In this module, we'll now build up on the practice app or on the shopping app we built in the last course module. So if you skipped the last course module, which you can, make sure you still download the finished code from there and you manually go through that code to understand what we're doing there. Also, of course, run the app on your emulators or real devices so that you, well, again, get a feeling for what's happening there and what we built there. Because in this module, we'll take this app and we'll now work on the user input part. That means we'll work on the part where users can add products and where they need to enter their own data. Because whilst fetching data with the text input component is relatively straightforward, as you will learn in this module, there is a bit more to it when it comes to validating that input, configuring the text inputs correctly, and using that user input. And these are all the things we'll have a detailed look at in this module. So for that, as mentioned, I'm back in the project we worked on. And of course, now the edit product screen here is what I'm interested in. This is the screen where I have these text inputs here with my labels and then the text input, where we currently have a very basic input handling. We are at least fetching the user input and storing it with the help of the React state with the use state hook. We're then feeding the entered values back into the input, and that's it. This allows us to capture and use the user input, but for one, we can improve how we do that. We can write this in a more reusable way, and we're not doing any validation whatsoever. So these are the things I want to change in this module. In addition, we also are not configuring our inputs in any way. That means that right now all text inputs are equal. We don't change the type of keyboard we're presenting. We're not offering multi-line input, for example, for longer texts like here for the description. None of that is happening. And therefore, let's actually start with configuring these inputs before we move on to validation and so on. One important configuration which you can add to your keyboards is the keyboard type. The keyboard type prop can be set, and there you got a couple of values available. Now you got quite a bit of values here, but the official docs are also a place which you should consult when thinking about the type you want to assign here. Because when you visit the official text input documentation, you of course see some examples, but then you also see all the props you have, and there you can learn more about each prop and how you may configure it. And for the keyboard type, for example, we learned that only these types are supported cross-platform. So whilst we have specific iOS and Android types available, these types can only be used together with a platform check so that you make sure you don't use a type on Android which isn't supported there and which therefore wouldn't have any effect. Hence, I will stick to the cross-platform types so that I don't have to add an extra platform check. And there, typically for, let's say, normal text, we would stick to default, which of course therefore is a type we don't have to assign. But that, for example, changes when we have a look at our price input. There I want to make sure that people only enter valid numbers, that they don't enter any text. And therefore, of course, I want to show the right keyboard to help them with this. And if we have a look at the official documentation, we see that there are three main cross-platform types of keyboards we can show: number pad, decimal pad, and numeric. And there, for example, decimal pad is an input which allows the user to enter decimal numbers, which is just what I want here for my price. So therefore, setting this keyboard type here makes a lot of sense, because now if we have a look at this price input here, and I toggle the soft keyboard, which you can do with the Command K shortcut here on iOS or with the hardware menu up there, then keyboard, toggle software keyboard, you see that now I got this decimal keyboard opening up here, whereas on the other inputs I have a normal text keyboard. And of course it's the same on Android. If we go to admin there and then have a look at the price, we also see that there we're presented with this number friendly input instead of the normal text keyboard which we get on the other input fields. So this is how we can configure this, and this is of course an important configuration. We can also configure other things. For example, here on the title input here, if you hit Control Space and you have a look at the auto completion, you see there are a bunch of things you can configure. For example, whether this should be auto capitalized. There you have different values which you can set. For example, that characters should be capitalized, only full sentences or words. And here I'll go for full sentences, for example, to help with capitalizing those. You also can turn on auto correction. And by adding it like this, you ensure that autocorrection is turned on for this input. By setting it to false, you could disable it, or by just omitting it, of course, that's also an option. And so on. There are a bunch of things you can configure, and I would strongly recommend, as always, that you have a look at the official docs as well to learn about the available configuration options and what they do. Also, simply play around with those so that you get an idea for what you can do there and what each option does and, well, what might make sense for your next application. One other value which I want to set, for example, is the return key type. This can be set to a couple of values, and again, if you check the official docs, you will learn that not all values are available on all platforms, only these 5 are available cross-platform. And there you can basically configure this button in the bottom right corner. If you have a look at your input here, and you click into any of the inputs, it's this button here in the bottom right corner which says return here for the image URL. Now on the title I set it to next, so if you click into the title field, you now see here it says weiter, which is German for next, and this is just because I have a German emulator here. And let me also restart this on Android because it crashed there so that I can show it there as well. If we go to our input there, click into the title, you see this next button here. On the image URL, you have this done button here, and that can be configured with the return key type, though please be aware that this only controls how this is displayed, what it says there, what's the label on there, or which kind of button is presented. It does not automatically change what this button does. For example, if I click the weiter button, this keyboard closes. The same is true if I click the return key here. Now, when we talk about behaviors of text inputs, then all the events we can listen to are interesting. With on, you get an idea of all the events you can listen to. For example, there you got on blur, which fires whenever an input loses focus. On change, which fires on every keystroke and gives you the full input event. On change text, which also fires on every keystroke, but only gives you the text which was entered, which typically is what you're more interested in though. On end editing, where we can also get an idea for when this fires. So if I enter on end editing here, let's see when this prints in the console. If I now go here to my input, and please note I'm on the title input, so if I type there test, we see it didn't fire here. If I click out of this, now it fired on end editing. The same is true if I click the weiter button here, for example. So basically, whenever we leave this keyboard with the focus, or in general when we click that done button there as well. In addition, we also have other listeners for like on focus, which obviously fires when this input gains focus, or also on selection change when we select text in there, or on submit editing, which is fired when this return button is clicked. So if I add on submit editing here, when I add this listener as well, and also that console log statement, you see that now this will fire whenever I type in here, does not fire. Whenever I click out of here, it also doesn't fire. We only got to get the on end editing log here, but it will fire if I press the weiter key here. There you see on submit editing. So this is a listener you would use to listen to when the return key is clicked, and then you can do whatever you want to do, like submit your data or automatically move the focus to the next input with the help of references, for example, if you want to. This is how you can configure this, and as I said, I would recommend that you dive into this to get a feeling for how this works. I now will move on, however, and I want to make sure that we don't just listen to inputs and store the values, but that we also validate what the user enters. Now, to validate what the user entered, I of course want to do something on every keystroke. Now, we already got on change text here as a listener on the title, for example, and what we do right now is we set the title in our state. Now, the next step is to not just do that, so to not just save the input, but to also validate it and also kind of manage the validity of this input in a state. So therefore, I'll add a new function here, title change handler, for example, which gets the entered text and then can do something, and I'll just outsource this into a separate named function to have a bit of a cleaner, easier to follow along code, because now I will bind this listener here to my onChangeText event so that this function fires for every keystroke. And there, of course, I will still set my title with that text, but now in addition, as I said, I also want to manage the validity. And for that, we can add another state which we want to manage. So maybe here, after managing the title value, we can also have the title is valid state or whatever you want to call it, and add set title is valid here as a setter function. And then this state here initially could be false, so that we initially treat this as not valid. Now, for every keystroke here in the title change handler, before we maybe store this and update our title state, we can validate this, of course. And now it's totally up to you how you want to validate this. Now, for example, you could say this is only valid if you have a text which is not empty. So if text length is greater than 0. Text is a string, of course, so if the length is 0, then this means that it's an empty string. We can also call text.trim to trim excess whitespace so that just a bunch of whitespace also isn't treated as valid. Of course, you could also add min or max length validation by checking the length here. You could add regular expression validation to check the text for certain patterns. It's actually something we'll do later as well. But to get started, I'll just check it like this. And now here, if we're greater than 0, we're fine. But actually, if we are having a length of 0, we're not fine. So here I want to set title is valid to false. Else we set title is valid to true, of course. So if we do have a valid input, and we'll always set the title itself. We always need to store that. We must never lose that user input, otherwise we break the app. And now with the title validity stored in a state, we can use it, of course, here in our JSX code to check if the title is not valid, for example. And if that's the case, we can dynamically output a text here, where we, for example, say, please enter a valid title to show a little error message here, which you, of course, also could assign some styling to. With that, you see that if we go to our input here, we see that error message right from the start, because we start in invalid state. And if we start typing, this disappears, but if I remove all input, it reappears. And this is some basic validation you could add to show a little error message or a little hint to your user to make sure that users get at least an idea of which kind of input you want. Now, of course, you can then not just use this validity to output error messages, but also to avoid that your form gets submitted if it's invalid. So here in the submit handler, where I do always submit my data and create or update a product, no matter if the input is valid, there we can use the validity data we gathered and, for example, check if title is valid. And if it is not valid, hence the exclamation mark, then we just return, which means we cancel the function execution and the code thereafter won't run. In addition, we might not just want to return. Of course, we can also import alert from React Native and throw a nice native alert here. So we can simply show alert with a message of wrong input and or a title of that and a message of please check the errors in the form, and then simply add one button there where we say OK, because there's nothing else to do then to confirm. Well, with that, we have a nice flow here where we warn the user that the input is invalid. So for example, now if I try to submit this input with my invalid title, I get this error. And only if I enter a valid title, I can submit it, because I haven't added validation for the other inputs yet, which we of course should. So this is how easy you can get started with validation. Now, since we used JavaScript here, you can of course also bring in other third-party validation libraries. Like, for example, Validate.js, which is a package you can install into your project and start using it to then easily validate strings for certain patterns if you wanted to do that. In this module, I'll write the basic patterns we use manually so that you get a clear understanding of what's really happening there, but you can absolutely bring in such third-party libraries as well. Well, and now with that basic understanding about validation and so on, let's make sure that we now actually also move towards a form and input management that is more scalable and doesn't involve tons of states which we have to manage manually. Our approach here, of course, works. We're storing the inputs in some state, we're storing the validity in some state, and we could do this validity management for all our inputs here and simply have our different change handler functions here for our different inputs. That would work. One important note, by the way, before we move on, since I checked the title validity here in the submit handler, of course, we should also add it there as a dependency. So title is valid must be added there as a dependency in the use callback dependency array. That's important. Otherwise, this function will not be rebuilt when that validity changes, which means we won't be able to submit it thereafter. The problem with our current approach is that we manage different states to store the input for the different inputs. And then we also have different validity states, at least potentially, if we start managing our validity like this. And for very large forms, of course, this means a lot of copy and pasting, a lot of state management. Now, if you have that many states that are kind of connected, you also can do this in a more elegant way. Instead of having your separate states for each input, you can have one big state which merges all input values and which merges all validities, and then use a concept called a reducer, not a Redux reducer, but one supported by React out of the box, to manage that state. You do this with the use reducer hook, which again has nothing to do with Redux. The concept of a reducer is not Redux exclusive. A reducer in the end is just a function that takes input and spits out some output. And therefore, React also supports this. And you'll see how you can use this in this lecture now. So what's the idea of a reducer? Now, first, it's important to understand that use reducer is a hook that helps you with state management. Typically, you use it if you have connected states or more complex state, and you don't want to have a bunch of individual use state calls and a bunch of individual states which you manage. You then can use reducer, and here's how it works. You start by creating a reducer. Let's say a form reducer here. You can name it whatever you want, and please note I created outside of my form component. You could do it in there, but if you don't depend on props, you can do it outside of there so that this won't rebuild with every re-render cycle, and you don't even have to use callback, which of course also costs some performance if you use it. So use it outside of there, build it outside of there to avoid unnecessary recreations of that function. And now that reducer, just like a Redux reducer, gets the current state and an action. But again, it's not related to Redux. It's not used by Redux. Reducer functions just always kind of work like this. Now in there, again, just like in a Redux reducer, because again, they work like this, you can check different action types. And here I want to check one type. This is well, just use an if statement. You could use a switch case statement as well. And that I check action.type here is totally up to me. You can name this whatever you want because you will be the one dispatching the action later. And here I check for the update action, which also is an identifier I chose, and which, just like in Redux, you could also store this identifier in a standalone constant here. So you could have your reducer update action here. For example, your reducer update identifier like this, and use this instead here if you wanted to. And you can name this whatever you want. So now I'm checking for this action. And if this action occurs, I want to store an input value and validate it. But to understand this, we need to understand how we use the form reducer. So let's leave it like this for the moment and go down to the component itself. There, we start setting up our form state down here. So here, I want to call use reducer. And now use reducer takes such a reducer function. Hence, I will pass in my form reducer, which I set up here and which is still unfinished. Use reducer also takes an optional second argument, which is the initial state you want to pass in. And that can be anything, but here I'll pass in a JavaScript object. And the initial state I want to use here is the ender object, which has input values, which then is yet another nested object, which I'll soon populate. Input validities, which also is a nested object, and maybe an overall form validity I'll name it form is valid, which initially is false, let's say. So this is now my initial state I pass in here, and that's the state which I later want to change from inside the form reducer. Now on the input values, we can, for example, add our title, and that is up to you how you name it, which is an empty string initially, let's say. These will be the initial values I want to set on my inputs, and this will in the end replace my state management down there, where I manually store my inputs in different states. Now I will merge this all into one object managed through that reducer. So I have my title here, and actually that's not always empty, of course, but actually it's only empty if we have no edited product. So I will copy this check from there and use this in here. Now the same, of course, for the image URL. There I initialize this with edited product.image URL if it's available, and otherwise I use an empty string. Basically what I did down there as well. And of course I do the same for the description. Here I want to check if edited product is set, and I use this description or set it to an empty string if it's not available. Now last but not least, we have the price, and there I always have an empty string because we either don't need it in the case of an edited product, then I don't care about its value, or we do need it, well then I want to initialize it with an empty value anyways. Now of course each input also has a validity. So we can add a title here, and again check whether edited product is set. If it is set, then I know I'm editing, so we will have pre-populated the title, so initially it will be valid. So in this case my initial value would be true, otherwise it will be false. And now this is also something we can repeat for the image URL. If we have an edited product, we know it was pre-populated, therefore it will be valid initially, so we set this to true, otherwise I set it to false. If I have for my description here, it's the same, true or false. And for the price, it's kind of equal. Of course, we don't pre-populate the price if we're editing, but if we are editing, I don't care about the price anyways because it will not be changeable. Therefore, I know if I am editing, I should treat this as valid because it can't be changed anyways, and therefore I don't care about this input. But I don't want to block form submission because of setting this to false when we can't edit it anyways. So I will set it to true if this is not planned to be edited. If we're not editing a product but we're adding one, the price will be editable, and therefore we will start in a false state because the price input will be empty initially. That's what we're setting up here. And now the overall form validity, well, there again, I can check if we have an edited product, which means we are editing, then the form is true, the form is valid initially. Otherwise, it's false initially if we're adding a new product. Now, this is my initial state here. Now, this reducer function should be able to change that state when actions are dispatched. And an action should be dispatched whenever we type into one of our text inputs. That will be the trigger. So therefore, we can now get rid of all these state assignments here, and hence we can also get rid of the entire use state import even, and make sure we dispatch the reducer update action for every keystroke we do in an input. So here in the title change handler, I in the end will remove this code. I'll leave the if check for now, but I'll not have any code in there for the moment. Instead, down there, I want to dispatch reducer update. And now this is done with the result of the use reducer call, because use reducer, of course, returns something, just like use state did. It also returns an array with exactly two elements, and therefore we can destructure it with this array destructuring syntax, which we also used on use state. And there I get my form state as a first value and a dispatch function as a second value. This is always what use reducer will return you. A state snapshot, which updates whenever you change it, of course. So whenever you change it, this component will re-render and give you a new state snapshot. And a function, dispatch in the end is a function, that allows you to dispatch actions against this reducer. Of course, you can name these two elements however you want, but I think this is a sensible naming. This is our state snapshot, this is a function. Now, dispatch, by the way, is a name I already use here from Redux. So here I will name this dispatch form state to avoid a name clash. You can name it however you want. So dispatch form state can now be used here in my title change handler. I just call it, and I need to pass an object there which describes my action. And this object will have a type property. You don't have to have a type property. You could name this ID or identifier or whatever you want, but I use type here because I actually do check for the type property inside of my reducer function. And this reducer function will be executed for every new action you dispatch. So if I go back down there, the type will be a reducer update, or maybe a better name actually would be form update, I think. So that's also what I'll use up here, of course, and up here. So form update, maybe form input update. The name, of course, is up to you, but it should be clear about what it does. So here I'll also have form input update. Yeah, that looks good. So form input update, that's what I dispatched down there. I need to change it here as well. And of course, you can also pass any other data you might want to use inside of your reducer. And I do have some other data which I want to use. That would be the value, and I'll just name this value here, this property. You can name it however you want. That's the text which was entered, so I just forward that to the reducer so that we can store it in our state there. And the validity of this input. So therefore here, I will actually add a is valid prop, which initially, let's say, is false. And now we'll remove this else case and check if we're greater than 0 here, which would mean that it should be true, because then I set is valid equal to true, otherwise it will stay false. With that, we can also add is valid as a key to the action and forward the value stored inside of our is valid variable. And this will be false initially, but if our input length for the title is greater than 0, then it will actually be true. And now we, of course, also need to let our reducer know which input triggered this. So I'll add a, let's say, input ID field here, or just input, whatever you like, and use title here. And this key here should be a key which you also have inside of your state, like here in input values and input validities. Because this will allow you to write some reducer code, which we'll do soon, that is highly reusable and highly flexible. Because now we can take the next step and make sure that we transform this to be a function that actually works for all inputs and that is really flexible regarding how we use it. So let's continue working on this, and let's change this to a, let's say, text change handler function, which we now assign to onChangeText here on the title, but which we also can add to our image URL. So here for onChangeText, I also set this to text change handler. And now for this to work, we need to make sure that this function gets information about which input it was triggered for. So whether you just typed in the title or in the image URL input. So besides getting the text, I also expect to get a different argument. I expect to get my input identifier or anything like that. You can name it whatever you want. So that this function can be reused for multiple text inputs, and we still get information about which input triggered this, so that we can forward this to our reducer, where we will later need this information to update our state correctly. Now, to get this input identifier functionality, we need to go to the places where we use text change handler, and there we can, for example, use bind or use a wrapping anonymous arrow function instead to bind this where I don't care about, but more importantly, to configure the arguments this function will get. And there it's one special argument which I want to pass, and that's the input identifier. And for this function here, for this function call on this text input, this of course would be title. For this input down there, we would have bind this image URL. And again, this should be an identifier which you also have in your state up there, in your form state, which you pass to the reducer. With that added, we'll make sure that the text change handler is executed and gets this input identifier argument. The text argument will also be received because that's the default argument which React Native would pass us anyways, and this will then automatically be received as a last argument in that function. So we don't have to, and we actually can't bind this here, it will be forwarded automatically. Now we have a reusable text change handler function here. We can assign this to the other inputs as well, like here to the image URL, like down here for the price. We can bind text change handler, bind this, and then price is our identifier here. And of course also for the description. There we paste this in, and then bind to this, and the identifier is description. Now this same handler can be used for all inputs, but right now, of course, it does one thing. It validates each input for its length. Now that might make sense, and it does here. No input should be empty, but you might want some other validation as well. For example, my price here should be a number greater than 0, let's say, so that 0 is not allowed as an input. That, on the other hand, is not some criteria that matters to me on other inputs. We'll find an elegant solution for that later. For now, let's stick with this smallest common denominator validation, which we can apply to all inputs to make sure they're at least not empty. And let's focus on the reducer function and how our form state should change when this form input update action with all that data is dispatched. Because right now, nothing will happen. We have our initial state on the reducer there, and that will be passed or stored in the form state, but this state will never change. Well, that's why we dispatch an action, right? That's why we do this here. This is why form input update is dispatched, and that is why we want to write some code here in the reducer when this action reaches us here. Now in there, if this action reaches us, in the end the goal is to make sure that we update this state snapshot, our current state snapshot, appropriately. This means that, for example, we'll need some updated values. For this, I create a new object because my input values here, that's an object, and it will create a new one to replace it. And it will first of all copy the existing state input values. Now keep in mind that the state here is passed in automatically. That's our current state snapshot before we update it. And therefore initially that's this state snapshot here, for example. And this will have an input values key, which in turn holds an object. And that's just what I'm copying here. I'm copying all the key value pairs of that input values snapshot. And then I want to replace the key value pair for the input for which this action was dispatched. The good thing is that we attach the input identifier to the action. So we can go to the reducer and dynamically overwrite a key here in the copied input values. The key is action.input, of course. That's our input identifier, which we attach to the action. And the value should be action.value. That's all we need to do. So we dynamically store the value that was dispatched with the also dynamically assigned input and update our copied input values. Now we can return a new state here because that's the goal of your own reducer. Like for the Redux reducer, in the end it has to return a new state snapshot. And there I want to copy the existing state, but overwrite the input values with the updated values, which copies my old values so that no data is lost, and then replaces one of the key value pairs in there. Now, obviously, it's not all to just replace the values or update the values. I also want to update my validities. So here are my updated validities, and just as with the values, I start by copying my input validities key, because input validities is a key here, as you can see. And then I want to replace one validity for the input which we get on the action, so title, image URL, or whatever it is, and replace this with action is valid because we get the information, whether that is valid or not, as part of the action that is dispatched, right? We're forwarding this here based on this basic validation we have here. Now with that, we just need to update this here. So our input validities here are equal to the updated validities. And now we just have to manage the overall form validity. For that, I add a variable, a helper variable, form is valid, which initially is true. And then I loop through all my updated validities, which are my old copied validities, and then the one updated validity for the input we just typed in. So here we have a for in loop where we go through all the keys in updated validities. And the goal is simple. I check every form input validity, and if all form input validities are valid, if they are all true, then the overall form is valid. If at least one of them is false, the overall form is false. The overall form is not valid. So therefore here form is valid is equal to the latest form is valid state we have, and then the updated validity for the input we're currently looking at, so for this key, and we're going through all inputs here. The way this Boolean operator works is such that false overrides true. So if any input is false, form is valid will be set to false and can't be set to true thereafter. So if at least one input is invalid, the overall form will be invalid, and therefore now I don't need to copy my state anymore here, well, because I will replace the entire state snapshot and set form is valid to my derived form is valid here. And of course, to avoid confusion, we could also name this updated form is valid here, and here, and here, and here. Now, just one additional thing, if we don't make it into this if block, so if some other action was dispatched or anything else, then I will just return the unchanged state here. With that, we added a reducer logic that is able to handle any input or any typing into any of our text inputs. Now we just need to use the form state, which will change with every keystroke, which is just what happened before, but now all centralized and merged into one managed state, which I think is way cleaner than having tons of different states for validities and values. And by the way, managing all these states manually and separately would have become a big problem when you then want to validate the overall form validity. So now we can use the form state, which will change with every keystroke, and we use it, for example, here on the values. We pass back in the value for this text input by accessing form state input values.title. And obviously, we do the same here for the image URL. We feed this back in, so just what we did before, now with our form state managed with the help of the reducer. Same for the price, of course, and also the same for the description, like that. Now, besides changing it here, we also have to change it in some other places. For example, here in the submit handler, of course. There, title is valid, this no longer exists, but we can check form state input validities title. That is true or false, and if it's false, it means it's not valid, so this check should be fine. Of course, however, we care about the validity of all inputs, so instead of just checking them all manually here by concatenating them into a long if statement, we can just check if form state form is valid is false, because that means some input is false, and therefore we show this error. That's the shorter check. And this is, of course, also when we want to avoid that the form gets submitted. If the form gets submitted, however, title, description, and image URL, that no longer exists. Instead, that's now form state input values.title and so on. So we do the same here for the description and for the image URL. We derive our values from the form state. Same, of course, here for creating. We get the title and the description and the image URL, and also, of course, the price, which I still convert to a number with the plus here. We get all of that out of our form state of the input values. Therefore, of course, our dependency here is not title, description, image URL, and so on. Instead, it's just form state. If the form state changes, which it will on every keystroke, then this function should be rebuilt. And it needs to be rebuilt because the information that's used by the function changes with every keystroke. The validity can change with every keystroke. The values you want to submit can change with every keystroke. We also can, of course, now use this to show our error message. Instead of checking title is valid, which doesn't exist anymore, we check form state .input validities .title. If that is false, then I want to show this text. So now with that, if we save all of that, we should be able to check this. If we go to our page here, we see this error initially. If I start typing, it disappears. If I try to submit this, it fails because I have 3 empty inputs. If I do enter something valid there, on the other hand, this works. If I try editing, let's try this on Android maybe to mix things up. So if I try editing the red shirt here, I can submit this just fine. Now let's also try submitting this if this is empty. Then I get the alert. So this works in the way it should work. Now with this more elegant form management using useReducer. And of course, you cannot just use useReducer when working with forms. This is just a particularly good example for when it makes sense to merge multiple states together and therefore have highly reusable and efficient code. Now, I'm still not done though, because all this code repetition with the inputs here, which are always structured in the same way, and the missing customization possibilities regarding the validation, these are the things I want to tackle next. So how else can we optimize this? Well, you might notice that this JSX code here in the end can be repeated over and over again. Every input looks like this. We have a view, we have a label, we have the text input itself, and we might also want some error text which we can display. So it would make sense to outsource this into a separate component. And that's exactly what I want to do. I'll go to my components folder, and there in the UI folder, I'll add an input.js file, which will hold a React component. So I import React from React, of course, and then import a couple of things from React Native. And these things in the end are my view, text component, the text input component, and the style sheet, because I'll need this as well from React Native. And with that here, we can create the input component here, which gets props and needs to return some JSX. We'll have a styles object with style sheet create. And of course, in the end, we export this as a default here, this component. Now, if we go back to the edit product screen, we can cut this title JSX code, so the surrounding view, the text input, and this error message part, cut it out of here, out of the edit product screen, and move that into the input screen, and there use it as a return value in the input component here. Now, of course, we'll need to adjust this a little bit, but that's our general skeleton, which I want to use there. Now, also from the edit product screen, I'll take the styling. There, this form control, label, and input styling can all be removed and should be moved over into the input component and there into the style sheet. So now with that, of course, this only can be used for a title, and I want to create an input component which can be used for any input. That, for example, means that the label here needs to be dynamic. So I'll expect to get this on a prop named label, maybe. I also, in general, want to make sure that the text input can be configured from outside. So I will forward all props I get on my input component here to the text input, so that on this input component, we'll be able to set things like the keyboard type. Because I don't want to hard code this in here. Instead, this should be a reusable wrapper around the text input component, which can be configured from outside. So these settings here, for example, I will cut them from here so that we can set them from outside. I'll also get rid of these listeners because we don't really need them. The error text here should also be settable from outside. So we'll check for props error text here. And of course, you can, as always, give these props any names you want. Of course, we'll also have to change what we assign here as a value and so on. That will also change. But now we can already start using that input here. Let's go to the edit product screen. And there I will just go to the top and import input from the components folder, of course, and there from the UI folder and there from input. And then we can start using the input component in the place where I previously had my text input component here. So there I will just add input. And now on input, we can add the setting which I cut, like the keyboard type and so on, because it will be forwarded. We can set our label, like title, and also our possible error text, like please enter a valid title. Though that's not all we'll do regarding validation, but it's a start. This is how we can then use this input. And of course, this is also how I can now use it to replace the other inputs. So for example here, the image URL. Here I set this to image URL. Please enter a valid image URL maybe. Keyboard type default is okay. Auto capitalization, auto correction is not required. Return key type next, we can leave that. We're not doing anything with it. We could add some logic, but I'm not doing it here. For the price, I'll leave the conditional rendering, but in there, I can add my input here. Set this to price. Please enter a valid price. Keyboard type here should of course not be default, but decimal pad. Don't need auto capitalization on auto correction, so let's get rid of that. And for the description here, I'll also add my input here. Description, please enter a valid description. Keyboard type can be default. I can use auto capitalization, auto correction. However, I'll not set a return key type, but here I want to set multi-line, just like this, which allows for multi-line editing, and set number of lines to, let's say, 3. This, however, is only used by Android, but there it will restrict the number of lines you can enter. On iOS, this will not have an effect. But this is how you can now use this input component and still configure it from outside. That being said, as I said, we're not done though. What about the value and this change text listener? There are different ways of how you could handle this text input or the text values here. You could still simply forward it to the parent component and only use this input component as a visual wrapper. But I will take it a bit further, and I want to manage this value and the validity of this single input inside of the input component, so that I then only report back to my parent component, so to the added product screen in the end, what the current value is and whether it's valid or not, so that the validation doesn't need to happen inside of the parent component. But again, that is totally up to you whether you want to do that or not. Here, I will add a new constant in the input component, text change handler, where I get this entered text, because that's now what I bind, or what is already bound, and I will generally keep it like this, though we don't need the identifier here anymore. Don't need bind, therefore, because, well, this is inside of a single input. We don't need an identifier there. This will now, therefore, trigger on every keystroke, and hence now here, I want to check whether this is valid or not, and also manage my value of that input. Now for that, we can again use a reducer or individual states managed with use state or created with use state, but I'll go for a reducer. And here I have my input reducer, name is up to you, gets a state, gets an action, and returns a new state in the end. Then here in the input, I can call use reducer and forward or set this to the input reducer. And my initial state for this input here will be a simple JavaScript object with 3 values. The value which we currently have, which initially can be empty, but actually I want to allow myself to set an initial value from outside because we will need this, for example, when we're editing products. So I check whether props initial value is set. Again, this is of course a name you can choose however you want. And if this is the case, I'll set this to props initial value. Otherwise, I'll set this to an empty string. Then I will also manage whether this is valid or not. And there, again, I can check if props initially valid, let's say, is set. If that's the case, then I will automatically take that value, which should be true or false. If it's not the case, this will automatically be treated as false. And I will also manage whether this has been touched yet or not, so whether the user did actually type here. And this can be useful for helping us with providing a better user experience regarding when we show validation errors. And here I will set this to false initially. Now, of course, this will return us the input state snapshot and a dispatch function, which I here can also name dispatch because we'll have no name clash. And in the text change handler, of course, I will dispatch an action which I therefore will create here with an action identifier, input change, for example. That should be dispatched here, type input change. And then here in the reducer, we can add a switch statement to mix things up, check the action type. And for the case input change, we want to do something. In the default case, I will just return my state. So I will not do anything. But here, of course, I want to do something else. Now here in the text change handler, obviously I dispatch input change and I want to forward the value, which I store in a value key. But now here I also want to do input specific validation and forward the information whether the input is valid or not. And for this attached, you find some validation setup or some validation code, which I'll now walk you through. Here I have a constant that sets up an email regular expression, so a regular expression that allows us to validate email addresses. We have no email address input yet, but later when we add authentication, we will have that. And then I want to be able to use this input component. So then this component should be prepared to also validate emails. Then I have the isValidHelper variable here, because then we have a bunch of checks here. Now I want to make sure that we can set the criteria we want to use from outside with the help of props. So for example, I check if a required props is set, if that's set to true, so if it's set at all. And if that is the case, then this check will be performed. If the required prop is not set, this check will not be performed, and therefore this validation is not performed. And that's the case for all my different validations here. So we can set a required prop to check whether it's not empty. If it is empty, we set isValid to false. We can set an email prop on the input component to validate it for being a valid email address. If it's not, we set it to false. We can check a number for being too small or too big, or a string for being too short with the min length validator. And of course, you could add more logic here, possibly also with a package like validate.js, which I already mentioned earlier. Now with that, I will have isValid in the end, which is true by default, but false as soon as one validation fails. And therefore now we can add isValid to this dispatched action as well. Now with this action being dispatched, we can go to the reducer and write some code here in input change. And that's very simple code. We return a new state where I copy my old state, and I want to update the value with action.value, because value is one property I have on this action, the other is valid. And that's the other thing which I also want to update on every keystroke. Is valid for this input, not for the entire form, but for this input managed internally. I'll not update touched here. Instead, touched should be updated when we actually lose focus, because that means the user is done entering content for the moment. So now I want to mark this as touched and possibly show validation errors. So here, lost focus handler is a function which I add, and there I will dispatch an action. Now for that, I'll create an action identifier up here, input blur, like this, input blur, like this. And now we can dispatch input blur here. Don't need to attach any data. And now in our reducer, we can use that with another case, input blur. And if that is the case, I return a new state where I copy the old state because I want to keep value and is valid and not change that. But I want to set touched to true. So as soon as we blur an input, it is treated as touched. Now we just need to hook up this function. So we'll set the onBlur listener here and point at lost focus handler so that this triggers when this input blurs. Now that is all nice, and this will manage the state inside of this input. Of course, I still need to forward the value and the information, whether that input is valid or not, to my parent though, so to the added product screen. Hence, what we can do is we can add useFact here as an import in the input component, and maybe add it here. And in the useFact function, I want to call a function which I expect to get via props, maybe on input change, name is up to you. And I will just execute this and forward my input state value and my input state is valid information. So that in the parent component, we can add a function here that listens to that in the end, that is triggered, which receives these two arguments. And then in the parent, so in the screen component, we can update our state there. Now the important thing is, when should this useFact run? And it shouldn't run after every keystroke. Instead, this should run whenever our input state value or is valid changes, of course, because that's what we depend on. Or to be precise, we might even only send this information if input state touched is true, because otherwise the parent component might not care. So now our dependency here is the entire input state, because we use all values, but we still will only fire this function on the parent component if touched is true. So this effect will run more often, but most of the time it won't do anything as long as touched is not true. And props, of course, also are dependency. Now, to avoid an infinite rendering loop here, we can use the object destructuring syntax and pull out on input change, so that if other props change, we don't refire this effect, because on input change is what we need down there. And now we can add this as a dependency, and the other things, other changes in the props will not trigger this. So now we call this on the parent component whenever this is touched, and then we forward the value and the validity of this input to the parent component. So let's now make use of that in the edit product screen. There, on our inputs, like on the title input, we can add the on input change prop. And that's the prop which I target here, right? So you need to get that naming right. And this expects to get a function as a value, which then in turn will receive two arguments when called, the value and the validity of that input. So here I want to point at a function, and that can be our, let's say, input change handler. We can recycle this. I just rename it to be more fitting. So the input change handler can be triggered here, like this. There, I want to still pass in my identifier because I want to reuse that for all my inputs. And now, since I'm in the screen component, we will have multiple inputs. And there, we therefore get our identifier. And then we get the value and the is valid information, right? So input value and input validity. That's what we get, right? Because that's what we forward from inside the input component here. That's what we pass to this on input change function. So therefore here we don't need to do validation. We just need to forward that information. We forward the input value. We forward the input validity. And this will only happen when the input is touched, by the way. So when it loses focus. And of course, that's just a restriction I added here, that you need to have lost focus. You could, of course, also go to the input component and remove this if check to update the validity and value in the parent component for every input, for every keystroke. Now, one additional thing which I want to do, I want to wrap this in a use callback call here, so that this function isn't rebuilt unnecessarily, because keep in mind that we pass this function to on input change in the input component. And there, on the other hand, this is a dependency of this effect. So this effect will rerun whenever this changes. So it shouldn't change too often to avoid unnecessary effect runs. And here we therefore need to state our dependencies. And the only dependency we have is dispatch from state, form state, which will actually never change. So we're good. This should never rebuild because the logic in there doesn't change. We get all values that we need as arguments. With that, in my edit product screen, I still have my form state, of course, with all the form values and the form validities, but I only manage this here because I need to submit it later and because I need to derive the overall form validity. I don't do it because I need to manage every input here. We do that from inside the input component instead. For submission and so on, we still need the information about every stored value, however. Now, if I go back to the input, don't forget that you also need to set the initial value prop and whether this should be initially valid. So if I go back to the edit product screen, now we should set initial value here to what? Well, we can check if we have an edited product, and if we do, then the initial value here should be edited product.title. Otherwise, it's an empty string. And this should be initially valid. So use this prop here if we have an edited product. So if this is, with the double bang here, if this is true. If we have no edited product, then this can't be initially valid. So then I pass false, which is good, which is just what should be the case. Now we can copy these 2 lines also to the image URL. There, of course, we forward the image URL value as a default value. Other than that, it can stay like it is. For the price, we'll never have an initial value and it will never be initially valid. For the description, on the other hand, we can again add this and here point at description. Now with that, there's one thing I need to fix in the input component, which I also just thought about. Of course, here, the form state is not available anymore. Instead, we have our internal state here, and I named this input state. That's what my reducer returns. So we should use that here, of course. So here we have input state dot value as a value. It's as simple as that. And here we have input state dot is valid as a check. And that should be all. Now if we save this and have a look at this, let's see whether that works. If we go here, we have all the error messages initially, which makes sense because they're all invalid initially. If I start typing here, I get an error. Can't find variable is valid in my input component. That has to be in that handler that fires for every keystroke. Probably here, yeah. In the reducer, of course, I should check action dot is valid, not just is valid. I have to get this from the action. So with that fix here, let's go back and let's try this again. If I start typing, this is cleared. If I revert this, my error doesn't come back though, so that's a little error we'll have to fix. For the price, 0 is not treated as valid. 1 also isn't, so validation has some issues, but entering and so on works. But let's see what's wrong with validation now. Well, of course, the way validation works here, we're not using it. Please keep in mind that I always check whether this type of validation is enabled for this input, or this type, or this type. And we do this with the help of these special props which we need to set. Right now, no validation is enabled, so only the default invalid values are taken into account. So if I go to the Edit Product screen, we now enable this special validation by setting the right props. For example, here on the title input, required. On the image URL, also required. On the price here, required, and also maybe min equal to 0, so that 0 is the minimum number we have to enter, or a number greater than that actually. So maybe 0.1 is our minimum number. For the description, should also be required, and maybe also min length equal to 5 to have at least 5 characters. There also is one additional thing we need to do here in the Edit Product screen. This onInputChange handler here also needs to be added to every input, of course, not just to the title input. So we need to add this for the image URL, otherwise we'll get an error later. We'll need to add this here to the price input. We'll also need to add this here, obviously, to the description input and replace the identifier in the right way. So let's test this, and you'll notice something strange. If you type here, that works. If you type in the image URL, doesn't work, right? The validation doesn't update. And you can't go back either, or at least this might be stuck. So if we reload this with Command R or double pressing RR on Android, and we give this another try, here, let's say on the price, you'll notice, this works. But why doesn't it work? And the same would be the case, by the way, if you tried it on the image URL. Here, this works. Why doesn't it work if I previously edited another input? Because now, for example, it doesn't work on a title anymore. And the problem is related to this being stuck here. We're re-rendering this component way too often. And the reason for that is really hard to trace down. In the end, we have kind of an infinite loop here. The problem is our input change handler. We're using callback here to avoid unnecessary recreation, but by then binding it like this, we kind of render this obsolete. It's making no difference now, because this will create a new function binding for every re-render cycle. So in the end, what we have to do is we have to remove bind here, remove it here in all these places, because this will break our app. It will cause too many re-render cycles because of use callback not having an effect. And instead, we might want to forward an ID prop of title and so on to our input component. So let's add this on all these inputs. This ID prop is basically what I added in the bind call before. So we just forward this to the input component so that we can use it in there. Let's do this for all these inputs here. And now how can we use that? Well, inside of the input, we now have this ID prop available, right? So now there we can simply attach this. So here we can forward props.id or simply ID so that we don't have to add props here, and instead pull out ID out of props here, just as we did it with onInputChange, and add ID as a dependency of this effect thereafter. And now with that, we still forward that identifier of this input, but in a more elegant way that avoids using bind, which in the end recreates this function for every render cycle and hence leads to an infinite loop. And therefore now if we reload this, and we go to the admin section here, now I can enter something here, and also here, and now this works because now we avoid this infinite render cycle, and we get the validation as we wanted. So now this is my approach, or this is the approach I wanted to show you here, which you can use to have a reusable input component which does its own validation, which you can configure from outside, and where you can still manage the overall form. With that, let's dive into some fine-tuning, like for example, styling this error message we're displaying, this validation error message, and also controlling when we display it, because I don't want to show it all the time. So for this error message in the input component, we're getting the text from outside, but I want to control the style from inside. So here in the end, I will wrap this text here in a view component, simply to have more styling options, you could say, and assign a style here of error container maybe. And on the text itself, I'll assign a style of error text. But these identifiers, as always, are totally up to you. I also don't always want to show this if it's invalid, but instead I want to show it if it's invalid and this input has been touched. That's why I'm managing this touched state, so that the user at least has a chance of entering something before I yell at him. So now error container and error text can be added. And of course, you are totally free to style this in whatever way you want. I'll give the error container a margin vertical of, let's say, 5. And then for the error text here, again, up to you, I will assign a font family of Open Sans here, a color of red maybe, and a font size of 14 to have it a little bit smaller, or 13. And now with that, what you'll see if this reloads, and let's test this on Android as well, of course, not just on iOS. So if we wait for this to load on Android, there, if we go to admin, and unfortunately the Android emulator is a bit slower, which is why this takes a bit longer, and we add a new product here. Now, first of all, if I try to submit it like this, I get an error, as it should be the case. And if I start entering here, I can do that. However, please note that after I touch the image, input, if it's invalid, I get an error. And that's exactly how it should be the case. So I can enter all of this. Now we have another issue. My keyboard is overlapping the description input, so we'll have to fix this. But first of all, let me enter something valid into all the other inputs. Even if it's an invalid image URL, we're not checking whether it's a valid URL here, just whether it's some text at all. So I don't care about the exact URL validation here. Of course, you could add a regular expression check for this. But now I'll just enter some valid input into all these fields. And thereafter, if I hit save here, this is saved and also can be found here at the bottom. And I did create 2 here, 1 behind the scenes, but this is where this is coming from. Let's now make sure that we can also reach all inputs. And for this, back in the added product screen, I'll use a component which you already saw earlier in the course. I'll remove these 2 imports, which we don't need anymore, and instead add the keyboard avoiding view to make sure we can always reach all our inputs. And now this keyboard avoiding view here can be used in the added product screen and can be wrapped around our scroll view like this. around the entire scroll view. And there you might now want to play around with how you configure this regarding the behavior. You can also use the platform API to use a different behavior for different platforms. I will try padding here and add a keyboard vertical offset of, let's say, 100 to add a lot of padding so that we really move up all the inputs quite a bit, because they're rather large. We have a label, we have the input itself, which isn't super small, so I definitely want to move it up quite a bit. And in addition, and that's important, you need to add a style here, and I'll quickly add an inline style here. Of course, you could also use the style sheet, and add flex 1 here, and that's super important. You need to add this to the keyboard avoiding view, which you wrap around your scroll view, to have an effect, because it basically needs to reserve for itself the entire screen size. There is a scroll view in there, and that will still be able to scroll, but you also need that. And now with that, let's give this a try on Android, but since this takes a bit to load, I'll also quickly have a look at iOS. And there you see you still can scroll. Unfortunately here, the keyboard isn't even close to our description. By the way, we can add multiple lines there as well, as you see. But now let's have a look at our Android app here. Go to the admin section there. And in there, if I go to my description here, you see this is now moved up. If I'm in the image URL, typing some stuff there, and I click into description, this is reachable now. So now with that, we make sure that we can always reach all the inputs, which of course is important in an application. You want to make sure that you can reach all your inputs. We're validating the data, we're saving the data, and we're doing this in a highly reusable way. So we worked on these forms here, or on these inputs, where we can fetch user input for adding new products. And that, of course, is a core thing you'll probably have to do in any application. Now here I showed you all the nitty-gritty details it takes to set this up from scratch on your own, and of course this is only one possible approach. You could have managed all the state individually with multiple use states in one component. Here instead, I use reducer and this merged state to have all the state that belongs together, and I use a separate component for the actual input and its label and the error text and the validation of this input text. And of course, that's also just one possible pattern. Now, in production, of course, you might not want to reinvent the wheel all the time. So instead of writing all that validation logic manually here, as I mentioned already, you might want to check out solutions like validate.js, which gives you pre-configured validation patterns and functionalities so that you don't have to, add your own email regex and so on. You can also look into packages like Formic, which is a third-party React package that also works for React Native, which makes adding forms and validating forms even easier. And you can check out the official docs to learn more about it, and to also learn how to use it in React Native apps, because you'll find a description about that there. However, I found it more interesting to show you what happens behind the scenes and how you can set up something like this from scratch, because ultimately this course is about becoming a developer and not about becoming a copy and paster, I guess. So I hope this was helpful for understanding what's happening behind the scenes, how you can manage validity and values elegantly and in a reusable way. And we will also reuse the inputs later in the authentication section once we also add an authentication screen. And there we will then also see how easy it is to add yet another form to this application. It's now time to leave our local device, at least to a certain extent, because whilst of course we will work a lot inside of our app, so we as a user, not all data needs to be saved on the device, and right now we're not saving any data anywhere, to be honest. We're saving everything in memory, which means that when we, for example, add or edit a product in this dummy app we built thus far, it's lost whenever the app restarts. It would be better to save such data on a server in the web instead of just on the device in memory, because that would persist app restarts. We can simply load the data from there when the app starts. And in addition, for most apps, for example, for a shop app like we're building it, You also want to share data across different users, across different app installations. So if I add a product, other users should also be able to view it. And therefore, we definitely need to store data in a server so that we can all operate on the same data. Now, for that, I'm back in my code, and first of all, we need a server. Now, I won't write my own server-side code, because this course, of course, is not about server-side technologies like Node.js. Instead, we can use Firebase, which is a free-to-use service, or free to get started at least, where we don't need to write any server-side code to still get a server-side API we can work with. For that, you just need a Google account, and with that, on firebase.google.com, you can go to that console, and there create a new Firebase project. Simply click on Add Project there and give it any name you want, like RN Complete Guide, any name you like. Set this checkmark here and create the project and wait for this to be done, which will be super fast. Now, getting started with Firebase won't cost you anything, and you don't need a credit card to get started. Check out the Firebase pricing documentation if you plan on using this in your production-ready application, of course. So this was created, and now we're taking to this newly created app, and Firebase actually has a bunch of services. It's a fully managed backend, which we all won't need. I just need the database there. And that's important, by the way. Firebase sounds like it's a database which we connect to our app. Actually, you never directly connect a cloud database to your application. Instead, your application will always communicate with an API, typically a REST API, which then in turn talks to a database, because directly setting up a connection would be insecure. So that's how we'll do it, and Firebase will give us both a REST API and then a database to which that API talks behind the scenes without us writing any query code. Still, we need to enable that database by clicking on database here, and there make sure you scroll down to the real-time database and you click create there. Real-time database, not Firestore. Instead, use the real-time database and, important, start in test mode, which makes sure that the rules, the security rules, are set up such that no authentication is required. We'll change that later to require authentication, but for now we have no users, so we will start like this. Now, this is later where you will see your data which you write to Firebase and its database, and this is the URL or a part of the URL you need to send requests to store data there or to fetch data from there. And the cool thing about Firebase real-time database is that it kind of gives you a database hidden behind a REST API, where you can target dynamic REST API endpoints, which will then automatically be translated to write or update requests on your database. So it looks like you're directly talking to the database, but you always will talk to a REST API, and then your incoming requests are kind of automatically translated to database queries, you could say. This, however, is the URL, or an important part of the URL we will talk to, though. So with that, this is the URL we will talk to, and why don't we start with making sure that we can actually create new products and store them there, so that when I submit a new product, we don't just save it here in memory, but we actually send a request to Firebase to store it on its servers. And that's exactly what I want to do here, because to me that makes a lot of sense. Now for that, I will install one extra package in this project with npm install --save, and that's Redux Thunk. That's a so-called Redux middleware, which we can call, which allows us to change our action creators here in the actions folder, such that we can actually do asynchronous stuff there, that we can handle side effects there, so that we can, for example, send HTTP requests in such an action creator, and only once that HTTP request is done, we're actually dispatching an action to the Redux store. Because that's important, your Redux flow in general needs to be synchronous, so you can't wait for some action to complete before you update your state. With Redux Thunk, that changes. Your reducer still needs to be synchronous, so no async code must be in here. But your action creator can now be asynchronous. This means that you now can send a request as part of your action creator, and only once you're done with that, you actually dispatch the action to the reducer. And you'll see this in practice in a second. For example, here in Create Product, which is the thing I want to start with. However, to use this new feature, we have to enable Redux Func, and we do this in the app.js file. There, from Redux, you need to import apply middleware. And in addition, you need to import a new thing, and that's Redux Func. You can name this however you want, from Redux Func. Again, this can be named however you want because we're using the default export of that package. Now you use that in create store. There you can pass a second argument, and there you should call apply middleware as a function, and to that function pass Redux Func. This will now basically enable that package, which in turn allows us to, well, do this different thing in the action creator I was referring to. And that different thing is now what we'll have a look at next. So in the create product action creator, which currently is a function that just returns an action, we can now tweak this a little bit. Instead of returning an action, we can now return another function in there, thanks to Redux Func. Thanks to this package, we can do this now. And this will be a function which receives the dispatch function as an argument, and then in turn needs to dispatch an action. So in here, in this return function, I now simply need to not return this, but dispatch this action. That's the important difference. And I'm missing a curly brace here. So what happened? I changed create product to be a function which we actually still can dispatch from inside our components, but which now can still work as before, so we don't need to change all these action creators. So you can stick to the old syntax, but now thanks to Redux Func, an alternative syntax, so to say, is also supported, where this action creator function does not immediately return an action object, but instead where it returns a function. And if it does, Redux Func will step in and make sure that everything still works. And if it returns a function, then this is a function which has to receive an argument, the dispatch function, which will be passed in automatically by Redux Func. So Redux Func will in the end call this function for you. And then therefore you can then dispatch a new action, and here dispatch the actual action object, which we previously wanted to dispatch. But before you do that, you can now execute any async code you want. And that will be allowed and will not break your Redux flow because Redux Func will take care about this. And you can learn more about this in my React course, for example, or of course in the official Redux Func documentation. Also in the official Redux docs, actually. So now here we can send a HTTP request, and in React Native we can use the fetch API, which is built in. And fetch here works basically like the fetch API in the browser, where this also is available. It takes a URL you want to send a request to. And that's this URL we got here. So I'll just copy that URL from Firebase and enter it here. Now fetch sounds like it always just fetches data, so if it gets data, but actually the name is a bit confusing here. It's not just used for getting data, you can also use it to send a post request or a put request, so any kind of HTTP request. Now also we don't just send a request to this URL, but now as I said, Firebase translates your requests to kind of a database query and a database structure. So you can add any node you want here, any segment you want, like for example products, and Firebase will kind of create a folder here in the database and store your data in there. Important, and that's just a Firebase specific thing, you need to add .json here. So that's not required because of React Native or because of JavaScript or because it's a HTTP request. This is just a Firebase specific thing. By default, this would send a GET request, but to store data, Firebase wants a POST request. And to send that, we have to pass a second argument to fetch, which should be a JavaScript object. In that second argument, you can set up the method key and describe the HTTP method of this request. And that can be get, put, and so on. And here it should be post, which adds this product we're about to send to this node, which will be created there. Now you also can set up some headers there, and we need to set a header. We need to add the content type header, and you simply add headers as an object and then have key value pairs with your header identifiers as keys and the values as, well, values. And here the value is application/JSON to let Firebase know that we're about to send some JSON data. And then we need to do that. We need to add a body with the data we want to append to this request. and the data should be in the JSON format. Thankfully, React Native supports the JSON object, which browser-side JavaScript also supports. And there we can call stringify to turn a JavaScript array or object into JSON format, so into a string in the end. And there I want to, well, append my product. So in the end, I want to stringify an object here, which holds my title, my description, my image URL, and my price. Not the ID, because actually Firebase will generate an ID for us here, which is really convenient. Now this will send the request, but of course I only want to create the product locally if that request succeeded, because then I can actually also use that automatically created ID, which Firebase will return to me. And fetch conveniently returns a promise, which is this JavaScript object that will eventually resolve to a value in the future or throw an error in the future. So to wait for this response, we can then add then here after fetch, so on this promise, and we'll get our response here so that we can do anything with the response. You can also listen to errors with catch, and that's something you should actually already know because promises are not React Native specific, that's vanilla JavaScript. And React Native also supports the more modern async await syntax instead of then and catch. To use that, you add async here in front of your function, this async keyword, and now you can await your response here and store it in a constant with this syntax, with the await keyword. Now behind the scenes, this transforms this to the old syntax with then. So this is like if you added then here and you used your response in a callback you got there. But this is a bit easier to read, which is why I will use this async await syntax. Just be aware of the fact that this is like adding then. It's just more readable. When you use async await, by the way, this function here always will automatically return a promise. Therefore, this entire create product function now returns a promise. It didn't do that before, now it will. You see that here, it now returns a promise. So that's our response. This response now can be kind of unpacked to get the data in there. So the response data, that's done by calling response.json. That's a method which is available on that response object we're getting. This again is an async task which we have to await for. And now this will in the end give us the data returned by Firebase when we add a product. Now we can for now simply log that response data to see what's in there, and I still dispatch my action here, but since we have a wait here, and therefore this is like it was in multiple then blocks, this will only be dispatched once these operations here are done. So with that, let's save this and let's add a new product by going to the admin section here, and then I'll add a white shirt. I picked a nice image URL for that. Here it is. Let's say that costs $39.99. This is a white shirt, which is pretty stylish. If I now save this, whoops, need to blur this first. Now this is added, here it is. And now if you have a look at Firebase, we also see that there now is a products node. In there, this is this unique ID, and in there we have the data we submitted. And if you have a look at your console, you see this is what we got back. That's this response data here. This holds a name key and then also holds this ID which Firebase generated. This means that when we dispatch our data here, we can actually add an ID key here and add restdata.name to access this name key on the response returned by Firebase to forward the server-side generated ID to our create product reducer in the end, or to the logic that runs in the reducer. So now in the products reducer, we can actually not use this dummy ID here, but instead expect it on our product data. There we now get an ID field, which is the server-side generated ID. I will stick to the dummy user ID for now though, but we'll get this server-side generated ID here, and here it is, and therefore we use this on the front end as well, which will be important for later when we also delete stuff and so on. So this adds a product, but of course as soon as we reload the app, it's gone, because in the app it was only stored in memory. Now we also store it on a server, but we're never fetching it from a server. So let's make sure we do that as well. So storing is great, fetching would also be sweet. And in the end, I want to make sure that when we, for example, visit the products overview screen, we simply reach out to the server and get all products from there. So that on this screen, whenever we visit it, we load the latest products. Now for that, we need to send the HTTP request from there. And therefore, in the end, what I want to do is I want to dispatch a new Redux action, which will reach out to the server, get my products from there, and then set the products in my store. So I need a brand new action here, set products, which I didn't need before because we only worked with dummy products, but now that's not the case anymore. So set products should now be dispatched. And I will need a new action creator here, which I'll name fetch products. For this, I have no identifier because I will never dispatch this as an action which should reach the reducer. Instead, this will just be my action creator with the async code, with the HTTP request. It will not need any arguments, but thanks to Redux func, it returns a function which gets that dispatch function as an argument. And there, in the end, I want to dispatch an action object where the type is set products and where I want to forward my products. But of course, that should not be an empty array, but the products I get from my API. So we can therefore kind of copy this code here, including the async dispatch part here, all the way up to there where we get the response data, copy that from create product, and replace this part here with it. And now what we do is we send the request to that same URL as before, which makes sense because that's where the products are stored. However, now I want to set a GET request, and that's actually the default when you use fetch, so you don't need to set this. For a GET request, you also don't need to set any headers, and you can't set a body. So actually here, we can entirely get rid of this second argument on fetch. We just send a fetch request like this. Now the response will get back our data, but now there's one important characteristic about the format of that data. And it's best if we simply see that. So let me console log the response data here and comment this out for the moment, or we can leave it in there. It doesn't do any harm. It doesn't do anything useful either. We're not handling this in the reducer yet. But let's log this. And let's now go to the products overview screen and make sure that there we dispatch this fetch products action. Now, thankfully, I already get access to the Redux dispatch function there in products overview. So now I just need to add use effect so that I can fire this whenever this component loads. So here I can add use effect, and in my function here, I can call dispatch and now reach out to my product actions, which I therefore need to import as products actions from store actions products like this. Whoops, that should be actions. And now use the product actions here to fire my fetch products action, which in the end will make this HTTP request. And this effect should run whenever my component is loaded. So I can add an empty array and actually add my only dependency which I have, which is dispatch. Here, that's the only dependency we define inside of our component. So that this will actually never rerun. The only time it will run is when this component is loaded. And that's exactly what should be the case. Whenever I visit the screen, I want to fire this effect here. So if I now save this, let's save this. And now as this loads, you see here in the log, this is what happened here. And both on Android and iOS, which is why I see this twice. This is what I got back in the end. This object was returned by Firebase. It's an object with all my products, and I only have one, which is why I only see one here. And each object is matched to its unique ID. But that's important. We don't get back an array, we get back an object with the unique IDs as keys, and the values for these keys is then my object data. And we just need to know that for handling it correctly. So back in our action, this is how the response data looks like. Of course, in my app, I work with an array though. So I need to transform this. So my loaded products, or however you want to call this here, should be an empty array. And now we can loop through that object to map the object data, the products in the object, to, well, products in the array. It's relatively straightforward to do. We can add a for in loop here with our key where we go through all the response data we fetched here in the end. And then here I add each product to my loaded products with push so that this array grows over time. What I add here in the end is just a new product using the product model, which you therefore need to import. So make sure you have that import here pointing at your models folder and there at the product file. And I create a new product here where my ID is that key, because that is that unique ID here, which we have in that object through which we're looping. Then that user thing, well, that is U1 still, dummy data, because we have no user data involved here. And then we have to look into the object we got back from Firebase to get the title and so on. So here our title for this new product we're creating is simply res data for the given key dot title. And the same, of course, here for the image URL. So dot image URL for the description. And of course also for the price. Like that. So this adds everything to loaded products. And now loaded products will be a populated array, which I can add here to the action that is dispatched, to the set products action. So the only missing thing is that we now go to the reducer, and there we can handle set products. Maybe here is the first case, but of course the position doesn't matter. Add set products here, and for that make sure you're importing it from your actions file. And then there, it's a very trivial thing which we're about to do. In the end, I just need to return a new state where the available products are equal to action.products. So to the products I derived here in my action creator, which I add to my dispatched action. And for the user products, it's pretty similar. There, it's action.products just filtered for all the products that have my user ID. So like that. And at the moment, due to my dummy code here, where I hard code my user ID, that of course means that all loaded products are treated as my products. This is something we'll change later once we added authentication. So with that, now if this reloads, you see we start with the dummy data, but then this is immediately replaced with this loaded data. So loading data works just fine. We can work with that as we could with our own data here. Of course, we're not storing orders on the server and anything like that, but we are able to load our data which we previously stored on the server. Before we continue with updating or editing the data or deleting it, let's also make sure, however, that we don't see the dummy data here initially, but that we actually see a loading spinner and maybe also a message if there is no data to be loaded, or an error message if we have an error. And for that, let's start with the loading spinner. On the products overview screen, there I want to show a loading spinner whilst we're waiting for data to arrive. For that, we first of all need to know whether we're loading or not. And we can control that with use state, so with an internal state in this component. So there we can add is loading and set is loading, and then simply use state here like this, and initially we're not loading, so I set the initial state to false. And now here, when we dispatch this, so here in use effect, I set is loading to true, of course. But once we're done, I want to set it back to false. Now the good thing is, dispatch here dispatches our fetch products action, and therefore this here gives us a promise actually. So here I can add then and also catch later for error handling to do something once this is done. You can also use async await, but it's not allowed to use like this here in use effect. That's not simply how use effect should be used. So if you would want to use async here, you would have to wrap this into a separate function which you have to create in your effect, like load products, which is just a dummy wrapper function that looks like this. Maybe with set is loading in there as well. Now here you can add async, and now then you can call load products like that right thereafter. It's simply a wrapper which is required due to the way use effect works. It must not return a promise. It would do so if you use async here, and therefore using async there is not allowed. This, on the other hand, is allowed. So now in here we can use a wait here to wait for this dispatching to be done, which means this will automatically wait for the promise that's in there, so for the HTTP request, and thereafter we set is loading to false once this is done. Now to show a spinner, thankfully React Native got one for us, the activity indicator, which will automatically look good for iOS and Android, so it will automatically get the default platform style. And now we can render this if we're loading. So down there, instead of returning the flat list, if isLoading is true, I will return a different piece of JSX. I'll return a new view here with my activity indicator in there. For that, of course, you need to have view imported as well, so make sure that this is also available. Now with that, we return this view with the activity indicator. There you can set up the size to be large and the color to be colors.primary, for example. And this, of course, requires you to have that colors constant be imported, so make sure that it is available. And last but not least, now I want to center this indicator. So here we can add a style, which we, of course, could set up with a style sheet, or here, quick and dirty, flex one, justify content center, align items center. However, actually, I will use a style sheet here because we'll need that in a different place later too. So here I will refer to styles, let's say centered, and import style sheet from React Native. And with that, then go down there, add my styles object. After setting up the navigation options, maybe styles with style sheet.create. Add the centered property in there, which has this styling with flex, justify content, align items. And now with that, we should see a centered activity indicator whilst we're loading. So if I save this and this reloads, Firebase is very fast, so you don't see it that long, but for a short amount of time, you see that loading spinner here with the different look on iOS and Android, of course. Now, of course, loading is one thing. Sometimes you also just don't have any data that could be loaded. Let's say in our reducer, we're reaching out to product.json, which is a source where no data can be fetched, and therefore we end up with an empty screen. Well, that's something we can do, but it's not the best possible user experience. So I want to add another if check where I check if isLoading is false, so if we're not loading anymore, and my products here, the length there is equal to 0, which means we have no products. In that case, I will also return my centered content here, but there I simply want to output a text where I say no products found. Maybe start adding some. And for that, of course, you need to make sure you import the text component, and you can also assign your font styles there or create a default text wrapper component, which we used in earlier modules. For now, I'll just have my text like this, and this is indeed what we see there for now. Of course, as soon as I switch this back to the correct URL, where we actually do find data, it works. Now, last but not least, you could also have an error. Let's say here I don't have .json there. Of course, that is an error we would typically avoid because that's just a typo on our side. But unfortunately, Firebase servers are relatively robust. So to fake that they, for example, went down or something went wrong, I'll just break the URL in this way, which is an invalid URL. And now what we see is an infinite spinner. And the reason for that is that we actually now don't have a valid response. So if we have a look at our reducer, at our action here, and we console log this response data here, we see that as this reloads, fetching should happen immediately, right? But we don't get any output there. We don't see anything being logged from this. We just get a promise rejection warning at some point of time. So it looks like we're simply getting an error. And right now, we're not handling an error. Now, if you would be using promises without async await, you would simply add a catch statement. Here we are using async await. So what we do is we wrap this into a try block, all that code, which we ultimately want to run if everything succeeds, and catch any errors here. So a try catch block. That is where we get a potential error. And now with that error gotten here, we can handle it, for example, send it to our own analytics server or do whatever we want, and then maybe also refrow it. Of course, if all what you do is refrowing it, you wouldn't have needed to add this try catch block, but typically you might want to do more here. Send to custom analytics server or anything like that, as I mentioned. So now we refrow the error. It's still not better, still causes us to have an error. And in addition to just having try catch around this, we should actually also add another check here before we unpack the response body. We should also check if response OK is wrong, if that's false. OK is a field you have available on this response object, and this simply is true if the response is in the 200 status code range. If it's in a different range, for example, because you're not authenticated or anything like that, then the fetch API by default would not throw an error. However, I do want to throw an error in that case so that we always end up in the catch block if we have a 400 or 500 status code, or if we have a network request issue, for example, if the request can't even leave the device. So here, and that's fetch API specific, to handle 400 and 500 status codes as well, which normally would not cause an error. I'll also throw a new error here in that case, where I say something went wrong. Of course, you could dive into the response body here in that case too and find out what is wrong there. But I will just throw this generic error. And now we'll definitely have an error if something goes wrong, if we don't get back our data. But still, we then just rethrow the error here. But the place where I ultimately want to handle it is my component here, my screen component. Because there I then want to show an error message. So in there, we have our effect, and just as we could use catch or the catch handler if you use then and catch, or async await with try catch in the action, we can do it here as well. So here I want to try dispatching this, but I want to catch any potential errors we might get. So here I catch any errors this might yield. And since I rethrow my error in there, that's what I just did here, right? Ultimately, the error will reach us here. So now we will ultimately end up in this catch block. And now to show our error data, we can add another state, error and set error. You can name it however you want. Initially, that's undefined because initially I have no error. But then here, I will call set error and set this to error.message, for example. So to the message of this error I'm getting. Still, of course, I want to set loading to false thereafter. That doesn't change because we definitely are not loading anymore, even if we got an error. But now we also have this error state, which we can use. We can use that to check it here. If we do have an error, so if that is true, I don't even need to continue. Instead, I want to return my centered JSX content here. But there, I just want to output in text where I say an error occurred, for example, like this. And if we now do that, you'll see, we see a spinner, but then we see this error text. Now, of course, this doesn't allow the user to do a lot. We can now just navigate away and then come back. But we might want to give the user a way of trying again, maybe by adding a button here. So here with button imported, we can go there. And then here, add this button component with a title of try again. And of course, it's totally up to you how you want to let the user handle this. And there you could add an onPress handler. And now to be able to load again, I will actually take this load products function here, move it out of the effect and make it a regular function of this component so that I can call it from inside useEffect. Now, however, it also needs to be a dependency. And therefore, to avoid an infinite loop, it should be wrapped in useCallback. So let's import useCallback here and wrap this around this function here, where the dependency then is my dispatch function. You can also add set is loading and set error, but all these functions will never change. Therefore, you could also omit them. And therefore, this will never be recreated, which is good. But now we can use load products as a dependency here in useEffect. And now, since it's not inside of the useEffect function anymore, we can use load products anywhere else in this component. And the anywhere else part is here, this button. If we press this, I want to also trigger load products again. And also, last but not least, give the button a color of colors primary. With that, looks like I have a error here with my imports. Oh yeah, I already had button imported, so let's get rid of the second import, only imported once. And now what you'll get is that this will actually reload, eventually throw an error, and you can press try again to reload this. However, we always see the error message simply because we never clear the error. And if we do have an error, we always return this. We don't even make it to the loading spinner. So we should make sure that whenever we do load our products here, we set the error back to null. So we reset the error. And by the way, multiple set state calls next to each other will be batched together by React. So this will not lead to multiple component re-render cycles. It's okay to use it like this. So now with that, if I click try again, well, we can try again. Obviously, it will never succeed because our URL is broken, but still, this is how we could handle this error. With that, however, I'll go back to my actions and fix that error by correcting this URL again. And now this should also load our data correctly and display it. Now, one thing you can notice in this app is if I go to a different screen, let's say the admin section, and then I change something on the server, which of course is kind of unrealistic, but on the other hand, if this is an app where multiple users start adding products, of course the user can edit a product, save that to a server, and we are on a different page, and therefore we don't have the latest state because we have no live push updating here. So I'll edit this here. I remove the exclamation mark in the description, and in my app here, if I go back, and of course this is our product here, but if it were not, and I click here, I still see the old description. Reason for that is that the data wasn't refetched, and you might think that it actually should be refetched if I go back to the product's overview screen, because in there we have this effect which should run whenever this component gets rendered, right? If we go to the user here it is. There we have this effect, and this should run whenever the component gets rendered. And it does, but the problem is the way React Navigation, our navigation library, works is such that our different screens which we go to with the drawer are actually all kept in memory, so to say. They're not recreated just because we don't see them and then we come back. Instead, they're created once when the app launches, basically, or when we first visit them, but they're not recreated thereafter. It's a different thing for stack navigation. If I go to the cart, this is loaded. If I leave it, it's destroyed. If I come back, it's recreated. But not for this drawer navigation. And that's just how it works. So how can we refetch this whenever we reach this page? The answer is simple. You can set up a listener to navigation events. And we can do that with another useEffect call here. And in this function, we can use props navigation add listener. There we can set up a listener to the will focus event alternatives, and attached you find a link to the official docs with a full description. Alternatives are did focus after the page has been fully focused, will focus will fire when the transition begins, and we also have will blur when you're about to leave it, and did blur once you're done. But here I'm interested in will focus, and then here in the callback function, which fires when this event occurs, there we can reach out to load products. Alternatively, of course, we just point at load products like this. Now, dependencies of this effect are load products and also our navigation prop or the add listener prop there, but I will avoid it here to avoid unnecessary reruns of this effect if something else about our navigation prop changes. For example, if we set new params to communicate with our header navigation options, which we do in some components, then we could enter an infinite loop here. This is why I only add this, even though it would be cleaner to add all dependencies we have. Now, the cool thing about useEffect is that you can also return something there, which we haven't done thus far, and that is a cleanup function. So it's a function, it has to be a function, which runs whenever this effect is about to rerun or when this component is destroyed. And there we can clean up that listener, which we of course should do. For that, we can simply store the subscription. So will focus sub like this. And then here we use will focus sub and can simply call remove here. And this will get rid of the subscription once this component is basically unmounted, or whenever it will rerun because load products rebuilds, which shouldn't really happen. Now we have that listener, and now if we remove use effect here, because we always will load our products with this listener, nothing happens actually. Reason for that is simple. This will set up this listener, which will reload our data, but it doesn't fire initially because this will only be attached after the component rendered the first time. This is after will focus fired though. So to also fetch the products initially, we need this extra use effect call. But with that, we fetch it initially, and we'll also refetch it. And to prove that, let me add a console log statement here in load products, where I say load products like this. And therefore now when this app loads, we see load products here. And if I now leave this screen and go to admin, this was on Android here, by the way, the second log. So this was the one log from the iPhone. So now I left the screen. If I come back to products, you saw the spinner too, and this also reprints. So now we do this whenever we revisit this page. And this is a pattern you might want to consider when working with React navigation to make sure you do something, no matter if that's fetching data or something else, whenever this screen re-enters. Now we know how we can store and fetch data. Of course, in our app, we can also edit and delete data, however. So let's make sure that this works as well. And for that, I'll go back to my actions and there to products. And in there, in the products actions file, we have our update product action creator here. Now, just as before, I will now change this to return async dispatch. And then in the end, in there, dispatch this action here. So move that in there and, well, call the dispatch function here, which we're getting by Redux func. And before we do that, we can now reach out to the server and update our data there. Now that will be pretty simple. We can just, again, use the syntax from create product. This here, so just the fetch request alone should suffice here. And do that before we dispatch. Thanks to our wait, we will wait for this because this dispatch function invisibly gets wrapped into the then block that belongs to this promise. But we need to tweak this request. The URL, for example, is not entirely correct. It points at the products, but now we want to point at a specific product, the one product we want to update. Therefore, I'll use a different JavaScript syntax here with backticks instead of single quotes, which still creates a string, but a string where I can easily inject dynamic data into. And I will add a new segment after products before .json, and we can now inject data with this $ curly brace syntax, and that's vanilla JavaScript, not specific to React Native, it's just JavaScript. And here, I want to add my ID, so that in the end, I target this URL, then the products node, and then this ID. Of course, if you're using a different API than Firebase, the URLs you have to send your request to will differ. Then you should have an API documentation that tells you which URLs are accepted, or you're writing your own API, well then you should definitely know where you can send requests. This is how Firebase wants it, and the method now for updating also shouldn't be post, but patch or put. Put will fully overwrite the resource with the new data. Patch will update it in the places where you tell it to update it, and that's what I want here. I also need to add my headers, and now also add a body with a title, description, and image URL, but of course not with a price because we're not getting this and we don't want to touch this. And this will send a request where Firebase will automatically only change these fields on the product with this ID we're targeting. Now I actually don't need to store the response in a constant because I don't care about it anyways. It's just important that we wait for this to complete. And with that we should be good. If we now save that, and we go here to admin and start editing this, and maybe add exclamation mark here, and then important, click somewhere else so that this re-triggers due to our form logic and submits its new data. And we then click this check mark, we're taken back, and we see a white shirt here. We also see this on Firebase. So this is working. So this is how we can update data. Now what about deleting? For this, let's go back into our actions. And for deleting, we have our action creator. Now, just as before, here I return this async function that gets dispatch as an argument. And we're in this function. We then, in the end, dispatch this action that reaches our reducer. And before we reach that, we can again send a request. Request that looks like this. I will copy this part here. Don't care about the response really. Just like that. Await fetch. Now the URL is wrong. Just as for updating, I want to add my ID in there. Hence, I'll use backticks so that I can use this injection syntax again and add the product ID here. Send a delete request, and we won't need to set a header because we also won't have a body, so we can get rid of all of that. Just the method is important and that we await. And therefore, now we should be able to delete data as well. We can have a quick look at this. If I create a new dummy product, which I can easily delete without losing too much, like that, if I save that, if I click delete here, click yes, it's gone here, and also we saw it for a fraction of a second here, it was also deleted on Firebase. So this is how we can update and delete as well. So now that we added storing, fetching, updating, and deleting, and therefore all the CRUD functionalities, and we had a look at showing a loading spinner and handling errors, there are two things missing. One is that when we actually place an order, that we do send that order to a server too, and that we store the order there as well, and not just locally. Because right now, of course, when we order something, we see it here, but as soon as we reload the app, since we're not storing it on a server, that is lost. So that's one thing. The other thing is, of course, that we only show a loading spinner here, and we also only handle errors here. On the admin screen, if something goes wrong, we get no error. Also here, if we edit this and we submit this, we see no loading spinner whilst we're waiting for this to be submitted. So that's also something we could improve. And that's actually the part I want to start with. So here on the edit product screen, when we dispatch, updating or creating, in both cases, this of course takes a while. And indeed, we get back a promise here because both in the update and the create product action, we're using the Redux func feature of returning an async dispatch function here, which therefore returns a promise, which therefore is returned as part of our dispatch function call here. So therefore, we actually get the information whether we're waiting for the response, whether we got an error, or whether we're done. We just need to use it. And of course, we can use it in a similar way we did before, with use state imported from React, and then by managing the loading and the error state here. Side note, you could of course also work with a reducer where you merge both states together if you wanted to, with the help of the useReducer hook. Here, however, I'll stick to isLoading and set isLoading. And initially, of course, this is false. And also have the error and set error variables here with use state like this, which initially is undefined. And now we just need to set this as we're dispatching actions or as we're getting errors. So here, when we're about to dispatch this, no matter if we're editing or if we're creating, I want to set isLoading to true. And I also want to set my error here to false, or not to false, to null, reset it. Now, once we're done, I want to do something else, but for that, we first of all need to wait for dispatching to be finished. Now we can therefore turn this into an async function again, just so that I can use the await keyword in there. The alternative would be to not turn this in an async function and simply add then and catch thereafter. That would work as well, but I like to use async await. So now we can await for both dispatches to finish. Of course, only one of the two will run because that's in an if condition, but we can wait for that to finish. And therefore, after this if block, we know that it will be done dispatching. So here we can set isLoading back to false. So that's the loading state. Now to handle errors, we just need to wrap this with a try catch block. And we can actually wrap the entire if block here with try catch. So let's grab that, move it in here, and then catch any potential errors we might be getting here. And now here, I of course want to set my error to the error I'm getting here, or to the error message I'm getting here. Now we're setting the error, we're setting the loading state. Of course, this has no effect here on this screen. So to show a loading spinner, we need to import the activity indicator from React Native. activity indicator from React Native. And to show an error, I also want to throw an alert, and for that you need to make sure that you're importing the alert, which we're already doing. Now, as a next step, to handle the loading state, maybe down there, before I return my form, I will return, I will check if isLoading is true, and if it is, I will return my view here with the activity indicator in there. And there I'll set the size to large and set the color to colors. And for that you need to make sure that you import that colors constant primary. So make sure you have that colors constant imported here. That's required. And now I will also use the style sheet here to add a new style, this centered style to be precise. Here I will add centered, and yes, we could therefore also outsource this into a separate wrapping component if you wish to. There I'll set flex to 1, justify content to center, and also align items to center, like this. Now we can apply this centered style here to the view, which I wrap around my activity indicator by setting the style here to styles.centered. Now we should be seeing this whilst we're loading. And on a side note, we also now shouldn't navigate back before we're done. So if I add, or if I remove that exclamation mark and then leave that input so that this is submitted and I click save, you saw the loading spinner and we only navigate back after this is done. Now Firebase is super fast, but still that is what happened. Now to simulate an error, I'll go to the product's actions, and there in update product, down here, I will remove that S here again to force an error, and I will also add something else. I will now store the response here in a constant because now I actually do care. I want to make sure that if the response is not okay, so if we have a 400 or 500 status code, I also throw a new error where I say something went wrong or where you do whatever error handling you want to do, so that we also throw an error in that case. By the way, I'll do the same for deleting before we test this forced error which I implemented. So here for deleting, I also want to check this, and for that, of course, here I also need to get my response by awaiting the fetching here. Okay, with that, let's see if that forced error for updating due to this missing S here, if that has an effect. If I now go back here to admin, I start adding this, I add an exclamation mark and click this. Now what you'll see is that the update is simply dismissed, so we don't see the exclamation mark here, but we also get no error message, which makes sense because I have no logic to do that. Now, how can we handle this? As I said, I want to throw an alert, and therefore I will use useEffect, so that useEffect hook which React offers, which we find here. I want to use that, and I can simply implement that here after initializing the reducer, let's say. Exact position doesn't matter too much. useEffect here should rerun whenever error changes. So if we set this to be an error or to not be an error, then here I check if error is truish. So if we have an error, and if we do have this, then I can throw an alert. An error occurred. I want to output my error here. And that should be the error message because that's what I'm setting here. I'm setting my error to the message, so that should be a string which I can output. And then I'll add a button where I say OK, which simply dismisses this. Now, also important, if we get an error, I don't want to navigate away. So to avoid that this happens, I want to make sure that here, this props, this navigation here, actually only is performed if we, well, don't end up in this catch block. So basically here, after the if-else block, but still in the try block there, I want to navigate away. So now let's give this another try. Let's go back here, edit this, add exclamation mark, click somewhere else, click save, and now I get my error message here, and I stay on this page, and it's also reset. I can add this again, click here, and it's gone. On the other hand, if we now fix that error here in the actions by re-adding that S here, And we now go back and have another look at this. If I edit this, add my exclamation mark, click somewhere else and click save, now that all works as it should. So now this really works, and now this behaves in the way it should behave. Now you can, of course, also add a loading spinner and an error handler here to the user product screen if you want to. So if you delete this, which I won't do here, but if you would delete this, you would currently not get a spinner, a loading spinner. You also won't get an error if it fails. To save some time, I'll not implement this here, but you could implement it in basically the exact same way we did before if you wanted to. So that's something you can definitely also do. So now to come to an end in this module, I want to make sure that we also save orders on a server, and of course that we fetch them from there as well. Now we have the orders action creator here, and there we can again take advantage of Redux func and return our function here, which gets that dispatch function, which should be asynchronous with the async keyword so that we can use async await. And in that function here, which we return, ultimately, of course, I will dispatch my action object. But before we do that, we can now send a request to store that order on a server. And we can borrow that request from the products action creator. There, it's not really a big difference whether we create a product or an order. So we can copy this entire product creation code here, all the way up to here, and move that over to the orders.js file. Now, of course, you can also add error handling here. I'm not having it here. One thing I want to at least add is that I check if the response is not okay, in which case I want to throw a new error. Something went wrong. But that should not be the focus here, because we covered error handling and loading spinners, not really the part I want to focus on here. Instead, let's make sure that we're sending this request to the right address. And that should not be the products node, but let's say the orders node, which kind of makes sense, I guess, because well, we want to store our orders. Maybe we also want to store our orders specific to that user, so we could store that at /orders/u1, which is my dummy user ID, I assume here. Later, that will be different. Later, we'll have a real ID here, a dynamic ID. For now, let's just hard code this here so that we have some subfolder, one subfolder per user later. It should be a post request because we're appending some new data. We're adding a new order. This header needs to be set, and now, of course, the data we're sending is different, though. There, I want to send my cart items and my total amount. And one other important thing, the date of the order. I want to send my date here converted to a string with 2 ISO string on the date object so that we create this locally in the app and then we save the timestamp on the server. Now in your app, you also might want to do that date creation on the server, but since this course shouldn't focus on server-side programming, we'll just do it here and send it to the server and not worry too much about what else the server could do for us. Instead, let's do all the things here and just send that finished timestamp to the server. Now this will add an order here. And once we're done, we get back our response data, which will include that automatically generated ID, if you remember. We did that on the product creation as well. So therefore now when we add an order, we of course forward our items and the amount, but now I also want to forward the ID, which I get from restdata.name. That's the same logic we used when we created a product. And there's one additional thing. My date snapshot, of course, should be the same as created here. So actually what I'll do is I will create my snapshot here, date with new date, and then use this constant here to create my string version, and use the same constant here to forward it with my order data. So here date refers to this date constant, so that I use one and the same timestamp both locally in my data managed with Redux, which is the data I work with here in this running app, and of course also have the same timestamp on the server, which is the data I will load in the future or other devices will load. And now we just need to work on the orders reducer. For add order, the ID is now something I get from outside. So here I have order data.id, because that's what we're forwarding here. It's that automatically generated ID Firebase gives us. And the date is also received from outside. Here we can now use order data.date like this. And with that, we have all the logic to hopefully add an order. Now let's go back here and add this to the cart and click order now. This seems to work. If we go back, we now see an orders node here on Firebase with a U1 subfolder for our user with the generated unique ID. And in there, the order data with the timestamp, with the price, with the card items, which was this one white shirt. And that all doesn't look too bad, I'd say. Now, of course, when storing an order, it would also be nice if we see a little spinner here when we click the Order Now button until this is done. We can implement this as well. We just need to go to the card screen, which is where we dispatch this action to send an order. Here we dispatch. And now dispatch here, of course, returns a promise in the end, right? Because remove from cart, which is the case when we click this button, and add order will return a promise in the end, thanks to our change. So dispatch will therefore return a promise. So it's here where we can control our loading state. Now, to make that a bit more readable, I'll move it out of this anonymous function here and actually create a new function stored in a constant here in my component, but outside of the JSX tree. And I'll name this send order handler or anything like that. That's the same function I used before. Now I will just bind this to the send order handler. And now the idea is simple. Here, add order will return a promise, as I said. Dispatch therefore returns a promise. So we can add async here so that we can again use async await and manage the loading and possibly also the error state as we did before. So we just need to import use state from React. And of course, therefore initialize our state again. So here we have is loading and set is loading. And initially that's false. And if you want, which I'll not do here, but if you want, you can also add error handling in the same way we did it before with use state, error, maybe use a fact to then show an alert, and so on. I'll focus on the loading part. So now here in send order handler, I'll call set is loading and set this to true. Then we await this dispatching, so we wait till this promise is finished. And again, this just invisibly wraps the parts thereafter into a then block, because thereafter I will set loading back to false. We're not loading anymore. And now we can use that to show an activity indicator. So let's import activity indicator from React Native here. And what I want to do is here, instead of that order now button, I want to show that indicator whilst I am loading. So here I can check if is loading is true. If it is the case, I'll show my activity indicator with a size of, let's say, small and a color of colors, which you need to make sure that's imported, primary, and that's self-closing. And otherwise, if we're not loading, well, then I will show this button, of course. So here I want to render this button in the else case. And now let's give this a try. Let's save that, add this to the cart, maybe twice, click order now. We saw the spinner for a fraction of a second here. And now if we have a look at orders, here's our order. Now let's make sure that the orders also load when we visit this screen. To make sure that they load, again, we need to go back to the action creator and add a brand new action in the orders action creator, One identifier I need is set orders, just as we had one for set products to set the loaded orders. And then here I have my fetch orders action creator, which takes no arguments, but which then returns my async dispatch function here, thanks to Redux func. And there, ultimately, I dispatch where I send a new action where the type is set orders and where I have my loaded orders. And of course, that should not be an empty array. Instead, we can borrow the logic from the products action creator, from fetch products there. We can take all that logic, copy all of that here, and move it over to the orders action creator and run that before we dispatch here. Now, of course, we need to fine-tune this. For example, the request needs to be sent to orders/u1. And again, that will be replaced later with a dynamic value. For now, it's hard-coded to fetch the orders for this user. Should be a GET request. I want to check this. That's fine. Here I got my response data. Now here I got my loaded orders. That seems to be a more appropriate name. Still, I loop through all the data I got. and I want to set my loaded orders down there. But now there's one important difference. I don't create new products here, which I add to loaded orders. Instead, of course, I need to create new orders here. And for that, you need to import order from the order model. Now, also, I see there's a missing curly brace. Now, before I proceed with that, by the way, I need to make sure that I also catch any errors I might be getting. And there I want to throw the error, basically re-throw it, make sure it reaches my component. And need one more closing curly brace. But now back to our logic here, where I create new orders. There, the ID is the key, just as for the products. The items can be found in my response data, because we basically get back this here, right? So the response data will hold a card items key, for example, which holds my card items, which I need. So response data for the given key and there dot card items, that's where I find my items, because that's what we send here in the end to store the card items. Then my order, which I create here, of course also needs the total amount. I get that from res data key. And then there, if we have a look at Firebase, it's that total amount field here. And the date, well, for that I create a new date object, but I initialize this with res data key dot date. Now we need to create a new date object because res data key dot date is just that date string here, and I need a date object, not a date string. Hence we wrap it, this string, we wrap it with the date object creation here, and therefore we get a date object. And that's the order which I add here to loaded orders. We do that for all the orders we're fetching, and with that we can dispatch this, and now we just need to handle it in the orders reducer. So there, if I handle set orders, and for that you of course need to import this action identifier. The only thing I need to do is I need to return a new state object where orders is equal to action.orders, and that's all we need to do. So really simple. And why is it that simple? Because in the action creator we do all the work. There we map our orders, and then here I just have the orders key on my action, which holds all the mapped orders. So that's just what I need to store here. Now the remaining step is that we dispatch fetch orders here in our orders screen. So let's go there and let's actually add use effect again to do that. And to dispatch, we also need to import use dispatch from React Redux. And then here we can get access to that dispatch function by executing use dispatch. And then here in use effect, we add dispatch as a dependency because in this effect function here, I dispatch, and now I need my order actions. So let me import everything as orders actions from the store folder, from the actions folder, from the orders file. And with that imported here, we can say orders actions dot fetch orders like that. That will go ahead and make that request. And therefore now if we save this and we go to the orders screen, it's initially empty, but very, very fast. It loads all the orders which we stored. And that are these 3 orders which I have here. And of course we can expand this just as before. Now a loading spinner would be nice as well. And of course you can also pause the video here and try this on your own. I'll quickly do it in the same way as before. Import use state from React. Then here, set up the is loading state and set is loading by executing use state and setting this to false initially. And then here in the effect, in the end, I want to use async await. Now I said that you can't or shouldn't add async here. So we can either use then here simply, or wrap this in a helper function. Now I will just use the then call. So we'll set is loading to true here, and then add then here. And once this is done, I know we have a response. So here I will set is loading to false. Now please note that I'm not having error handling here. So if this fails, we're not handling this. Instead, we'll always be in the loading state. So of course you might want to consider adding error handling as well. I'll just not do it here because I showed how it works. To not bloat this module too much, I'll not implement it, but I can. But of course, you could handle errors here if you would want to use this then approach here by also adding catch. This is something you can absolutely do here. I'll focus on the loading part, however. Now, since I have all of that set up, we can import the activity indicator and import the view component. And for some styling, also import the style sheet API from React Native. And then check whether we're in the loading state, in which case I want to return my centered activity indicator here with a size of large and a color which should be colors, which you need to import there for primary. So make sure you have that colors import added. And with that added here, I'll add styles equal to, style equals to styles.centered, or however you want to name it. And now add that styles object here with the help of style sheet create. And there, centered should have a setup of flex1, justify content center, and align items center, like this. Now with that, if we save it, we have a look at orders. We see the spinner. Again, it's loading very fast, but you can see it if you look closely. Here's the spinner for a fraction of a second, and thereafter the orders are loaded. So that's now working, storing and fetching orders, all the works. And with that, we implemented HTTP requests and using a server for storing the data in this app. So that's our app here. Now in this application, we added a lot of functionality, but there's one more thing I want to add, and that's pull to refresh. Let's say I want to be able to fetch all the products from inside this page, so without leaving it and coming back, which will fetch the latest products, but from inside this page by simply using this pull to refresh pattern, where you drag down and then it reloads. Thankfully, that's really easy to do in React Native if you're using flatlist or a scroll view, because it's built into these components. Here in the products overview screen on flatlist, you can implement it by simply adding two props to the flatlist. The first prop is on refresh. You need to add this, and this should point at a function which is executed when the user pulls down, so when the user starts this pull to refresh action. And here in the products overview screen, we can of course simply point at load products, because that is in the end the function that loads our product. So this is perfect. So here we can just point at load products. Now by adding this, we automatically get this functionality. But here we also get an error that the refreshing prop must be set. Because that's the other thing you always have to set when you add on refresh. Setting on refresh automatically unlocks all this behavior and also this nice spinner you get by default. React Native will do all of that for you, but it only does so if you also add the refreshing prop. The refreshing prop is required to let React Native know when you're done. And this should therefore point at a variable, at a stateful variable, so at some state, which indicates whether you're currently loading or not. And of course that's great, because we have our isLoading prop here. So that does tell us whether we're loading or not. We'll just have one problem. If we're loading, I replace the entire content of the screen, and that's of course not what I want to do for reloading. So we'll fix this, and a simple fix could be that we remove the set as loading part here from load products, both setting it to true and to false, and instead do that only for the initial load here in useEffect, where we trigger load products when the component loads, and then here using this then syntax, set this to false once we're done. We can do that because load products will return a promise, because it's having this async keyword, therefore it returns a promise. And with that, we get the loading spinner when this initially loads, but not when it reloads. That also means that when we visit this page, we don't see the spinner, but that might be fine. We have some content on there anyways, and if that then updates after we visited this page, that might be okay. So now we're not setting isLoading here, but we can now set a different state here. Let's name it isRefreshing maybe, and set isRefreshing. Here I want to manage a state which initially is false, just like isLoading, and that's now what I want to set here. So set is refreshing to true here. And also here, here after try catch, set it to false once you're done. Now, of course, this works in the same way as is loading, but now I won't use is refreshing to replace the entire content of the screen, but instead is refreshing can now be fed back into the flat list on this refreshing prop. And therefore, on initial load, this works as before, but now here we get this nice pull to refresh functionality. You see it here. I can pull down, get that spinner, and this will automatically reload. And I can prove this by editing this on the server. If I add an extra or a couple of extra exclamation marks there, we can get those exclamation marks here by pulling and refreshing. Here you see that. The same, of course, on Android. There you also got that functionality out of the box. And this is how easy you can add pull to refresh functionality to your React Native application. So that's another core module finished. You learned how to store your data not just locally in memory, which you of course need for the running app, but also how to store it on a server so that you can get it after your app restarted, or importantly, also on other devices using this app, because you're not the only user of this application. And whilst you sometimes have data that only belongs to you, the products in a shop certainly aren't of that kind. So it's good that we can now store them on a server. You learned how to store data there, how to send requests to change or delete data, how to fetch data, how to show a loading spinner, also how to use this pull to refresh functionality, how to show errors if you got some. All of that is important, and all of these things are things or features you will need in most applications you build. Therefore, this was a key module, hopefully helpful to you in future applications. And with that, in this project here, we can move on to also add authentication. It's time to add some users to this application. To add authentication, because many apps which you'll build will have authentication. They need users who can sign up or log in or log out to really work. And therefore, in this module, we will thoroughly walk through everything that's included with signing users up, signing them in, logging them out, giving them access to the backend so that they can send data to protected resources there, and so that only authenticated users can interact with the backend, and so on. We'll do all of that in this module, and you will learn how authentication works in native apps like this, and how you can implement it in this React Native app. Now, it's important to understand how authentication works, because if you're having a web development background, you might be used to authentication working a bit differently. So we have a server, Firebase in our case, but that can be any server to which we talk from our React Native mobile app. And this is the server which typically also authenticates us. So where we can send the email and the password the user entered to create a new user or to log a user in. So we send that auth data to the server. Now the server responds with something. For example, with an error if the credentials are wrong, or with a success response if they're correct. And in a traditional web application, a server would then also store a so-called session on the server and return a session key to the front end, so to the browser, for example, that basically allows the browser to find out that the user using this app in this browser is authenticated. Now, this works a bit differently for mobile apps, because there you communicate with servers which are stateless, for example, RESTful APIs or GraphQL APIs. And there you don't really have a session because the server doesn't care about the individual clients. It doesn't save any data about whether you are authenticated or not. Instead, you work with so-called tokens. The idea is not too far away from the session idea. When you log in and the server checks the email and the password and determines that both is correct, the server creates a token. It uses a certain algorithm for that, and it uses a key, a private key, which only the server knows. This token is then returned to you, so to your app, for example, to the React Native mobile app. And there you can store the token in some storage, for example, in the Redux storage, so in memory. Manage it with Redux in memory whilst your app is running. Now, why do we need that token? For one, as long as we have that token, we can determine in the mobile app that the user is probably logged in, and therefore forward the user from the authentication screen to our main app screens, and so on. And when the user clicks log out, we would simply delete that token. But we also need that token for something else. On the server, as I mentioned, we typically have certain resources, certain URLs, which are only exposed to logged in users. So for example, in our app, creating products is probably not something every user should be able to do. And therefore, if you want to send a request to such a protected resource, you need to attach that token to the request so that the server, which created the token and which therefore can check with that private key whether the token is valid, so that the server can determine whether you have access or not. If you send a wrong token or an invalid token or no token at all, access will be denied and you get back an error. If you have a valid token, and again, the server is able to check whether the token is valid or not, you will be granted access. And you can therefore then access the resources, write data, whatever it is. This is how authentication works. And this is how we will implement it here. Now, the good thing is Firebase, which we're using as a dummy backend, already has all the token creation, user management stuff built in. So we don't need to worry about that. We just need to send the right requests and then manage that token, and we're good to go. So let's get started with implementing authentication. And one very important step towards that is that we add a new screen, the auth screen, which is the screen that should present a login or sign up form which the user can use to, well, log in or sign up. And therefore here in the auth screen, I'll import React from React. And I'll also import some things from React Native, because from there, from React Native, I want to have the scroll view because we'll build a form and I want to make sure that users on all device sizes can interact with it. I will add a style sheet here. And that should be it for now. We can always add more if we need more. We can also already include a view and the keyboard avoiding view, I guess, to make sure that all inputs are always reachable. Now, speaking of inputs, of course, we'll add a form, and therefore I will reuse the input component we built in the forms section, which I can find in the components UI folder. So make sure you watch this section to know what this component does and how we can manage a form with it. With that, we can create the off-screen component here, which receives props. And we can also create that styles object with the style sheet, the create method there, and of course export the off-screen like this. Now obviously the question now also is, how do we present this off-screen? How do we make sure that we see this if we're not logged in? Now that's something we'll refine throughout this module, but to get started, we can go to the navigator and make sure that when the app launches, we see that off-screen. And for this, we can use a special new navigator, which we haven't used before, which is specifically built for, you could almost say for this authentication use case. And that's the create switch navigator function that helps us there. So it creates such a switch navigator. The special thing about this navigator is that it always displays exactly one screen and you can't go back to another screen if you then navigate to a different one. So going back is explicitly not allowed, which is exactly what we want, because you shouldn't be able to go back to the login screen if you did just log in. So therefore, here at the bottom of the file, I'll create a new navigator, maybe my main navigator. The name is totally up to you, of course, with create switch navigator. And just as before, this navigator takes an argument where we configure it, so an object where we configure it. And there I want to bind my off screen and also, of course, my shop stack thereafter. Now to have a nice header, I will also create my off navigator here, which is a stack navigator created with create stack navigator. And in there, I'll just map the off screen, which I just started working on. And for this, of course, we need to import it. So in that shop navigator.js file, we can import off screen from screens off, user off screen like this. And with that import added, if we go down, we map this here to off in the off navigator, and the off navigator is then mapped to off here in the switch navigator. And shop is of course mapped to the shop navigator. And now it's the main navigator, which we wrap with create app container. And therefore, with that, if we save this, we will actually render the off screen as the first screen, which right now will not render any valid JSX. So we get an error. But we can work on that, of course. Because there, the goal now is to render this authentication screen where we can, well, log in and do our thing. So here, I want to present these inputs, and I'll actually also import the card component from components UI card to have this nice card look here and have my inputs in there. And of course, this is totally optional, but here I'll add it. Here I'll add the card. And in the card, we can add the scroll view so that we can scroll inside of that card. Of course, you could also add the scroll view around the card so that you can scroll on the overall screen. But I'll do it like this. Also add my own style here to the card, which I'll name off container maybe. Name is totally up to you. And I'll also wrap a view around all of that here as a wrapping view where I will add a style which I'll name screen. Actually, here we can already use the keyboard avoiding view, I guess, with a behavior of padding and then this keyboard vertical offset of, let's say, 50. So now inside of that scroll view here, which we have in our card, we can start adding the inputs, the custom input we built earlier in the course. For example, here, an input with the ID email and a label of email, because there I want to fetch the, user email address. And therefore the keyboard type of email-address, which is supported both on iOS and Android. It should also be required, and I want to use the email validator. These are two of the validation functionalities I built into the input earlier in this course. Also, auto capitalize should be turned off, so I'll set it to none because capitalizing the email address is really not helpful. And the error message I want to show if we have something wrong in there is please enter a valid email address. Something like that. Now, when the value changes, so on value change, we want to do something, but for now I'll not do anything here, just provide an empty function so that we don't get an error. And the initial value which I want to show here, well, that's just an empty string in the end, because I don't want to provide any other initial value. Now, of course, it's not the only input, so I'll repeat this, because I also need a password input here with a label of password. And the keyboard type here should be default, because I want to have the normal text keyboard, but I want to obscure the input so that we can't see it. And that can be done by adding the secure text entry here. This is, of course, not a prop supported by my custom component, but keep in mind that in this component, we forward all props to the built-in text input, and the built-in text input supports this secure text entry property here. So that's why I can set this. Here, the validation should also not check for that being an email address, but make sure that we have a min length of, let's say, 5 characters. Auto capitalization can be turned off here as well. Error message would be please enter a valid password. And with that, I just saw that here, of course, I have a typo that should be email address. Here, password. And I'll leave this here as it is. Now, in order to be able to submit this, I also need a button. So here I will import button from React Native and add 2 buttons actually in the card, and therefore also inside of the scroll view. The first button has a title of login, let's say, and we'll later switch this to be either login or sign up, depending on the mode we're in. And the color is imported or is added with the help of the colors constant, which you should import. And on this colors constant, I will use colors.primary. And on press at the moment can simply point at an empty function. And I will repeat this because I want to have a second button where I say switch to sign up. And of course, this will also then later say switch to login if we are in sign up mode. And there we can maybe use our accent color. If we now save that, we should have a basic login screen. Here it is. Doesn't look the way it should look, but we have our inputs here. We have these 2 buttons. Also on Android once this is done loading. Here we go. And now, of course, I'd like to style this appropriately. So let's go down to the style sheet. And please note I have two styles in the end assigned, screen and auth container. So here in the styles, I want to add both screen and auth container. These are the two styles I plan on working with. Now for the screen, I'll set flex to 1 and then justify my content in the center and align the items in the center to have centering both on the vertical and the horizontal axis. And on the auth container, I want to set a width of, let's say, 80% to not take the full available width, and a max width actually of 400 pixels. In case 80% would be more than that, we restrict it to 400 pixels. And maybe a height of, let's say, 50%, but a max height of also 400. Let's see how that looks like. We save this. This is what I get here. Now I can scroll in there because I set up such a scroll view. And actually, that's not the behavior I want. I'll not set a height here. I'll just set a max height so that this is capped at a certain height, but by default, it just takes as much height as required. And therefore, I rather instead add some padding so that we have some space around the inputs and it doesn't sit on the edge of the card. So this looks much nicer. And let's see how that looks like on Android. Yeah, looks generally okay. If I tap in there, this also scrolls up. So the keyboard avoiding view is doing its job. But of course, I still get an error here that on input change is causing an error because, yeah, I added on value change here. That should be on input change, not on value change. So that's a little fix, but we're heading in the right direction. Now I'm not done though. I want to have a header title, and how about some background color here? That would also be nice, probably. So for that, regarding the header title, of course, we can add offscreen.navigation options and work with some static options for now, because I just want to add a header title here and set this to please authenticate, or just authenticate, something like that. And for the background, well, of course, we could give our view here, which holds everything, a background color. But I actually want to show you a new component which we haven't used thus far. For this, we need to install a brand new package, and that's the expo-linear gradient package, which you install with npm install --save expo linear gradient. This is a package which allows us to add a linear gradient with ease, so in a very simple way. And after this has been installed, you just need to install just import from expo linear gradient, and you do import a component which this exposes, the linear gradient component. Now that's a component which you can use in your page, and here I'll use it inside of the keyboard avoiding view, linear gradient like this, and wrap it around all the other content like this here. And now you can configure that, and there I want to make sure that this has a colors key which allows us to set the colors between it should transition. Because a gradient is simply a gradient between multiple colors, at least two, but you can add more. And there you can now adjust the colors like red or by adding the hex codes. And I want to transition between FFEDFF and let's say another hex code FFE3FF. And of course you can experiment with different colors here. Now we also need to add a style here, and I will name this styles gradient, which we can now add down here. And this gradient will take a width of 100% and a height of 100%, so it will take all the width and height it can get. This is therefore how it looks like, but now we have a problem. Of course, our content isn't centered anymore. To ensure that this is the case, we now need to add justify content and align items again. And therefore here on the surrounding screen, we can get rid of that. Now we have the same look as before. Obviously, we can therefore also achieve this by not setting width and height, but just flex 1. So now with this setup here, and it's important that the screen doesn't try to center, because otherwise the gradient will be centered. But with this setup, we now have this look with this nice gradient. And to see our header title here, we just need to make sure that in the navigation setup, in the shop navigator, we assign our default navigation props to the auth navigator. So I'll add the second argument to create stack navigator, and default navigation options just points at default nav options, which sets up the header color, the header title color, and so on. Of course, make sure you have no typo here in the off-screen navigation options in the off-screen as I do. So with that fixed, this is the setup we have here. Of course, you can experiment with the colors and use different colors if you prefer that. I'm happy with that. And now the only remaining thing I want to fix here is my styling for the buttons. Some spacing around them would be nice. And that can easily be added by wrapping the buttons in views here. Both buttons actually. So do this here. And now give each view a style here. Maybe styles button container. Do this on the first view and on the second view. And now we can give that button container a styling down there in the style sheet. And here we can set a margin top, for example, of 10 to make sure that every button has a little margin to the top so that the buttons don't sit directly next to each other, which I think really would help our buttons. So this looks good on iOS. Let's also check it out on Android. Yeah, this doesn't look too bad. So with that, we have that basic setup. Now let's make sure that this also does something useful and that we do actually try to log in with that. Now, as I mentioned, Firebase has authentication built in. We just need to go to the authentication area there and then click on Setup Sign-in Method and there choose password and email, or email password here. Enable this and click Save. And with that, we have it enabled. Now we can send requests to a Firebase API to create users or to log them in. Now, in order to find out where to send the requests, you can Google for Firebase REST Auth API and you will find these official docs where you learn how to create and sign in users with their API. Now, there are a bunch of endpoints for different things. Here in this app, we'll focus on signing up and signing in. So if we click on sign up with email and password, we learn how that works. We need to send a HTTP request, a post request with this content type to this URL, enter our own API key here, which I'll show you where you get it from in a second, and attach this body to the request. So email, password, and then this return secure token field, which should basically always be true. As a response, we'll get back a token. That's that token I mentioned on the slide. Well, the email we used, a refresh token, which is more advanced. This token here will expire actually after this amount of seconds, which we also get back. With a refresh token, we could recreate it, revalidate it without having the user to log in again. We'll not do that here. You would have a separate endpoint to which you send the refresh token to get a new ID token. We'll keep it simple here and just use that token and log the user in again after that expiry time. Because that expiry time is also something we get so that we know when this token will become invalid and can't be used anymore, because we'll have to clean it up in our app by then so that we don't try attaching this invalid token to future requests to our database. And local ID, that's the user ID of the user which Firebase created on its servers. Because we'll not have to do any of that user management, Firebase will do that. We don't need to write any server-side code. So what we need to do is send a HTTP request. And since I also will manage this all with Redux, I will create a new action creator for this, and I'll name it auth. I will also already create a reducer because we will also manage some auth-related stuff there, for example, the token and the user ID. Let's start with the action though, and let's hence export action creator here, which could be named sign up. Makes sense to start with that because logging users in will only be possible after we created at least one user. So here in sign up, I want to be able to, well, create a new user, and for that we'll need an email and a password. So that should be passed to the sign up action creator from outside. Now then, this will send a HTTP request, and in order to be able to do that, we'll use the Redux func package again, and therefore return async dispatch here. So we return a function which can use async await, which gets that dispatch function as an argument passed in by the Redux func middleware we started using in the last HTTP module of this course. And this allows us to run async code before we then dispatch an action that actually reaches our store. Now for that, we'll also need an action identifier for that action which we later want to handle in our store. And there I'll just use sign up, which also has sign up as a string identifier. So here in the end, we'll then dispatch this action object where the type is sign up and where we will probably then also add some extra data. But before we do that, we need to send a HTTP request. Now that can be done with the Fetch API, as you learned in the last module, and definitely go through that module first, therefore. And this is the URL we need to send the request to. So we can copy that. Add it here. And now we have that API key thing. Now that's something we can get from Firebase by clicking on the gear icon here, project settings. There you find that web API key, and that's exactly what you need. Copy that and replace API key, including the square brackets, with that key. This is the URL we'll need to send the request to. Now, as the official docs tell us, we need to send a post request. So, as you learned, we need to add this second argument here to fetch, which is an object which allows us to configure that request. And there we can set the method to post and also add some headers, because we'll need to add the application JSON header, so the content type header, which should have a value of application JSON. And we'll need to add a body. And that body needs to be in JSON format, which we can get with JSON stringify. And the data I want to stringify needs to be an object with these three keys: email, password, and return secure token. So here, of course, email refers to the email we're getting as an argument here. The same for password, which refers to the password argument we're getting. And then it's this third, and I'll just copy it to not mistype it, return secure token argument here, or key value pair, where the value should just be true. This request should create a new user. Now we can wait for its response with the await keyword. And then, as you learned earlier, we can check if the response is not okay. If that's the case, I want to throw a new error where I say something went wrong, and we'll have a look at more detailed error handling later. For now, that's it. And if it is okay, however, I want to get my response data by awaiting for response JSON, which will unpack the response body and automatically transform it from JSON format to JavaScript, so to a JavaScript object or array. And now we will be able to work with that. And for the moment, I'll simply log this response data here. Now, we haven't added the rest of our auth-related Redux store. We'll do that later. But we have something that should work. We should be able to dispatch this and therefore send such a sign-up request. So now we can go back to the auth screen. And there in the end, when we click this login button, which is incorrectly labeled login at the moment when we actually do sign up, but let's leave it like this for the moment. So when we click this button, I want to send this sign up request. So for that, we need to, as before, import use dispatch from React Redux so that we can dispatch actions. And of course, import everything as auth actions from the store folder, there from the actions folder, and there from the auth file. And with that added, we can add a function here, either an inline function or like this, a named function stored in a constant, which I'll name sign up handler. There I expect no arguments. And there I then want to dispatch, so we need to get access to that dispatch function by executing use dispatch. And then here we can dispatch this auth actions sign up event or sign up action. Now the problem is this requires the email and the password. And right now I'm not storing this. I get this in my input, but here on input change, I'm not storing that data, which I of course should. Now we can have a look at our other form here to see how we did that. So in the edit product screen, we of course have our form reducer here, which manages our entire form-related validity and the values. So in the end, we can copy that and add it to the auth screen outside of the auth screen component, like this, and go back to the edit product screen to then also grab the part down there where we initialize that with use reducer. So copy all of this and add it to the off screen as well. Now inside of the component, maybe here. And for that to work, we also need to import use reducer from React. And with that imported, now we just need to tweak it a little bit. This form reducer is fine. And by the way, you could outsource this into a separate file because we're using the same type of reducer in both the off screen and the added product screen. You could even create a custom hook if you know how that works. For now, I'll just leave it like this. One thing I need though is the form input update. Let me grab that from the added product screen as well. This constant here, let's move that in off screen as well. So now with that, that's all fine. But down there where I call use reducer and initialize this all, that of course looks differently. We should have an email which initially is empty and a password which initially is empty. And for the validities, it's the same. We just have an email which initially is not valid, and we have a password which initially is not valid, and the overall form therefore also initially is not valid. Now, dispatch form state should be triggered whenever our input changes here. So here in on input change, of course, you know, and you can see it in the added product screen, we get 3 values. We get the input identifier, the input value, and the input validity. So in the end, we can just copy this here from added product screen and move it to the off screen and replace this anonymous function with it. Or actually store this in a new variable here, input change handler, which now holds this function. Now, just as in the added product screen, you should wrap this with use callback to make sure that this doesn't re-render when it shouldn't. So actually, we should grab it here, including the use callback call and the dependencies of use callback. So this is actually what should be used down there on the input change handler. Now, this input change handler can be bound or can be set here to the on input change props so that these props target this function. And now with that, we're storing our form values or our input values in our form state, which we handle with use reducer and so on. So now it's this form state I'm interested in here in my signup handler, because there to sign up, I need to pass form state input values.email and form state input values.password. So these 2 values which were gathered. And now the signup handler here, this function can be bound to this button down there, to the login button here in onPress, because this is the function I want to point at to execute it when we press this button. Let's see whether that works as it should. If I start entering values here, I do get my validation errors, but somehow they're not showing up. That's the case because it's not error message here, but error text on the inputs in the off screen. So if we change that, error message to error text. Now if we test this, if I click in here, tab out of there, I get my warnings. Now if I enter a valid email address, this is gone. If I enter a password that's long enough, that's gone. If I now click log in, yeah. Let's see whether that works. Let's go to Firebase, to authentication, and there you now should see a new user. This is the user which just was created. So signing up works. Now let's make sure we can also switch to login mode and make that work as well. By the way, also note that this here is the data we got back. So that's the response, this object with email, how long the token is valid in seconds, then the token itself, which is this long cryptic string, then also the ID of the user which was created, and the refresh token. Now let's make sure we can also log in. And for that, in the auth action creator, so in the store actions folder in the auth file, we can duplicate this sign up action creator, copy it, and rename the copy to login. This also will need an email and a password, but it will send the request to a slightly different URL. If you have a look at the official docs for signing in, this is your URL. Now it might look almost equal, but here the difference is this word, sign in with password, instead of sign up after accounts : This is what we need to change to have a valid URL again. And of course, therefore, you could also think about ways of merging this into one function and reusing code. I'll explicitly let it split up here to make it really clear that we have two separate functions here. And now with that, we're sending a request to this URL. We still need to attach email password and this return secure token field, which always should be true. And we'll get back pretty much the same data as when we sign up, just one extra field, which basically tells us whether this email is part of an existing account. So other than that, we send the same data here. We can leave it as it is. We want to have this check here. And therefore here, I can then also log my response data. Of course, I don't want to dispatch a sign up action here, but instead dispatch a new login action thereafter. Though we're also not doing anything there for now, we'll soon do so. We can already change what we dispatch. With that, let's see whether that works. But for this, of course, some changes on the off screen are required. Because right now, there, we always, when we press this button, we always sign up right now. And that's not what I want. Instead of always signing up, I want to either sign up or log in, depending on which mode we're in. And this mode should be changeable with the help of this button, which allows us to switch between modes. So in order to be able to switch between modes, we need to manage some additional state in the off screen. Basically a state that allows us to find out whether we're in login mode or in sign up mode. So here I use my state and I start with false because this should say is sign up and set is sign up. And that therefore tells us whether we're currently in the sign up mode or if that's false, if we're in the login mode, basically, because these are the two modes we have, right? So is sign up is false initially because initially I want to be in login mode. And now we can use is sign up to determine what happens when we press the login button, but also which text we output there. So let's start with the text. Here I don't always want to say login. Instead I want to check if is sign up is true. Then here I want to say sign up. And I only want to say login if this is not true. And here, of course, I don't always want to say switch to sign up. What I say here depends on the mode we're in. So here I will now use backticks with switch to, so that here I can inject the dynamic value, which now depends on is sign up. And then the dynamic value either is a string where I say login, because if is sign up is true, we switch to the login mode. Or if is sign up is false, we switch to the sign up mode because we are in login mode. So that changes the text. Now here in this function, I want to call set is sign up and basically invert it. For this, we can use that function form of updating this, where here we get our previous state, so where I pass a function to the setter function here, and I return what previous state is not. So the previous state, of course, is a Boolean, because with is sign up, we are managing a Boolean state, which initially is false. And now here, therefore, I get that current state, and I set the opposite as a new state. So if this is currently true, I set it to false. If it was false, I set it to true. That's what's happening here. Now we just need to make sure that different things happen here. And for that, I'll rename this from sign-up handler to auth handler to be more generic in its naming. And of course, bind my auth handler down there. And now in that auth handler function, we can check in which mode we are. So here I can check if is sign up is true. And if that is the case, then of course I want to dispatch this action. So that's fine. Else, if that's not true, I want to dispatch the other action. And therefore we can even change this a bit. Dispatch down there and define our action up here. And now my action initially is undefined. And then I set action either to this, or I set action equal to auth actions login with form state input values, input values email and form state input values password, like that. And now action is a variable which I can pass to dispatch down there. So I always dispatch this action, but this action is either the result of auth actions sign up or of auth actions login, depending on whether we're in sign up mode or in login mode. With that, we're really flexible. And now if we save this, if I switch here, you see the text updates here on Android as well. And therefore now if I switch to login mode, so if this says login and I try logging in here, make sure you enter the same credentials you used before for creating this, and I press login, this looks pretty good. I get my console output here with the data this URL should return. So that looks like it works. And with that, we're able to sign up and to log in. But of course, we're not doing anything with that token right now. And of course, we also have no error management or loading state management. So these are things we'll also have to add. Let's start with managing the loading state here on the off screen, because obviously I want to give the user some feedback when we're currently waiting for a response. For this, we can import the activity indicator, which you already know, and manage the loading state here by adding another state here is loading, and set is loading, which we initialize to false because initially we aren't loading. And now here, when we are in this auth handler, I can add async here because of course sign up here returns a promise, the same for login. So these action creator functions return promises. So we can await for the result of dispatch, which ultimately uses these promises which we get and basically kicks off this entire process. And before we await this, I can set isLoading to true. So when we start this whole process, before we send the request, and thereafter set isLoading to false once we're done with this request, no matter if it failed or not. And now isLoading can be used to display a loading spinner. It's up to you where you display this. For example, you could say that you want to replace this sign up button with the loading spinner. So here we could say, if isLoading is true, I want to show the activity indicator like that. Otherwise, I'll show the button. So this is the syntax we could use. Set the size here to small and the color to colors primary, let's say. Now, if we give that a try and we go back here on iOS, if I try logging in, indeed, I see the loading spinner and then I'm back. So that works. Now for the error handling. For the error handling, you also learned how that works. You can, of course, manage your error state here as well. You could, again, also use reducer to merge loading and error state into one object, but I'll do it like this. Error and set error with the help of use state, which initially doesn't assign a value, so that this is undefined initially. And then here, we can wrap try catch around this dispatching here, where we get a potential error, and set our error to this error message we're getting back. And before we send the request, I also want to set my error back to null. So now we're storing a potential error here in set error, and I just want to throw an alert, show an alert to the user if we get an error. So for this, you need to make sure that you import alert from React Native and also use effect from React, because use effect allows us react to changes in the error state and show the error alert if we have an error. So maybe here, after setting up the reducer, we can add use effect. And my dependency here is the error state variable or constant. And if we have an error, so if this is true-ish, then I want to show an alert with the alert API where I say an error occurred, and my message is the error, which should be a string, and I will add a button where I have a text of OK. And of course, you could add more buttons where you do different things. Now, we can simulate this in the action creator by going there, and for logging in, let's say we remove that D here, so that this is an incorrect URL in the end. If we now try logging in here, I get this error. Now that's good, but there also are other kind of errors which I want to handle. For example, what if I log in with an email address that doesn't exist? Of course, I want to show an error to the user or two, and I do, but I only show something went wrong, which is not exactly the error I would like to show. Now I'm showing this error because in the action creator, here, if the response is not okay, I throw something went wrong. Now the problem is when we send an incorrect email or an incorrect password, also by the way for signing up, if we send something which isn't an email or a password which is too short, if that happens, then we'll get back a response with a status code of 400 something. And we get some error details as part of the response. And right now with our error handling, we don't see those. So we need to change this. Instead of immediately throwing an error here, if the response is not okay, I still want to look into it. So I will have my error response data, which I get by awaiting for response JSON here. So I do the same as in the success case, but I extract it into a different field. And now here I want to console log the error response data so that we get a feeling for how this looks like. So now let's try entering an email address which doesn't exist again. And now we get our strange error, which I just saw, but now we have this interesting output here. And you see, this is the error object Firebase returned to me. And of course, it depends on the API you're talking to, which kind of error you're getting and when you're getting it and what details it includes. This, as you see, is an object which has an error key, which is yet another object, which has an error code, some details about the errors, and then this message, which is, for example, email not found. And that's the part I'm interested in. In the official docs, by the way, you find more potential error identifiers you could be getting. So in the end, that's what I want to check now. I want to get my error ID, let's say, from the error response data by accessing the error field there, which is this field, which gives me access to this object, which then has this message field. So therefore here I then access message to get this message. And now we can check this. We can check if error ID is equal to email not found. If that's the case, I want to set my own customized message. So here we'll add a variable, message, which is just something went wrong by default. But then here, if we know the problem is that we didn't find the email address, we could say this email could not be found. And I'll add more if checks in a second. So this is something I want to check here. And in the end, therefore, I have a message which I now want to throw. So now I will throw a new error with my own customized message though. So another check I want to add with the else if statement here is whether the error ID is, for signing in, invalid password, let's say. So I can check for that and set the message equal to this password is not valid. And now let's give this another try. Let's go back and enter an email address which doesn't exist. Click login, and we get this email address could not be found, or this email could not be found. Now let's try a valid email address, but actually a password which is invalid, like this. And we get this password is not valid. So now we give the user a better feedback. Now let's implement the same for signing up. So I'll copy that and go to my sign up case here. And there I just have different error codes. There I have codes like email exists, if that email address exists already. So I extract my error ID in the same way, but then I check for email exists. And if this is the error, I say this email exists already. Now this is actually the only thing I want to check here. There are other errors too which you could get. And you can, for example, simply turn off your validation here and see which error you're getting if you're sending an invalid email address by logging that error ID. And then you can check for that too. Here I'll just implement this message. And therefore now if I try signing up here with an email address which I already did use, like this, I get this email exists already. On the other hand, if I use a valid email address, of course, this just goes through. And on Firebase, then indeed, if you go to authentication and refresh this, you will see that second user. So this is how you can add a loading spinner and error handling with authentication. That's all nice, but now it would finally be nice to also leave that screen and go to our app and then start working with that token which we're getting. So how can we leave the off screen now if we are logged in or if we did sign up successfully? Well, that's not too difficult. If we make it past this dispatching here without landing in the catch block, so still here in the try block, we can just call props navigation.navigate, just as we always did, and navigate to the different screen we set up in our switch navigator. So in this case, to the shop screen. So let's do that. Let's simply go to shop. And therefore now, as soon as we do log in successfully, which I'll now do, this loads, and we're here. Now I get a warning here regarding some state update which couldn't be performed. That's this set is loading state, which now fails if we navigate away. Solution is simply we shouldn't try to update the state on this screen if we're not on the screen anymore. So we can simply move that into the catch block because we'll only need to reset loading if we have an error, because that's the only case when we stay on the off screen. Otherwise, we don't need to change the loading state because we're leaving the screen anyways. So with that, we'll get rid of this as well. If I now try this again, here we go. And now we're in our main shop. Now we're still, of course, not utilizing the token. So let's make sure we do that as well. And for that, let's go to the auth reducer and add an initial state there, which describes basically with which state we want to start and what our general state shape is. And there I want to store the token, which initially is null. And I want to store the user ID, which initially is null. So very basic initial state. Then we can export the reducer function, which takes that initial state and which also receives, of course, an action. And here I want to switch on the action type, as always. And I got two cases I'm interested in right now. One is the login action. So you need to import this identifier from the actions folder and the auth file there. And the other case is the sign up action. So you need to import this identifier as well. In other cases, I just want to return my state. So if we do log in, I want to return a new state where the token should be, let's say, action.token, and user ID should be action.userID. And that's the same update I need in sign up, so we can just copy that over there. Now, of course, we need to make sure that our action carries token and user ID. So in the action creator, in the end of sign up here, when I dispatch the sign up action, we need to add a token field and we need to add a user ID field. Now the token can be gotten from the response data. There it's that ID token, and the same here. Res data is not ID token, but it's a local ID. You see that here in the log. Local ID, this here is the user ID. If you scroll up, ID token, that's the token. So that's what I dispatch here. And we can just copy that and use the same, almost the same for logging in. The only thing that needs to change is this identifier. And you could even unite login and sign up to one combined authenticate identifier, let's say, because in the reducer we're doing the same thing anyways. So I just have it split up here to be clear that we have two different things in the end, but the update is the same, so we could definitely combine these two action types. So with that, we're now storing the token, and that's nice. But what do we need this token for again? We need that token, which we're now storing, to access our API. And for that, let's go to Firebase and to database. Keep in mind that when we set up this database, I mentioned that you should start in this test mode, if you remember. What this did is it set up certain rules, and you can check those if you click on the Rules tab. This controls who can read and write to our database. And right now, this is both set to true, which means everyone can read everything, and everyone can write everything. That's, of course, typically not what you want. Instead here, I'll set both to off unequal to null, which might look strange. And this should be double quotes, by the way, here. But this is Firebase syntax, and you can learn more about the rules here by clicking on Learn More, or simply Google for Firebase Real-Time Database Security Rules. What this tells Firebase is that only authenticated users, so only users who send a request with a valid token, should be able to read and to write. Now you could even argue that reading should always be allowed, so we could set this to true, And you could even be more specific regarding the rules so that you say reading from products is allowed, reading from orders is not. But again, that's something you can check with the official docs. I'll go with a setup where reading is always allowed, but writing is not. So now for writing, we need a token. Otherwise, we'll face a problem. If we log in here and we're storing the token, but we're not appending it to requests right now, you see we can load all data. That's fine. But you'll also notice that if I try to edit this and remove a couple of exclamation marks here, in the end I get an error. And that error is thrown because I'm not allowed to write. And Firebase therefore blocks the access and returns an error response. So now we need to leverage the token which is stored in the reducer and actually append it to our outgoing requests. Now for that, first of all, we need to register this reducer in our root reducer. So in the app.js file, we need to import it. We need to import the auth reducer from the store, and there the reducers folder, and there the auth file, and add it to combine reducers, maybe here with the auth key, but of course you can use any key you want. That will allow us to then leverage this and access this token, but now we need to attach it to the outgoing requests. For example, for products, we need to attach it to the request we send for updating products. So that would be this request here. Now the way you append a request in Firebase can be found in the official Firebase docs for the real-time database user authentication here. There, in the end, what you learn is that you can append a token to your outgoing request simply by adding that auth query parameter at the end of your request URL. So here in the end, we need to add $auth equal, and then here we need to have our token. Now, how can we get access to the token here? We're in the action creator, which means we have no easy access to the store here, to the Redux store. Or do we? Redux Func, that nice package which allows us to write this syntax with that function that receives the dispatch function, that actually gives us something sweet. We can also change this function a little bit and not just get dispatch, but get a second argument as well, which is another function which gives us access to the Redux state. So we get access to the current state of our Redux store. So if I console log the result of get state here, let's see what that gives us. And to avoid errors for the moment here, I'll just add an empty string so that we can test this code. Of course, this will not work, but we'll fix it soon. So let's see what's inside of get state if we execute this. So time to log in again, real quick. And then go to the admin screen and try editing this, which of course still will fail. But that doesn't matter, because now if I do click here, yes, it fails, but what you'll see is that here in the log, what we get is a full output of our complete Redux store. This is our Redux store. We get an object with our auth state slice, which has yet another object with our token and with the user ID, our card state slice, our orders state slice, and our products state slice. So this allows me to get access to my Redux store and get access to the token. So the token can be fetched by executing getState.auth.token. Because this gives us access to our full Redux store, this then gives us access to the auth slice, and this to the token property, which we're managing in that auth slice. And now, in the products action creator, we can add this token here in the end. So here we can just replace this string with the token variable which holds our token. And now if we save this with this little change, if we now log in again, and later we'll also change this such that we don't constantly need to re-log in, no worries. If we log in again, we go to admin, click on edit here, and now we try this. This works again because now the token is appended, Firebase validates it and it determines that it's valid because of course we haven't mingled with it, it's a valid token, and therefore this just works. Now we don't just need the token when we update our products, we also need it when we add a new product. So I'll copy that logic and add the same logic here. When we create a product, I get my token with the help of that second argument which we can get here if we need it, the getState function. And this allows me to change these single quotes to backticks so that I can conveniently add that query parameter here at the end with question mark auth equals and equal that to my token. So now we can create a product and update a product. Deleting, of course, also is a write request. So for delete product, I'll do just the same, get access to my store with the getState function here, and then also add question mark auth here at the end and add the token. So that's one thing. Now in the orders, it's a similar thing. There for fetching, we don't need it, but for adding, we do, because adding is a write operation. So there we get the state if we want to. We can extract the token from there with the same approach as before, and we can append this here. And there we'll actually also need the user ID soon. So we'll take care about this in the next lecture. But for now, just make sure you append the token everywhere. And now let's see how we can also make sure that orders actually really belong to our user. We're adding tokens everywhere, which is important. But for orders, we don't just want to append the token, we also want to make sure that orders really belong to the logged in user. Now the good thing is we're storing the user ID, which Firebase generated in our Redux store. So mapping our orders to users isn't too hard. We get access to our full store here, so we can get the user ID by calling getState.auth.userID. That's all. This gives us the user ID of the currently logged in user. And now we can inject this here and replace the hard-coded U1 with user ID. Of course, not just for adding orders, but also for fetching orders, because we want to fetch the orders of the currently logged in user. So here, let's also receive that second argument, get our user ID, and here exchange single quotes for backticks so that we can use this dynamic, convenient injection here, and then replace or interpolate, as it's called, this string here by adding the user ID. So this now also makes sure that the orders are stored correctly, but of course it's not just the orders. The products also should be stored such. We should make sure that when we create a product, we actually do add our owner ID to it. That's something we're currently not doing, and that's something which we should do. So here, I actually also want to get the user ID here in create product. And when I then send my request to create a new product, I don't just want to save title, description, and so on. I also want to set a owner ID field, and the exact name is up to you, which is equal to the user ID of the logged in user. And that's now something brand new. Now we really start mapping products to a user, something we only did in a dummy way before. This also means, by the way, that when we dispatch create product here, I want to pass a new piece of information. I want to add the owner ID there as well and also point at the user ID here. And that means that in the product's reducer, we need to respect this. And in there, instead of hard coding this ID here, we can now get this from our action.productData from owner ID there, because that's what I just added there. So here, products, I added owner ID, I added this key to product data to the action I dispatch. Now in the reducer, we have to use that, extract it here, and use that as an owner ID of the product we create locally in Redux. Of course, this also means that here, when I get the products that belong to that user, I also want to make sure that I filter correctly for the correct ID. So when we call set products here, I want to make sure that user products are really filtered down to the logged in user. So in the products action creator, when we fetch all products here, of course I do want to fetch all products, but there I also want to be able to get my state so that I can get my user ID from the state. Because then here, when we create the loaded products, I don't just want to forward those, I also want to add a new user products key to my action object, where I take the loaded products, and here I filter them, and I have a look at each product, and if the owner ID of the product, if that is equal to the user ID, then I want to keep it, because then it's a product created by the currently logged in user. Otherwise, I'll not keep it. It's still part of the loaded products, which I pass to products, but not part of the products I pass to user products. And that allows me to go back to the reducer, and there in set products, user products is initialized not by filtering here, but by setting it equal to action user products, which now takes the filtered products filtered in the action creator with the logic we just wrote, where we take the user ID. This makes sure that we only see the products we really created, and we don't see the products of other users. Now, of course, by the way, we can now also make sure that in our products store here, we don't start with our dummy products, but we actually start with an empty array in both cases here. This also means, of course, that now if we save this and we log in, we should be able to view our previous product. Here it is. But if I go to admin, we don't see it there. That makes a lot of sense because this product was created earlier in the course, and therefore it has no owner ID. This product has no owner ID. So therefore, it's not included in any user's products, which is great because now I have a nice example that there are no products yet. Maybe we should also show a message here. As a side note, in orders, we also don't see anything, and maybe we should show a message here as well, because orders for U1, that's now not a valid user ID anymore. So these orders are never loaded for any user. And that's good because that's how it should be. So now with that, I'll just tweak these pages a little bit to show a message if we can't load any data. So here in the user products screen, if user products length is equal to 0, then I don't want to return my flat list, but instead I'll return a view here where I have a text where I say no products found. Maybe start creating some. And we'll need to set up some styles there. We also need to import view and text. Otherwise, we can't display this. And now I'll just do some quick and dirty inline styling here with flex1, justify content center, and align items center. Of course, you could also assign your own font here to the text and so on. I'll just do it like this. And then copy this and move it over to the orders screen. Make sure you import view and text there as well. And then here we can also add this check. If user products length is empty, of course, here we should check orders length, not user products length. But if that is empty, I say no orders found. Maybe start ordering some products like that. And with that, we should be seeing that text if nothing is found. So if I now try this again and log in real quick, and we go to the admin page, we see the text here. And if we go to the orders page, we also see the text here. So now that's working as it should. If I now create a new product on the other hand, for example, a scarf, let's say, with a nice little URL, which I selected for $59.99, a woolen scarf. If I do that and submit this, this works fine, and it also shows up here under admin, also shows up under products. We could, of course, also filter it out there if you wanted to, but why not? Why don't we have it here too? And if I add this to the cart and I click order now here under orders, we see it. And on Firebase, we also see that under orders, now we have a node with our user ID with our orders. So this is now really working in the way it should here on this application. And therefore now here we have a setup with which we can work. So we're fetching data, writing data, we're using our token to authenticate ourselves, to get access to restricted resources. We're using the user ID to scope our products and also to scope our orders. With that, we have the application which we can see here. Now, one thing I noticed here is that if I log in and I go to my admin section, I still don't see the product I just created. So something's wrong there. Let's check our products action creator where I fetch the products and where I do the filtering. There I check that the owner ID on the product I'm looking at is equal to my user ID, but yeah, here, of course, I have an error. I still have my hard-coded owner ID. That owner ID here, well, that should, of course, be retrieved from the backend. So there, for REST data key dot owner ID, I want to take the owner ID I get from the data I fetch on Firebase. So with this change in place, now if we do this again and we do log in again, if I now go to admin Now I see my scarf there. So we achieved a lot. We're able to write data, fetch data, use our token to scope data or to scope products and orders to our currently logged in user. We are able to log in and so on. So that's all nice. One thing we're not doing right now is we're not persisting our sessions, so to say. If I reload, I always have to log in again. That's not really what I want. It would be nice if we could automatically log in if we do have a valid token. And for this, we need to do two things. We need to store the token somewhere on the device, not in Redux, because Redux is in memory and this will be lost whenever the app restarts. So it needs to be somewhere on the hard drive of the device, so to say. And in addition, we need to check that storage whenever our app starts and automatically set the token in Redux and redirect the user if we do find a valid token there. Now let's start with storing, because that's the logical first step. To store, we need to import something here in the, not in the products action creator, but actually here in the auth action creator. There you need to import async storage from React Native. With that imported, we can use that to then save data to the device. Async storage is a React Native API that in the end uses a key value storage on the device, which is available both on iOS and Android, where we can store data that persists across app relaunches. So which we can use to save data that is not lost when the app launches or restarts. So I'll add a new function, save data to storage or anything like that. And there I expect to get my token and my user ID, the two pieces of data I'm interested in here. And we can now use the async storage to then set an item, which is how you save data. And that item which you set needs to be a string. But first of all, you need to define a key, and I'll name it user data, but that's up to you. You will need that key later to retrieve your data. And the second value now is a string, so the string which you want to save in there, and you must save a string essentially. Now that's no problem. We can use JSON stringify to convert a JavaScript object to a string. And the object which I want to convert is an object that holds my token, which I get as an argument here, and that holds the user ID, which I get as an argument. So in the end, we then save this object as a string to the device. Now we just need to call save data to storage whenever we're done logging in or signing up. So here, maybe after dispatching login, we can call save data to storage and forward restdata.id token and restdata.localID. So the same things we use in Redux, and we definitely want to use them there because Redux is important for the running application. But I also save it to the device for when we want to load it when the app restarts. Now, however, that alone won't do the trick. And we, of course, also need to do it when signing up. But that alone won't do the trick. We'll need one extra piece of information here before we continue. Do you know which? We need to know how long the token is valid, because you must not forget that eventually it will expire. Which is why for logging in and signing up, you get that expires in key in the response, which tells you in seconds how long it takes until, well, your token is invalid and Firebase won't accept it anymore. We need to store that information as well, because if we later come back, if we restart the app after 3 hours, our token is probably invalid. So we need to know when the token will invalidate so that we, when we check that, when the app restarts, when we check whether we do have a token, we know whether that token we might find is actually still relevant, or whether it's invalid already and we need a new token anyways, in which case we shouldn't auto log in the user. So I want to store the expiration date. Now we'll create expiration date here as a constant, a new date object, which in the end should take the current date and add the expiry time. Now, new date takes a date object, but with getTime, we get the current timestamp in milliseconds since the beginning of time, so to say, which is in the year 1970 in JavaScript. So that's an amount in milliseconds, and to that we can add restdata dot expires in. This is an amount of seconds, so we need to convert this to milliseconds, and it's also a string, so we need to convert it to a number. So here I'll add a plus here, or simply parse int alternatively to convert this to integer. And then I multiply this with 1000 to convert it from seconds to milliseconds, because getTime also gives us milliseconds. Now what this gives me is a new timestamp in the future, which is the current time plus the expiry time. And I wrap this into another date object to convert it back from a huge millisecond number to a concrete timestamp date object. This expiration date is now what we also need to pass to save data to storage. So here I expect to get the expiration date as well, and we need to enclose this here. So here I can name this expiry date maybe to mix things up. This is my expiration date, and there I want to call this nice little toISOstring method, which we can call on date objects, because this will convert it to a string in a standardized format, which I want to save. Now this is what I want to do for signing up as well. So this can be copied over there, and this is what I want to do there as well. Create the expiration date and save that to storage. Now we're saving that to storage, which is nice, but now we also need to check this when we're logging in. A nice way of doing that is to create a new screen, and I'll actually create this outside of my existing folders, in the screens folder, but neither in shop nor in user, and I'll name this startup screen, and you can name it however you want. The idea is that I show this screen whilst my app is booting up and I'm figuring out whether the user is authenticated or not. And this will be super fast. Chances are we won't even see that screen when the app starts. Now in here, we create a regular React component by importing React from React. And in there, I import stuff from React Native. To be precise, I need a view, the activity indicator to show a loading spinner whilst the app is booting up, and also style sheet, and also async storage, because here I also want to access the async storage to find out whether we do have a valid token or not. So here I then have my startup screen component, which is a regular React component, and the style sheet object here with style sheet create, and in the end we can export the startup screen like this. Now in the component, I'll simply present the activity indicator here with a size of large and a color of colors.primary, and for that you need to import that colors constant, of course, and also assign a little style here to the view. And I'll just take styles.screen here, which we can now add to the style sheet. And that should be very simple. Flex 1, justify content center, and align item center for some vertically and horizontally centered content. Now, of course, the real important stuff happens above the JSX code. This is where we now need to check the async storage for a valid token. And I can do this with the help of useEffect, which allows me to run some logic here when this component mounted. And indeed here, I won't need any dependencies, because here inside of useEffect, I now want to add a new function, which I'll name try sign up, or try login is more fitting. And I use this separate function because here I want to use async await, which I can do by creating that inner function, which I can now call here try login, because again, async here on this function, which you pass to useEffect, would not really be allowed. And here in try login, the goal now is to check the async storage for a valid token. So I get my user data here by accessing async storage.getItem, and then use the key you used for storing. So in my case, that's user data, but you must use whichever key you used in your auth.js file in the actions folder for storing your data with the async storage. So I retrieve this, and now the important thing to know here is that getItem, like all async storage methods, actually is asynchronous, which means, like the name suggests, I guess, which means that you get a promise here. So we can await this, and this will give us back our user data. Now this is then the data as a string. To convert it to a piece of data we can work with, I'll have my transformed data with JSON parse user data. And this parses a string in JSON format and converts it to a JavaScript object or array. Now before even trying that, I'll check if user data is not truish, so if it's not set, if we can't find any data for that key, because then I know we're certainly not logged in. So here I want to return and not continue and do one important thing. I'll use props navigation and navigate to the off screen. Because this startup screen has to be added to the navigator. So here we can import it, import the startup screen from the screens folder, of course, startup screen. And we add it to the main navigator here. So where we also have off and shop, and there at the very top, I add startup and point at my startup screen. This means that this is the first thing I load here. Now on the startup screen, I therefore go to the off screen if we can't find a token. So thanks to the switch navigator, I leave that screen and go to the off screen or to the off stack because I don't find a token. So if we make it past this if check, we at least have some data, but the token still might be invalid. So we will of course have the token, the user ID, and the expiry date, which we can extract from the transformed data. Whoops, after this line here with this object destructuring syntax. And these are the three pieces of data with the three exact same names as I store it here in the auth.js file. So here we have an object with a token, user ID, and expiry date field. That's what we store in async storage. That's what I can retrieve here. Now we need to check whether the token is still valid. And for this, I can recreate my expiration date by using new date and passing expiry date, which is actually a string in ISO format, to it. And now we can add a if check and see if expiration date, so the date when the token becomes invalid, if that's smaller or equal than new date, which is the current timestamp, which means expiration date is in the past. And if that's in the past, then our token is invalid. It's also invalid if we can't find a token, or also if we can't find a user ID. If any of the three conditions is true, we have an invalid token or an invalid user ID or anything like that. So in that case, I also want to return and of course navigate away to the off screen. If we make it past this if check, we do have a token, we do have a user ID, and the token is still valid. So if we make it here, I will call props navigation navigate shop to go to the shop screen, and also important, I need to log the user in. And for that we need a new action, because I don't want to send a request now, I just want to change some data in Redux. So I'll add a new action creator here, export const authenticate maybe, which takes my user ID and my token, and which then is used to change my data in Redux. And for that, I will now add a new action identifier, authenticate, with a string of authenticate here, and use this here as a type, authenticate, attach my user ID, which is my user ID here, and my token, which is the token I get as an argument. And now this authenticate action is what I want to dispatch here on the startup screen. Now before I do that, by the way, we can also go back to the action creator, and at the end of signup, instead of dispatching my own custom signup action here, we can also dispatch authenticate and execute this here, this action creator, and simply forward rest data dot local ID as a user ID and rest data dot ID token as a token, and do the very same at the end of login. So now I did indeed combine these two flows, because in the end the same thing happens. So now in the reducer, in the auth reducer, of course, instead of checking login and sign up, we can simply import authenticate and use this identifier here, get rid of sign up, and I'll just comment it out to still leave it here for reference because the same thing happens. So now combining it makes sense because we also need it for this automatic login. So here I then also dispatch it here for the manual login and the manual sign up. And of course now with that, if you want to, you can also get rid of login and sign up here of these two identifiers because we don't use them anymore. But with that, back to the startup screen here, we can now also dispatch this. And for that, you just need to import, use dispatch from React Redux, and import the action. So import everything as auth actions, maybe, from the store folder, from the actions folder, and from the auth file there. And then here at the beginning, get access to the dispatch function by calling use dispatch. And with that available here, we can add dispatch as a dependency, but this will never change. So the effect will never rerun. And here, after navigating to the shop, I now also want to dispatch auth actions authenticate and forward the extracted user ID. So this field here, and the extracted token. So this field, which I got from my async storage. And that should now automatically log me in. Was a lot of work. Let's see whether that works. If I reload this, I end up here on the login screen because right now I have no valid tokens stored in async storage. So now if I try logging in here, I'm forwarded. If I now reload, I again end up here. And that's great because now this means that this seems to work and the token is stored. Now, of course, it would be nice if we could also log out though, because right now there's no way of doing that. Now to log out, we need a new action which we can dispatch. So in the auth file in the actions folder, I will add a new action creator. Doesn't really matter where you add it. I add it down there and I export it and name it logout, which, well, sounds like a fitting name to me. I expect no arguments there. And I need an action identifier for logging out though. So here we can export const logout with the logout string. And now use that down there. And in this action creator, which is a normal action creator where I don't need to send any HTTP requests or anything like that, I just dispatch this logout action in the end, or I create this logout action object. Now we can use that. And I want to be able to log out with the help of the side drawer. In the side drawer, I want to have this logout button. That means that we need to do something which we haven't done before. We need to add a new button to the side drawer. Thus far, we only had the automatically created buttons. But adding your own content isn't too hard. For that, let's go to the shop navigator file where we set up the drawer. Here it is. And then here, besides my content options, you can also add a content component here. This allows you to add your own content for the side drawer instead of the default content. Now this takes a function which receives props, because in the end this is a React component which you add here. So it gets props and it has to return some JSX. And therefore you need to make sure you're importing React from React, and we'll also need a couple of other imports. We also need to import something from React Native, and that should be the safe area view. And I also want to import the button from React Native. In addition, from React Navigation, we need to import the drawer items, and also from React Native again, I also need the view. Now with that imported, let's go down to our newly added content component. And here we can now return a view with a style of flex1. You can of course also add a style sheet. I'll just add an inline styling. And by the way, this component could of course also reside in a separate file. It doesn't have to be created on the fly in this file. Now in this view, I want to have a safe area view, and there make sure you add force inset equal to top always horizontal Never. And this just controls how this is laid out. And in that save area view, you should now add the drawer items, and important, pass props to those, because these are the default drawer items which are rendered, and that should still be the case. And in order for them to be configured correctly, you need to pass in props, which is in the end passed in by React Navigation and holds all your drawer config and so on. And now you can add your own extra drawer item here, and that will be this button, the default React Native button, where I say log out, where I want to add a color of, let's say, colors.primary, and where on press I now want to dispatch this logout action. And now we'll have a huge problem here. How can we dispatch this from here? Now, first of all, if you save this, you should be seeing this. So here, if you expand the drawer, here's the logout button, right? So this works. And of course, you can style and position this however you want. And by the way, just to double check, we can also see this on Android. If we do log in there, here in the drawer, we also have the logout button. By the way, we might want to add a little bit more padding on the top. But how can we dispatch everything? And I will add some extra padding here of 20. Because my save area view works, but it does barely leave more spacing than I need. So in order to have some extra spacing, a little bit of padding can't hurt. I think that's better. But again, how can we now make sure that we can dispatch an action here? Well, this is a React component, right? So in the end, we can simply use dispatch here. So we can import, use dispatch here from React Redux. So what we did before, and use that in here, because you can use this hook in any component, and this is just a component. So in here, before we return JSX, I can get access to my dispatch function with use dispatch. And therefore now here, when we press this button, we can call dispatch and dispatch our auth action. And for that, of course, you just need to make sure you are importing it. So import everything as auth actions from the store folder, the actions folder, the auth file. And now use auth actions to create that action. Here, auth actions.logout, logout like this. And this should dispatch the logout action. Now, besides that, I also want to navigate away. So we can also call props navigation.navigate. That will be available here. And go back to the off screen here. So basically to this off screen here in the switch navigator. Our drawer is part of the shop navigator, so we can also go to the off screen from there. Now, when we dispatch logout, I want to make sure that in the reducer, we're also doing something. We have our logout action creator here. So in the reducer, in the off reducer, I want to add a new case, the logout case. And for that, you should make sure you're importing the logout identifier. And of course, here it's very simple. I return my initial state, which at the end means that the token is reset and the user ID is reset. And now let's give this a try. If I go back here and I now click log out, I'm back on the off screen. So that works. Let's also give it a try on Android. If I click on log out here, we're back. So this is working. We're almost there with that. But we also should be logged out automatically if the token expired, because it has this expiration date. And right now we have no automatic expiry. So to make sure that we're logged out when the token expires, I'll add a new function in our auth action. So in the actions folder in the auth.js file, I'll add a new function here where I want to set a timer that basically expires when the token is expired. So we can call this set logout timer, for example, and there I expect to get the expiration time. And in here we can use the good old set timeout, which React Native supports in its JavaScript version, to set a timer that expires after this time. And let's say this is a value in milliseconds. So that's just an assumption I have, and we have to make sure that we pass the data in milliseconds, therefore. Thereafter, this function here will execute once the token expired. And there, the question is now, what do we do there? Well, in the end, I want to dispatch logout here, right? So therefore, set logout timer should probably not be a normal function, but actually here, I will have a function which takes advantage of Redux func. So where we have this function in a function, where this inner function gets dispatched as an argument, and therefore, once this async task finished, once this timer expired, we can dispatch logout. So we can dispatch the result of this action creator, which is this action in the end. So that happens when the timer is done. Now, when we do logout, I also want to clear any running timers, because maybe we have that automatically set timer here, which we're not setting yet, but we'll soon do. Then I want to clear that timer when we manually log out, so that I don't have that ongoing timer, even though it's redundant. So we can add a new variable, maybe at the top of the file here, which I'll name timer, which is uninitialized initially. And then here, when we set a timer, I will set the result of set timeout to timer, or store the result of that in timer, which is a pointer at this timer, and add a new function, maybe here, clear logout timer, which is now a normal function, not a function that gets this dispatch inner function, but a normal function, where I simply call clear timeout timer. And timer is that variable which points at the timer. I just want to check whether timer exists if it's not undefined. And if it is not undefined, I'll call this. Clear timeout is a built-in function, built into JavaScript to get rid of that timer. So with that, we can clear the timer if we don't need it anymore. And I want to get rid of it whenever we log out. So whenever this happens here, I will call clear logout timer. And one other thing I need to do when I log out is I need to clear my async storage, of course. So here I can call async storage remove item user data. Again, using that same identifier I used for storing the data. So I used user data down there. I need to use the same identifier for clearing it. Now remove item returns a promise, and we could wait for this. In that case, we would need to return that inner syntax where we get dispatch and we do our async tasks. So we move this code here into that, and then here we can dispatch this action. We could do all of that if we're interested in the result of remove item, but here I am not interested. I'll just fire this, and I don't wait for this promise to complete. Instead, I immediately return this new action object, and I trust that this will complete. Now, of course, you could restructure this, but that's how I will do it. This should remove the data from our local storage. So with that, logout does this. We have the logout timer function, which sets a timer, which does log out once this expires. Now we just have to make sure that we dispatch this set logout timer action creator here, that we use this action creator. And I want to use this whenever we authenticate. So we have this authenticate action here. And there in the end, I need to dispatch set logout timer as well as this here. So there I will now actually use this different syntax where we got this inner function which receives dispatch, so that here I can dispatch set logout timer, so that this here is triggered. And of course this also means that here, instead of returning this, we also need to dispatch this. So we dispatch two actions here, which is absolutely fine. So I set my timer and I then dispatch the authenticate action. Now, of course, the logout timer needs to know how long it should take. The expiration time is required. And I expect to get this expiry time, just to mix up names, as an argument here in authenticate, so that I can forward this here to my logout timer. That means that every place where we dispatch the authenticate action, or where we use this action creator, I should say, every place where we do this does not just need to provide the user ID and the token, but also the expiry time. And that starts here with sign up. When we sign up, we have our expiration date here, and we dispatch authenticate. Now authenticate also needs the expiry time. Now the good thing is here, it's very easy to find out when this expires because we have it in the response data. There we have this expires in field, which is of course a string. So with parse int, we can convert this to be a number. And then this will be in seconds. Authenticate and set logout timer expect values in milliseconds. So I will multiply this with 1000. And I will also add this in login, of course. There, I will also add that as a third argument here. So that for login, when we dispatch this authenticate action, we also forward our expiration time, which we're getting back from Firebase. Now we also have one other place where we need to do that, and that's the startup screen. Because there, we also dispatch authenticate. And here we need to calculate the remaining time, because this kicks in whenever we restart the app. So here we don't know how long it will take for the token to expire. We need to calculate this. So here we have I can calculate the expiration time by basically taking the expiration date, which is a date object, and calling getTime on it, which gives me its timestamp in milliseconds since the beginning of time. And from that, I have to deduct the current timestamp getTime. So the current timestamp in milliseconds. This will be in the future. This is now. So the difference should be a positive number because I'm checking that this is in the future here. So this should be a positive number in milliseconds. So now the expiration time here can be forwarded to authenticate. With that, we should have auto logout as well. Now to validate that this works, let's go to the auth.js file, and actually there, in the setLogoutTimer function, I'll temporarily divide the expiration time by 1000, which means I'll divide the milliseconds by 1000, which turns them into seconds. And that means we should be instantly logged out now. If I reload, I am logged out, but you will soon notice that this only theoretically works. If I do log in again, I'm logged in, and now since I divided the value by 1000, I should be logged out after 3.6 seconds, but I'm not. I can navigate around, but if I reload, indeed now I'm logged out. So it kind of cleaned up the data, but it didn't navigate us back to the off screen. And the reason for that is that we never instruct React Native to navigate us back to the off screen. So that's the missing piece. Clearing our Redux store is nice, but in reaction to that clearance, we need to make sure we're taken back to the off screen. To make sure that this happens, we need one place which is always rendered, which wraps our entire app, where we can listen to our Redux store and find out when our token is reset to null, so that if that happens, we can navigate back to the off screen. Now that would be the app.js file because that wraps everything, but the problem is in there I set up Redux here. So Redux in my store is only available inside of here, so in nested child components. And that's already my navigator component to which I have no direct access. The solution is to simply wrap this with another component. I'll create that in the navigation folder because I'll name it navigation container. Now this is a normal React component, like this, where I don't need anything from React Native, but where I just set up my navigation container component where I receive props and return some JSX in the end and export this as a default navigation container. Now in there I want to set up my navigation, so I'll import shop navigator from the shop navigator, which is in the same folder. And that will be what I return here, my shop navigator, like this. Now I can use my navigation container here in the app.js file. So instead of importing shop navigator here, I import my navigation container from the navigation folder and from the navigation container file, and use navigation container here instead of the shop navigator. Now this is simply a wrapper around the shop navigator, but since it's inside of the provider, I now have access to Redux there. So in here, we can import use selector from React Redux and use that here to tap into Redux. So here in the navigation container, I can simply get access to isOff, let's say, by using use selector. That takes this function, which gives me access to the Redux state. And then I can access state.auth.token to get access to the token in my auth state slice, and use the double bang operator to basically force this to be true or false. And if we have no token, this will be false. So isOff will be false in that case. If we have a token, it will be true. So isOff is true if we have a token, which makes sense, I guess. Now we can use effect here to react to changes in that. So here in use effect, my dependency array includes isOff. So when isOff changes, this effect function should run. And therefore here, I can then check if we're not authenticated, because that's what I'm caring about. If isOff is not true, if it is true, I don't care. But if it is not true, then I want to navigate to the off screen. And now we have another problem. The navigator is here. And only in components that are rendered with the help of the navigator, we have access to props navigation.navigate. But thankfully, React Navigation gives us an escape hatch. We can use a ref to get access to the navigation functionality with the help of this component when we use it in our JSX code. We can create such a ref with useRef, with the useRef hook. And we simply create our nav.ref here by calling useRef like this. And you should be aware of references in React, which is basically a way for you to directly access an element you render in JSX. And now we can add the ref property to the shop navigator and assign this to nav.ref, or the other way around. So this establishes a connection between the nav.ref constant and this element, which in the end is rendered here. And now with this here in the effect, we can call nav.ref.current. This is how refs work. They have a current property. Dispatch. Dispatch is a method made available by the shop navigator, or by this app container, which it is in the end, because shop container is nothing else than what shop navigator.js exports, which is such an app container component. And this component has a dispatch method, which we can use to dispatch a navigation action. For that, we now need to import something from React Navigation, and that something is the navigation actions object here. And then here we call navigation actions.navigate, and now this allows us to navigate. However, not with auth like this, but this requires an object as an argument where you set up the route name, and this can now be auth. So this is how we can now navigate from inside this component, even though it's outside of the navigator. So this goes to auth whenever our isOff state changes to not authenticated. This, by the way, also means that in the shop navigator, in our logout button, we don't need to navigate here, because if we trigger logout, if we dispatch this action, we clear the token in Redux, and therefore this should automatically trigger our navigation thanks to this navigation container. And therefore now if we save that, we should navigate to auth when the token is invalid. So now if I log in again, after 3.6 seconds, we should be logged out, and we should see that we are logged out. Yeah, that's looking good. Let's give it another try here. Yeah, going back. And let's also try manual logging out. So if I go to log in, open this, click log out, this also still works. So with that, we got the auto logout functionality built in. Now let's go back to the auth action file and remove this dummy division here, because I only did this for testing. Of course, I don't want to manually shorten my expiration time. Instead, now here we have a functionality that works, and that makes sure that no matter if we're signing up or we're signing in, or whatever we're doing, we have a token which we store, which we can use, and we're making sure that we're also logged out automatically if our token expires. This is the finished application here. So this was a bunch of work which we spent here on this app, on this shop app. You learned a lot about how to build apps in general, how to handle user input, how to store data on servers, and how to add authentication with users, scope data to your users, how to add auto login and auto logout, and so much more. Now you can always dive deeper, add authorization, add extra checks, use that refresh token, and these are all great practices. But with the things you learned in this and the previous modules, you should have a very solid set of skills together with what you learned earlier in the course to already build amazing native applications with React Native, with all these core features you need in so many applications. Now, missing pieces, which will be covered in the next modules, of course, are, for example, how you can tap into native device features, like using the camera or maps, and we'll have a look at this there. So, let's continue. In this course, we obviously covered a lot of the important things you need for building native apps with React Native. Navigation, state management, how React Native works in general, how to work with components, and so on. Now, one thing we haven't used that much though, and that's tapping into native device features. Obviously, for many apps you're about to build, you want to use features like the device camera, or add Google Maps, or get the user location, or maybe store some data, some more complex data on the device, and therefore you need an on-device database like SQLite. So these are things which we haven't really had a look at in this course yet, and we'll have a look in this module, therefore. In this module, in detail, we'll dive into how you can easily enable such native functionalities in your React Native app built with Expo. And by the way, just in case you're worrying, in a separate module later, I will also show how that would work in non-Expo apps, so that you really know how to build any app with any toolset that you want. So with that, let's see what we're about to build in this module before we then dive right in. So what will we build in this module? We'll build a simple app, and in this app I'll not focus too much on the app itself. We'll build a basic app here, we'll not add too many features because I instead want to focus on all these core native device features. So we'll build a simple application which allows us to manage some great places we found, let's say. So on the starting screen we'll have a list of those places where we maybe have an image, then the title, and then here the address of that place, and we'll have such a list here where we can view all these places. Now, once we tap such a place, we're taken to the detail screen for that place, where we see a bigger image, where we then also see the address, and below that we see a map preview, which we can also tap to open a full screen map. So to go to a new screen essentially, where we of course also can go back, just as we can go back here, by the way. So where we can go back, where we then see a full screen map representation of that place. Now, of course, to add new places, we'll have a way of doing that. We'll have a plus or a create button here in the menu. And when we tap this button, we're taken to yet another new screen, which allows us to add a place. Now on this screen we can enter a title with a regular text input, but we can also, and that's now the interesting part, we can also take an image and display a preview here. So we have a take image button here below that, which we can press, and that should open up the device camera, of course, so that we can take a photo with the device camera. And below that I will also have a map preview, and we can locate the user. So we have a locate button here, or choose on map button, which obviously should fit onto the page and not overlap it. But these are the two buttons we'll have here: choose on map and locate, and that will then, well, either pick the location where the user is currently at and populate this map preview with it, or if we click choose on map, we'll also open that full screen map here, but now in a mode where we can tap on a place there, and then this place will be selected, and we can then click save up here to save that place and use that place here for this screen. And there ultimately we'll also have a save button, which we can press to add this new place. Now, new places will be stored in a SQLite database. Now, of course, you might want to store them on a web server, but you already learned how that would work. So in this module, I want to focus on a new storage technique, which you also need in some apps, where you store something on the device in an on-device database. And that is, of course, also a common scenario. Not all data needs to be stored on web servers. Maybe you have an app where you need to store everything on a web server, but you also might have some data in some apps which you only need to store locally on the device. The advantage of storing it locally, of course, is that you need no internet connection. The disadvantage is that it can't be shared with other users, but if it's exclusive to this app installation, then you might absolutely want to store it locally. So therefore, this is what we're about to build. Regarding the navigation and so on, it's not the most complex app because we had plenty of practice with that, but we'll have plenty of amazing native device features in there. Camera, maps, user location, file storage, and also SQLite. So with that, you'll have a solid understanding of how to tap into such features and add them to your application once you're done with this module. So for this module, attached you find, again, a simple starting project. There you have the app.js file with an empty view, so not too much happening there. You get a constants folder with a basic color, which I set up for you, and that's it. Other than that, there is nothing interesting in here. It's a very basic application, which we'll now use to build this application, which I just sketched out. Now, of course, you can absolutely go ahead and build the basics on your own. So these 3 different screens which we in the end need, or 4 different screens, one for all the places, one for the place details, one for creating a new place, and one for that full screen map, which we also want to show. You can absolutely do that and build the base skeleton for these screens on your own. Also set up the basic navigation, because these are, of course, all things we already did multiple times in this course. It's also things I will start with in the next lectures in case you want to follow along there or compare your solution to mine. And thereafter we'll dive into the meat of this module. We'll dive into how to add native device capabilities. So let's get started with the basics therefore. I'll add a new folder, screens, with the 4 screens I want to have. And that would be the places list screen file, the place detail screen file, the new place screen file, and also the map screen, where we can then see this full screen map. And I'll populate them with content throughout this module, but these are the 4 basic screens which I'll need. I'll also add a navigation folder so that we can set up navigation in there, and here I'll set up my places navigator.js file. Now in the starting project, I provided React navigation and all its dependencies are already installed. So if you're using that, you don't need to manually install it. Otherwise, if you're using your own starting project, make sure you install React Navigation with npm install React Navigation, and also make sure you install these extra dependencies here to make sure that React Navigation works with Expo. So with that installed, now of course we can set up navigation here in the Places Navigator. And for that, in here, I'll import from React Navigation. And what I'll import is, of course, the stack navigator creation function. So create stack navigator and also create app container, which we also need to do because we'll need to do both, create a stack navigator and set up the app container thereafter. Now we also need to import the screens we want to work with, and that would be the places list screen, which I'll import from the screens folder, and there it's the places list screen. We'll also need the place detail screen, of course, place detail screen, which is imported from screens place detail screen, and also obviously the other 2 screens. So we got the new place screen from screens new place screen, and last but not least, we also need to import our map screen here from the screens folder, and then that would be the map screen. Now we can set up our stack navigator here, and I'll store this places navigator in a constant. And as you also learned, we're now mapping identifiers to our screens. So we got maybe the places identifier mapped to the places list screen. We got the place detail identifier mapped to the place detail screen. We also got the new place identifier mapped to the new place screen, and last but not least, maybe map mapped to map screen. With that, we can set up some default navigation options here. So I'll pass in a second argument. And of course, setting this up is totally optional, but I'll add default nav options to every screen, therefore. And I want to define my header style in here and make sure that there we're using a background color, depending on whether we're running on Android or not. Hence, I'll import this platform API thing from React Native. And I will also need my colors, so I'll also import colors from constants colors. That's also required, because with that we can now check whether the platform operating system is Android. And if it is, we can make sure that the background color of the header is our primary color. Otherwise, I'll set no color. I want to use the default transparent look, which iOS uses. And here also set up a header tint color for the text on there. Again, checking for the platform, because if the platform is Android, since we have a solid background, I'll set the tint color to white. For iOS, I'll do the opposite. There, I'll set it to my primary color. Now that is it here. I have no custom fonts in this project. Of course, you can add some if you want to. With this setup, we can export our app container, which we therefore need to create with create app container, and pass in the places navigator here. Now that's navigation set up, of course in the app.js file we can now use that. So here we should import the places navigator from the navigation folder, places navigator. We don't need the view import here anymore, therefore we can just return places navigator. Since I'm not loading any custom fonts, I also don't need to do this app loading stuff we did in earlier or in other modules. Here I can just return this right from the start. Now in these screens here, in the places list screen, I'll import React from React. I'll import a couple of things from React Native, probably a view, a text, and a style sheet, and then we can see if we need something else later from React Native, and then set up the constant here. Places list screen is a normal React component which receives props and which in the end returns some content. Here I'll just return a view with the text of places list screen. So just some dummy content for now. And also have the style sheet set up here with style sheet create, and ultimately export the places list screen. And this will be the base skeleton we can use for every view. So I will drop it into every view and just adjust this name here. So here we have the place detail screen, which I want to use. And then copy it all in the new place screen and replace this name here in all three places. And last but not least, also drop this into the map screen to have that here as well. And then we'll of course add the real content throughout this module. So that's the screens created. If we now save that and you run this with npm start or with expo start, and you run it on your favorite emulator or emulators, once this finished building, we should see the places list screen in the end, like this. Now, of course, we're not having a header title here, so let's make sure we do set one also on Android by going to the places list screen, and in there we can add places list screen navigation options and set this to a static object here where we can add a header title of all places or something like that. And with that, of course, once this reloads, we see that title here on the places list screen. So that's the basic screen setup which we'll need for this module here. With that, before we dive any deeper into the content of the other screens, let's actually make sure that we have a plus button here in the header as well, which takes us to the new place screen, because that's then where we can get started with tapping into native device functionalities and with adding places. Now, of course, you know how to add a button to the header of your navigator. All you need to do is install a new package with npm install --save, and that's the React navigation header-buttons package, which we used a couple of times throughout this course, and I will use it in exactly the same way I used it in the rest of the course. So I'll create a components folder in which I can set up my own header button component to have that pre-configured reusable button component. And in that component, I import header button from this React navigation header buttons package we just installed, import ionicons from expo vector icons, a package which you might want to install in case you're getting errors here with npm install -- save, and also import the colors constant from the constants folder and there the colors file. And then here we have a regular component, custom header button, which receives props, which returns some JSX. And here I want to return the header button, which we're importing, but now we'll just configure it to our requirements. First of all, by forwarding all props to it. And then we can set the icon component to ionicons so that this is used. Set the icon size here, maybe to 23, because I think that worked quite well thus far. And set the color to, and now I'll need one other import. I'll need to import platform from React Native, because now I want to check the platform here. And if the platform is Android, we'll have a solid background. So then I want to use white as an icon color. Otherwise, I use my primary color. Now with that, the only thing that's left to do is to export this custom header button here. And now we can start using it in the places list screen. In there also, as before, I import two other packages from React navigation header buttons, two other things from this package. And that would be my header buttons and item. Both needs to be imported. And in addition, we can also import our own custom header button now from the components folder and there from this header button file, which we just worked in. And with that imported, we can change our navigation options here to be dynamic, where we have this function that gives us the nav data and which then eventually returns this configuration object, because this will then allow us to also bind the button to some function which we receive via route params. Because here I want to add header right to add my header buttons. And of course, there's now also a pattern we did many times throughout this course. We add the header buttons like this and have the item in there. On the header buttons component, we can set the header button component and point at our custom header button component here. And on the item, we now set a title like add place, and we set the icon name here, which depends on the platform. So therefore, I will actually import this platform API here from React Native. And we can now check if platform operating system is Android. If that's the case, then I want to set this to MD add, otherwise to iOS add, which adds a plus button for the specific platform, so following the specific look of that platform. We also need to add the onPress function, and there, if we tap on this, I simply want to navigate with the navigate method here, and that's why we need to have this dynamic function here, so that we get access to nav data and then navigate to new place. And new place here, of course, is my identifier in the places navigator of this new place screen. So with that, we have a way of going to that screen, and hence, if we save this, we should be able to do that. Obviously, I'm getting an error because in my header button component, since I have a React component in there, importing React from React doesn't sound like the worst idea. So let's quickly fix that here in the header button component. But now with that, as this reloads, we have this plus button, and we can go to the new places screen, also here on Android, of course. Now on that new place screen, we can therefore also add navigation options to set a title, new place screen, navigation options, set it to some static object for the moment, because we right now don't need this to be a function. We don't need access to the nav data. We just need to set the header title to add place. And with that, if we save it, obviously if we go there, we see that title in the header. So this is this basic setup here. Now we can work on that add place screen to make sure that we, can add a place. So in the new place screen, I want to be able to add a place, and for that, I'll first of all add the text input component, which of course has nothing to do with native device features, but we simply also need that, because in there we can now add such a text input that allows the user to enter the title. And therefore, I'll also add a text component here where I say title. That should act as a label for this text input here. And overall, I also want a scroll view in here to wrap all my content, because I don't know which device the user is going to use, but we'll add more than just a title. We'll also add an image picker and a place picker throughout this module, and therefore being able to scroll this page is really important. So now we have that title label and the text input that belongs to it, which for now will, well, not do anything, but which will soon allow the user to enter a title. I also want to make sure that, of course, this form can be submitted. So what I also want to do is I want to add a button component here. And after the text input here, I'll have my button where I say save place, for example, add a color here and set this to colors.primary. And for that, you need to make sure you're importing the colors constant here. And on press will later submit this form. For the moment, I'm not doing anything here. The text input, of course, also can be configured, though most basic configuration is fine here. I don't need to change the keyboard type and so on, but some styling would be nice. And that's actually true for the entire page. So for this view here, for example, I want to add a style of form here, so a style identifier of form so that I can style the overall form. For the title here, I'll add a style of label. And for the text input, I also want to add my own styles, and I'll use the identifier text input here. With that, let's go down to the style sheet and make sure we do add some styling here. For the overall form, I'll add a margin in all directions of 30 so that it doesn't sit directly on the edges of the screen. For the label, I want to set a font size of, let's say, 18. And also add a margin to the bottom of 15 so that we have some spacing between the label and the text input. And on the text input itself, well, in order to be able to see it, I'll add a border bottom and set its color to this light gray here with this hex code of CCC, and a border bottom width here of 1. And then also have a margin to its bottom, so to the content below it, the button right now, of 15. And what I'll also add here is a little bit of a vertical padding, just 4, and a little bit of horizontal padding, just 2. If I save that, let's have a look. If I go to the new places screen, this is what I have. And this doesn't look too shabby. Also on Android, this is something we can work with, I guess. And this is something we can build up on. Now, of course, this input isn't doing anything. I, of course, want to capture what the user entered. And to keep this simple, here I'll not add super complex validation or anything like that. Instead, I'll just capture the value and that's it. You can, of course, add validation. You can add a reducer, as we did it in the user input module where you learned how you can manage more complex forms in all ways. Here, again, I will keep this very, very simple, and therefore I will just import the use state hook from React here so that I can just capture my values here. So here I will have my title value and a set title value function and use state to initialize this to an empty string. And I'll then add a function here, the title change handler, which receives the text the user entered, and where I'll then just set my title value to that text. And here, of course, you could add validation, but again, to keep this simple, I'll not do it. It's the title change handler that should now be bound to the onChange text prop here on the text input. So there I'll point at title change handler, and I'll bind the value of that input, of course, to my title value, because that's where I store the user input. With that, we have a fully functional user input here where I also capture the values. Now with that, we're able to get the title. We also have save place. Whenever we press this button, I want to save it. So I'll have my save place handler, which is a function I want to bind to this save place button. So here, instead of having this empty anonymous function, I'll point at save place handler on this save place button. And in there, I now want to make sure this place does get saved. And for this, I'll again use Redux. So I'll install Redux with npm install --save Redux and also React Redux. And I'll also install Redux Thunk so that we can use that too. For now, I don't need it because I'm not talking to a server, But later, once we add native device features, you'll see that there we also got some features that are asynchronous and where you might want to wait for their completion before we actually dispatch an action, which is exactly where Redux Func can help us. So therefore, with these 3 packages installed, we can now set up Redux. To set up Redux, I'll follow the same approach as I did earlier in the course. I'll add a store folder, and in there I'll have my places actions.js file and my places reducer.js file. That's of course a bit different than before. There I had an actions and a reducers subfolder. You can absolutely do the same here. Since I have only one action and one reducer though, I'll keep this in 2 files, but you could have subfolders and so on. That's totally up to you. Now in the places reducer, I'll define how my state should look like for this part of my total state. And that will be very simple. My initial state here is just a JavaScript object where I want to have a places key which is empty, an empty array at the beginning, because I'll have an array of places and that's it. So therefore here I can export this reducer function, which takes a state that is set to the initial state if no other state is passed in, and an action. And in there, for now, I'll just return that state. Soon, of course, we'll add logic to handle different actions and, for example, add a new place. In the places actions file, I'll export a new constant, add place, which is one action identifier I'll need, and I'll add an action creator function, add place, which should take some data about the place, and for the moment that's just a title. Later that will be more. And here I want to return my action object then where the type is add place, and where I then just have my place data, let's say, which at the moment of course is only made up of the title, but later again that will be more. That's the basic Redux setup. Now of course in app.js we need to wire everything up. So in there, as you learned it in this course, we can import something from Redux and also something from React Redux, and also import Redux Func from, well, Redux Func, so from this package we also installed. Now from Redux we need create store and combine reducers, and also apply middleware to apply Redux Func. And from React Redux we need the provider component. And with that, just as we did it multiple times in the course, we can create our root reducer with the help of combine reducers. This takes our object where we merge all reducers together. Now obviously we only have one reducer here, and that's the places reducer, which we import from the store folder, and there it's the places reducer file. But of course you could have more reducers in your app. And I'll map this to places. So the places reducer is mapped to the places identifier here. Now with that we can create our store with the create store function. And this function takes the root reducer, and we can also pass in a second argument where we call apply middleware and pass Redux Func to that function so that the Redux Func package is kind of plugged into our Redux flow here. With all of that set up, we can wrap our places navigator with the provider component, because every screen in our app, in our navigator, should have access to the store. And to provider, we pass the store through the store prop. That's the Redux setup we also saw multiple times throughout this course. With Redux setup, we can go to the new place screen and make sure that here in the save place handler, which is triggered when we click this button, we do actually add a new place, which for the moment only consists of its title, but of course that will change throughout this course. To do that, we can import use dispatch from React Redux and simply get access to the dispatch function by executing use dispatch up there. And also, of course, import our action, for example, again, with using this import merging syntax here with import everything as places actions from the store and there the places actions file. And with that, we can go to save place handler, call dispatch here, and dispatch places actions, add place, and forward the title, which is of course stored in our title value. So in this here. Now with that, we'll be able to dispatch this action. In the places reducer, we can now switch our action type or use if checks, of course, and look for the add place state or action, which we import from places actions. Also add the default case, by the way, where we just return the state, and therefore we can get rid of this return statement down there. And now if add place is what we got, well, then we can create a new place here. And for that, also just as before in this course, I'll add a models folder with a place.js file in there where I want to define how a place should look like in this application. Simply just to have an easy way of creating new place objects that are always the same. So here, I'll create a class and export this as the file default. And now, of course, it's up to you how you want your place to look like. I'll define mine with the help of the constructor to have an ID and a title, and later we'll add more. But for now, that's it. And I'll store my ID here, and I store my title here in a property. With that, we have a blueprint for new places. Back in the places reducer, we can now use that. So there we can import place from the models folder, and there the place.js file. And then here create a new place by calling new place. So by initializing or by instantiating a new place based on our class. And for the ID, I'll for the moment use a dummy ID of the current date timestamp. And the title, however, is of course something we can set because that's part of our action. There in the place data, we'll have a title property which holds the title the user set. So here I can set this to action place data.title. This creates a new place object, and now we can return a new state here where places, and I don't need to copy the old state because I have nothing else in my state here and I won't add anything, so I can just return a brand new state object where places is now state.places concat. So that takes the old array, adds a new item, and returns a brand new array, which replaces the old array here in our state. And I concat my new place, of course. With that, we should have a list of places which we manage. In the next lecture, we can now worry about outputting this here on the place list screen. Just do one other thing. When we add a new place here, by clicking the save place handler, I also want to go back to the places list screen. So here, after dispatching this action, I'll actually use props navigation to go back. So to go back to the place list screen. And now let's work on that places list screen, and let's make sure we do actually output a list of places there. So in the places list screen, I want to output a list of places, unsurprisingly. And for that, you know one component from React Native we can import, and that's the flat list. Flat list, of course, is perfect for outputting, well, a list. So here I will return flat list now, and I want to get access to my places. These are stored in Redux, so we can, or with the help of Redux, so we can import React Redux here. Or to be precise, from that package we import useSelector, because now in our component we can use that to get access to data stored in Redux. So here I want to get access to my places with the help of useSelector. That's a breeze. We pass in that function which receives our Redux store, our Redux state, which is stored in the store there. And there I want to get access to the places slice. And here I use places because in app.js I used places as an identifier here. That takes us to the slice managed with the places reducer. And in that reducer, we have another places key. So in the end here, I want to access state.places.places. And with that, we know which kind of data we want to feed into the flat list. Now, again, I will also add a key extractor here to tell the flat list where to find a unique ID for every item. And for me, that's in the ID property of every place. And of course, we need to add render item, so that we get our item data there and then output a component for every item which we want to output. Now for that, I'll actually create a brand new component in the components folder, and that's the place item.js file. Now to save some time, I attached my place item.js file to this lecture, and you can just replace yours or the content of yours with mine, but I'll of course walk you through what I'm doing in there. This is a basic component, as we also built it multiple times throughout this course. I just have my own component here, which is able to output an image, because we'll need that later, which then has a view with two pieces of text that will sit next to this image, thanks to the styling. which I apply down there. There I output the title and the address of that place. Of course, that's information we don't have yet, but we'll add this throughout this module. And we have a touchable opacity component around this so that we can press every place. And when we do press it, we trigger a function that we expect to get on the onSelect prop. Now in my styling here, I set this up such that the image and this text block sit next to each other in a row here with flex direction row. The image is then a rounded image, so it's a round image, it's a circle with a fallback background color in case we have no image yet, which you of course also can change to, for example, this grayish color. Then we have the info container, which is the container holding the two pieces of text, which now are organized in a column above each other. And then we have the title, which is a little bit bigger than the address. And there I actually also want to use black as a text color. That's the setup I'll use here, and that's the place item which we can now import into the places list screen. So there we can import place item from components place item and output this here in render item. So there I want to output place item as a self-closing component. And now place item, this new component, needs some input data. We need to pass in our onSelect prop, which points at a function that should be executed when we tap an icon. We need to pass in an image prop, a title prop, and an address prop. So 4 props which need to be provided. So let's do that here. For the image, we got no image yet, so here I'll just pass in null for the moment. For the title, we can do that, of course. We can point at itemData.item.title, because a single item is just an item following our place model, and that of course has a title prop, so we can safely access that. For the address, we don't have that yet, so I'll set this to null. And for onSelect, well, we can of course set this. There I want to go to a new page after all. So we can do this with an anonymous inline function here, or with a named function stored in a separate constant, whatever you want. I'll do it inline. And there I can use props navigation.navigate and go to the place detail screen with the place detail identifier, which of course in my navigator is this identifier here. And there I also want to pass some extra data, some params, so I'll pass a second argument here to navigate. And there are 2 pieces of information I want to pass. That's the place title, and that of course is itemData.item.title, so the exact same thing I'm feeding into the title prop here. And that's also the place ID, which is itemData.item.id. We have that ID also already, so that's already something we're generating when we add a new place. With that, we have a place item, which takes us to the place detail screen. And since we already have some basic skeleton in that screen, we should be able to see that. One thing I will add to the place detail screen, however, is my navigation options configuration, where I need that dynamic function, which then returns a configuration object, because there I want to set the header title based on the params I'm getting, because in the place list screen I'm passing in a place title and place ID parameter to this new screen. Place title is what I want to extract and set here in my header. So there I can set the header title to navdata.navigation.getParam place title, so that we have this title in the header. And now with that, let's give it a try. Let's save everything and add a new place, a test, click Save Place. We're taken back and we're seeing that here. If I tap it, we go to the detail screen where we see that in the header. Let's also give it a try on Android with a test. Save this, click on it, and that all works. So that's the basic flow for this. But one thing we still haven't done, of course, is use some native functionality. So now it's really time that we do that, and I want to start with the camera. Now this React Native application is built with the help of Expo, as you know. Now, as I mentioned at the beginning of the course, this still is a regular React Native application. Therefore, Expo just is an extra wrapper which provides a lot of convenience features out of the box that makes building this app easier. And it's like a shell, an app in which our app runs, which therefore makes tapping into a lot of native device functionalities easier, and especially easier to set up. Now, as I also mentioned at the beginning of this module, in a separate module, I will show you how you can add native device features to non-Expo apps. But actually, if you don't have a reason for not using Expo, I would strongly recommend that you do use it. Because Expo, if you check their docs, has a lot of built-in features and a lot of built-in native modules you can use. So native device features you can easily add. And you see a full list here by going to the docs and there to the API reference. Here you see a bunch of things you can add to your app, and these are mostly native device functionalities, which are all provided by Expo out of the box. So you'll still need to install something, but you'll need to do no manual configuration. And as you'll see in the building an app without Expo module, there is quite some configuration you might need to do if you're adding native modules, native device feature packages to a non-Expo app. So this is really sweet here. Now I want to use the camera, and indeed there is a camera package which you can add. We could actually use that to access the device camera. This is perfect if you need to build an application that really needs to do a lot with the camera. If you're building like an Instagram-like application where you really want to control the entire camera screen and the entire camera flow, it's actually not what I want to do here. I want to use the regular device camera, don't need anything special there. I just care about getting an image which the user can take. And for that, we actually get the image picker. This also allows us to use the device camera, but it doesn't allow us to customize the camera that much. But that's exactly what I need here. Now, all we need to do to get access to it is run this expo install command, which by the way is like npm install, just that it makes sure that it installs a version of the package that is guaranteed to work with our specific version of expo we're using in this app. So I'll just copy this command, and then in this project, we can run expo install expo image picker. Hit enter, and this will now install this package with npm install behind the scenes. This is what it does here, just in a version that fits our expo SDK version we're using in this project. And this will now install it, and that's it. No extra configuration is needed. We don't need to touch any config file. We don't need to do anything else. This makes sure that we can use this functionality. And that's of course very easy. With that, we can start using it. I want to start using it here on the new place screen where we have the text input, right? There I also want to now add a button which the user can press to open up the camera. Now, of course, for all these native device features and also the many features we of course can't cover in this course, you always learn how you may use them here in the official Expo docs. There you learn which methods and properties you can access there. You find some short examples for many packages. So that's definitely something you should check out. For the camera, of course, you can also follow along because we'll use it together here. To take a picture, I'll actually create a new component, image selector.js. You can name it whatever you want, in which I import React from React, and where I import a view and a button and also a text from React Native, and also the style sheet, of course, because I want to style my image picker. Let's actually name it image picker. I like that. My image picker component. So here, image picker is then a regular component, of course, where I want to set up some styles with the style sheet create method, and where I in the end export the image picker component. Now, what's going to happen here in the image picker component? In the end, in here, I'll return a view, which should then hold another view where I can display a preview of the image. So in there, I want to have the text component where I say no image picked yet, which is my fallback content if, well, no image was picked yet. Otherwise, I'll display an image, so we'll also need to import the image component from React Native. And below that view, I'll add a button with a title of take image, where I want to set the color to colors.primary. So for that, make sure you import that colors constant. And upon a press, I want to open up the camera and display it to the user. So I'll also add a constant here, take image handler, and that's a function which should open up the camera, and that's the function I'll bind to this button. Now, some styling would be nice. On that outer view, I'll add a style of image picker. On this inner view, which displays a preview of my image, I'll add a style of image preview. Then this text here could also be styled, but I actually need no special style there. And of course, I also want to output an image here, and I'll soon add a if-else condition to only display either the text or the image. And this should also get some style of maybe just image. So now we have 3 style identifiers, which we need to add to the style sheet. Get the image picker for the overall component, get the image preview, and then we get the image itself. Now the image itself is simple. There I just want to set a width of 100% and a height of 100% so that it takes the full width and height of the surrounding preview container. That container then can of course be configured however you want to configure it. I'll give it a width of 100% and a height of 200 pixels, but of course you can change that or calculate it dynamically with the Dimensions API. Add a margin to the bottom of 10 and make sure that my placeholder text would actually be centered by adding justify content center and align items center here. And besides that, I also will add a border here with border color, light gray color, and border width of 1. Now for the image picker component in general, I'll just set this to align items center to make sure that all the items are centered horizontally. But now we're all here to really open the device camera, right? So before we do anything else here regarding the preview and so on, let's make sure that here in the take image handler, we do actually open up the camera. And for that, let's import everything as image picker from Expo image picker, so from this package you just installed. Now, since I used image picker here and also for the component, we'll have a name clash. So I'll name this img picker here just to avoid this name clash, which would otherwise cause problems. Also change it here in the export, of course. So now with the image picker imported here, we can use it here, image picker, and there we can call launch camera async. You can also open the gallery instead if you wanted to, but here I'll call launch camera async. Now this will open up the device camera, and the async part here kind of implies that this is an async operation. Indeed, this does return a promise, which makes sense because it opens the camera and we don't know when the user will be done taking the image. So it will then just register a function which it should execute once the user is done and resolve the promise to execute that function, well, once that happens, once the user is done, or also, of course, once the user cancels. We can handle all of that and the result and so on later. For now, let's see whether that works. And for that, let's include the image picker component in the new place screen. So there we can import image picker. And here, of course, we can use that name because we're not using the image picker package in here. Import that from components, from the image picker component, and add this image picker here below our text input as a self-closing component like this. Now, if we save that, let's have a look. Here, that text is on. That's not positioned properly. We don't need to worry about that right now. Let's instead press take image. What you'll see is that nothing happens, but then I get a warning. Missing camera or camera roll permission. On Android, if I try it, there I'm asked whether I want to grant permissions. And I need to press allow here. With that, the camera does open. So that's good. It generally works. I can use it. I can press this button therefore and then confirm the image I took. But on iOS, it does not work. And why is that the case? Well, on iOS, we got a permission error here, right? And that simply happens because permissions are important, but they work differently on iOS and Android. On Android, you also set up permissions in advance. And since we're using this Expo application where Expo provides this wrapper, Expo actually does all this permission setup and requesting for us. For iOS, the permission system works a bit differently. You don't really set it up such that you have a config file where you define all permissions in advance and that's it. Instead, you have to ask for a permission at runtime. Side note, by the way, in some versions of Android, you also now should do that. Still, there, Expo, as you see, does it for you. So for Android, it kind of works like that. On iOS, it doesn't. You need to ask the user for a permission to access the camera. And that's simply something we need to do here, and we can do it with the help of another Expo package, and that is the permissions package. You also need to install that with this command here into your project so that you can ask the user for permissions. So let's do this here in the project. Let's run expo install expo permissions, which again is just this wrapper around npm install to install the permissions for this project or to install this package for this project. And then in the image picker, before we try launching the camera and opening the camera, we'll need to ask for permissions. For that, I'll actually add a new constant here, get or verify permissions. And this is a function, this holds a function which will use this newly added permissions package. So here I import everything as permissions from expo permissions. So the same kind of import as we have it for the image picker. And then there, we can use permissions and ask asynchronously. Again, that's an async task which returns a promise because this will open up a prompt. And before the user has chosen an answer, nothing will happen. So therefore, we have a promise which resolves or is rejected once the user confirmed or declined. So here we then need to be more specific about which permission we need though. So we pass something to ask async. And that's a constant we get from the permissions object we're importing here. So with the dot notation here, we can access different kinds of permissions. And here, all these capitalized names are the different permissions you can ask for. And here we need the camera permission because we want to access the camera. If you wanted to access the gallery, that would be the camera roll permission, by the way. Now I'll go for camera here. And as I said, this returns a promise. I want to use async await here, hence I can add async here in front of the function and then await this and get the result and store it in a constant. The alternative to that would be using then and catch on this. And there we now can check if result.status is not equal to granted, which means the user declined, the user did not grant permissions. In that case, we can't continue. So here I'll actually throw an alert then. So import alert from React Native and throw an alert where I say alert.alert insufficient permissions. You need to grant camera permissions to use this app or any output you want to show. And then I'll add one button here where I say OK. Now the user will need to change the permissions in the system settings after declining them anyways, so we can't ask for permissions again here once they were declined. So here I want to return false because it's the verify permissions function, and I want to return false if the user kind of didn't grant us permissions. I return true otherwise because now we know we have permissions. By the way, if we call this function multiple times and the user did already grant permissions in the past, the user will not be presented with this prompt again. The same, by the way, if the user declined. In both cases, the result is stored automatically by iOS, and this function will just return true or false depending on whether the user denied or granted access in the past. So verify permissions is now simply a function which we need to call in the take image handler before we try to use the camera. So here, I also want to use async await because verify permissions, of course, is a function that returns a promise. So I will await this and store the result, which I'll store in a constant named has permission, because this is either true or false, depending on whether the user granted permissions or not. Now, if this is false, so if it's not true, I'll just return here. I won't continue, I won't open the camera because I'll not be allowed to do that anyways. So we just can't continue, that's the thing. Otherwise, we can continue, and now we should be able to launch the camera on iOS as well. So let's give it a try. Let's save that. And now with that changed, I'll actually uninstall Expo here to make sure that regarding the permissions I granted there, it's back to the initial state. You probably don't need to do that if you never granted any permissions in your Expo app, but if you played around with permissions and native packages before, you should uninstall and then reinstall the Expo app by again running your app on iOS by pressing I in the console down there to make sure that all these permissions are reset. So now if we go to the new play screen and click take image, I'm asked whether I want to grant access to the camera, and here I can click OK, and now we still get that error. Now the only reason for that is that even though we're trying to access the camera here, this actually, and that's just something you gotta know for this package, requires permissions for the full camera roll. So let's change this to ask for permissions to the camera roll here. And with that, go back and click take image. Now I'm asked if I want to allow access to photos, and now if I click yes, I get camera not available on the simulator, which now is a different error and is pretty clear regarding what's the issue. The iOS simulator simply doesn't have a camera. So I will continue on Android from now on, but of course you can test this on a real iPhone to see that there it also does work. If you dare scan your Expo barcode with the Expo app and run the app there, as you saw it at the beginning of the course, you can take images with a real phone. And I'll also demonstrate the finished app at the end of this module on both iOS and Android devices, on real devices. So for the moment, I'll focus on Android, and there, of course, we were already able to open this. I'm again asked here, but now I can open this and take an image. That's of course nice, but taking the image like this is not everything I want to do. I also want to be able to configure how I take it, and I want to be able to use it. So let's start with configuring this. Here, launch camera async is the function we call to open the camera, but actually there you can configure quite a bit. If you pass an object here, you get a couple of options you can set, and of course the official Expo docs for the image picker are the place to go to learn all about these options. Now the default settings actually are quite fine, but for example here you could add allows editing and set it to true to get a basic editor which allows you to crop the image, for example, and that's actually something I will enable here. You can also set a specific aspect ratio you want to log in, like 16:9, which will be taken into account in your editing mode. You can also set if you want a base 64 string instead of a file, or in addition to the file, I should say, which means that you get a text string that represents your image, which is quite large though, and I'll not do it here. And you can also control the quality. And there I will set the quality to 0.5. This should be a value between 0 and 1, where 1 is the highest possible value. And of course, this also impacts the image size thereafter. So you want to pick a size or a quality that makes sense for your app. If you're only using the image as a thumbnail, you might not need super high-res images. With that, this is configured, and the question now, of course, is how do we get access to the image that was taken? Well, remember that this is a promise, or that this returns a promise. Well, of course, therefore, we can await that promise, and the result we get back after the promise resolved indeed is the image. So we can't just store this image in a constant. An image is now an object with various pieces of information about the image that was taken. So here we can console log image to see what's in there. Let's save this and test it on Android. There, if I now go to this new screen here, take an image, and I take this image with this dummy simulator camera I get here, and I confirm this. Now I go to this cropping or to this editing tool because I enabled editing. Here I have this 16:9 format thing which I can move, and by clicking on crop I can now select this. And if we now have a look at the console, we see that this is the object we got back. It's our object with a cancelled field, which tells us that this was not cancelled, but that we did take an image. So this is a field we can check to find out whether the user did take an image or whether the process was cancelled. We get the height of the image and the width. We get the type, which is, well, image, and the URI, so a link to the image file. Now this is in a temporary directory which is cleaned up automatically periodically, so of course it's not the storage or the path where you want to permanently store that, and we will actually move it later with the file system API. But for now, this is something we can work with. So to output a preview, we can manage some state here in the image picker by importing use state and then initialize it up there. Use state can be called here. And of course, I get back some data here. And that is my picked image and a set picked image function as you're used to from use state. And now we can utilize that here. Here, I want to set the picked image to image.uri, so to that link to my image, so that path as a string to my image. And the cool thing is this path can be used with the image component. It works with the image component without any special configuration. So there we can add source, and now we need to set this to an object with this URI property. Thus far in the course, we use that to point at network images. Well, you can also point at local images. So here we can point at picked image. Of course, this only works if we have a picked image, which only is the case after we use the camera. So now we can add a if check here, or a simple ternary expression where we check if picked image is set. And if it's not set, hence the exclamation mark, I show this fallback text. Otherwise, with the colon here, I set the image. And now we have this conditional output. And therefore now if we save that, and this hence restarts on both devices, on both simulators, if I go to Android and I take my image here, of course this camera opens, unsurprisingly. We can confirm this, choose our image, crop it, and now we see it here in the preview. So that's now our image getting used. And with that is of course time to add it to the place, which we can add by clicking the Save Place button. And it's time to add some spacing between these two buttons, I guess. So regarding the spacing, on the image picker component, I'll simply add a little bit of margin bottom here of 15 to add a spacing between this image picker component and everything else in the form. But the more important thing, of course, is that we kind of pass this picked image on to our new place screen, right? Because that's where we need the image in the end. I don't just need it here as a preview, I also need it in that other screen. Well, for that we can go to our take image handler, and when we set this as a preview, of course we can also reach out to our props and assume that we get a, let's say, on image taken prop, which should point at a function which we define in the new place screen, which we can now execute. And to that function, I forward my image URI as well. So I don't just store it here internally to have a preview, I also forward it to the parent component, so to say. And that should be on image taken. So all we need to do for this to work is we need to go to the new place screen and add this on image taken prop here on the image picker. And now this should point at a function which is executed by the image picker once we did pick an image. So of course here I also want to store that value, so I'll add another state here, and that's the image value or just image, and set image, maybe the selected image and set selected image, name is up to you, which initially is null or simply undefined like this. And now we can add a new function for this, the image taken handler here, which receives the image path in the end, right? That's what we forward from the image picker when we call this function. And here we then set the selected image to the image path we're getting as an argument. And the image taken handler is now what we pass into the image picker here with the help of the on image taken prop. And this is how we communicate between the image picker and the new place screen. When we now click the save button, and therefore the save place handler gets executed, when we dispatch this add place action, I now want to forward the selected image. So this state constant here. Of course, for that, we need to tweak the add place action creator a bit. Right now, it only expects a title. It should now also expect the image and also add this here to our place data. And in the reducer, I now want to add the image to the place which is getting created. But important, right now our place model expects no image. So it's time to change that as well. Add an image URL there maybe, image URI to be precise because it's local. And then have this image URI set equal to image URI we're getting here. And now with this adjusted, back in the places reducer, we now get this extra image data in our action, and we need to pass this on to the new place constructor. So here action place data dot image is what I want to forward. So that's the new argument added to the place constructor, and action place data image of course refers to the image we're setting here in our action object. So with that, the image is actually getting added to the place which is created, and with that in the place list screen where we output the place item, we can now feed some data into the image, and that would be item data dot item dot image URL. Image URL because item data dot item refers to a single place which is created as defined in our place model, and there we have image URI. And therefore, of course, here it should be image URI, not URL. But that's the important. It's not just image, it's image URI because here we're referring to a place object following our place model. If we now save that and have a look, this should actually work and should allow us to add images, which we also see in our place list. So here, if I click take image and I take this dummy image here, like this, crop this, and then also add a title here and click save place. This doesn't look too bad. We see our image here. Now, one thing is important to understand. Thus far, we're only storing this image in the default path we get out of the box, which is this temporary path. And that's of course not where we want to have it stored because, as I mentioned, this will be cleared periodically and therefore eventually we'll lose our image, which of course is not the goal here. To avoid that the image eventually gets removed, we need to store it in a more permanent path on our local device file system. Of course, we could also upload it to a server, but we already talked about service and so on. Here I want to focus on all the native device capabilities. Now, to work with our native file system, Expo has got us covered. We can use the file system package here to do that. You install it just like you install the other native packages with expo install expo-file-system. So let's do that. Here, expo install. Again, just a wrapper around npm install, which you could alternatively use. Just need to make sure you're using the right version for your expo SDK version you're using. And with that, we have that installed. Now we can move the image after we took it. Now, there are various places in the app where we could do that. We could do it in the image picker right after we took the image. But at this point of time, we don't know yet if we'll actually submit the form, if we actually keep that image. So what if we just took an image here, but then we discard this and we go back? I don't want to have the image moved to a permanent place in that case. It should definitely be cleaned up, and that's the default behavior, so I don't want to move it at this point yet. Instead, I want to move it once we submitted the form. Hence, we could do it here in the new place screen in the save place handler, but then we would add all this file system logic to this component, which is possible, but which adds a lot of logic into this component, which I don't really want to have there. I want to keep this component relatively lean. A great place for this, however, is the action creator. We already used this in the past for having side effects like sending HTTP requests. Now, moving a file is basically the same category of thing we're doing. Instead of sending a request to a server, we're moving a file. Well, it's not that different. So therefore, in this file here, in the places actions.js file, I'll import everything as file system from expo file system, so from this new package we installed. And here in add place, I'll now use this alternative syntax of dispatching or of having an action creator, which utilizes Redux func, where we return an internal function here that receives the dispatch function as an argument, so that in this internal function we can dispatch this action by calling dispatch here and passing our action object. And I will add async here so that we can use async await because we're going to do some asynchronous work here. In here, I now want to move the file, right? So for that, I want to use this file system package. Now moving the file actually involves a couple of things. First of all, we need to derive the new path of the file. And that should of course be a more permanent directory. For that, we can use file system, and there you got a couple of directories you can access. You got the cache directory, which is actually the directory where the file is already stored in out of the box. The bundle directory, which is not really a good directory for storing files your app uses either. But you also got the document directory. This is the main directory for any files that your app needs, which are guaranteed to survive. Now, when you uninstall your app, this folder will also be erased. So then these files are lost. But until then, they will persist across app restarts, across long pauses where people haven't used your app. So here the files will survive. So the file system document directory is the path I want to move my file to. And now there's one important thing to know. Your path also needs to include the file name you want to use in the future. Of course, you also get a temporary file name when you take the image, but when you move a file, this name is actually not kept out of the box. Instead, it will assume this path here as a name, so to say. So therefore, this should not just be a pointer at the folder you want to move the file to, it should instead also include the file name. Now for that, I'm happy with keeping the auto-generated image name. Of course, you could also now generate your own unique image names here. But for that, I'll derive the file name from the image, which I got here. Keep in mind that image here is a path, the temporary path to the image. So here I'll actually use image, which is a string, and call split on this to split it by slashes, because this path, of course, involves a couple of slashes in the end. And split converts this string into an array of string segments, where each segment is, well, a segment before and after such a slash in the string. And there, by calling pop, I get the last segment. So what this code here does is it takes a look at our image path, splits it by slashes, which kind of makes up our full path there. And by popping the last element, well, what is the last element? That is our file name, right? So if you have a path like some folder slash my image.jpg, then what we do with split is we get an array with some folder and with my image.jpg, and by calling pop on this, we get my image.jpg. So that's what we get here. So this will return us our file name, this code snippet here, and now we can append this here to our path by simply adding it like this. So now this generates a path which both includes a folder and then the file name. This is where I want to move the file to, and now we can move it by accessing filesystem.moveAsync. That's a method which moves a file from A to B, and it also uses a promise because moving that file can take a bit longer, and therefore it will tell us when it's done. Now moveAsync takes an object with two pieces of information, from and to, which is pretty straightforward, I guess. So from is image, because image is the path to the temporary directory, so that's the from thing, that's where the file currently sits. And to, of course, is our new path, like this. Now, as I said, this returns a promise, so we can await this, and that's it. Now, we should wrap this into a try-catch block, because this could fail, because, for example, there is not enough space on the device, or somehow we have a permissions error, or anything else is wrong. So we definitely should try catch our file system actions, because operations on the file system can always fail. And there we then might want to do something. Here I'm logging the error and I'm rethrowing it. But of course you could do other things there as well. You could kind of store this on your own analytics server, whatever you need to do. Now you ultimately might want to handle this in a component too to show an alert there. I'll not do it, but you would handle it in the same way as you do, for example, handle HTTP errors, which is something I had a look at in the HTTP module. So here we're assuming that this will mostly work, or that this will always work. We're moving the file. Now, once it was moved, we know it'll be in the new path. So of course, it's the new path which I now want to store here in my place data, or in my Redux store. That's all nice. This should store our image in a permanent directory. But what we're not doing is we're not storing our data itself in a permanent place. We're of course using Redux here, and that means it's stored in memory, but whenever we close and restart our app, all our data will be lost, because that's not stored on the device or on a server or in a database. It's just in memory, which is active as long as our app runs, and thereafter that's cleared. So as a next step, I want to show you how to use SQLite, which is an on-device database, both available on iOS and Android, to store more than just files, but to also store our data like the title and the image path and so on. So let's dive into SQLite. Again, we got a module for that supported by Expo, which we installed just as we installed the other native modules as well. And now just some quick words about SQLite. SQLite is a database system, you could say, which is available on both iOS and Android, so you can quickly set up such a database there. It'll be super easy with this module. And you can then use some SQL syntax, some basic SQL syntax, to run queries against that database. Now, I'll not dive deeply into the SQL syntax here, because this is obviously no SQL course. But to learn all about how to use that, obviously check out the official docs. And attached, you also find a link with a more detailed snippet that dives into how to use the SQLite package in an Expo app, where you can see more examples for how to delete stuff and so on. And you also find a SQL reference for SQLite, where you can learn more about the SQL syntax. I'll show some basic syntax now in this module, but for all the things you can do in your queries, for all the commands you can execute, definitely check out these resources. Now with that, let's add SQLite by running expo install expo-SQLite in our project, which will install this into our project here, and it will work out of the box just as before. No extra configuration is needed. And once this installation finished, we can start working with SQLite. Now, working with the database involves a couple of things. For example, you need to open a connection to the database. And if no database exists yet, which is the case when you first access it in the lifetime of your app, it will also create that database. And after you have that connection to that created database, you can of course run queries against it. So for that, I'll actually add a helpers folder with a db.js file in there, which you don't need to do, but I want to have my database logic in there to keep my other files lean, and so that I have one file where we can see all the database logic. Now in there, we can import SQLite from that package, and as you see, the import syntax is now a little bit different than for the other packages. Instead of importing star as SQLite from this package, we install it here with this named import syntax. Other than that, it's still very similar, and now we can start using that package here. Now, first of all, I'll create a db constant, which holds a reference to my database, which I get by running SQLite open database. And there we pass in a database name, which could be places.db. Now what this will do is it will connect to this database or create the database if it can't find it, so when we first launch the app, and you don't need to do anything else to get access to that database. So that's very trivial. Now this code line will be executed whenever we execute this file, which effectively happens when we first import this file anywhere. Now I also want to add an init function here, stored in a constant, which I do to initialize this database. And I'll export this function as a named export. Now in this function, I want to make sure that we create a basic table, because SQL databases work with tables, which hold your records. And records are basically the rows of data you add to your table. Now initially, when we create the database, it's empty, but in order to store places, we need a table that can hold these places. So I want to have an initialization function here, which will actually create that table if it doesn't exist yet. So there I can use my db constant, which points at the database, and run transaction. Now transaction is a method offered by the SQLite package on the database, and you find all of that in the official docs, of course. And this transaction method takes a function as an argument, which gives you access to the transaction object it creates for you. The concept of transaction simply is a concept where this package in the end then guarantees that your query is always executed as a whole, and that if some part of the query should fail, the entire query is rolled back so that you can't end up with corrupted data in your database. That's why you actually wrap every query into such a transaction. So this creates a transaction or initializes a transaction and then gives you access to this transaction object here in this function, which will be executed for you. So in here, we can now use this transaction object to execute a SQL query with the help of the execute SQL method. Again, that's also documented here. So execute SQL now takes a string which describes your SQL query. And that's the part where you can dive into that SQL doc I mentioned earlier, where you can learn all about the SQL language. Now, I want to create a table here, which we do with the create table command. And you don't need to write this in uppercase. I just do this to make it clear that these are standard commands built into the SQL language. And I want to create that table if it does not exist, which we do with the if not exists restriction here. And now the name of the table will be places, lowercase. Now that's my own dynamic thing here, right? I want to name it places. And now between parentheses, you configure what's in the table, and thereafter you can add a semicolon. So now we define the different fields we want to have in that table, the different columns, so to say. And I want to have an ID column. And I will set this up to be of type integer, which is one of the supported data types in SQL. And it will be a primary key, which means it will also be forced to be unique. You can't have the same ID twice in there. And it will auto-generate that ID for you, which is very convenient. And it should not be null. So adding empty value there will not be allowed. Now with a comma, we can add the next column we want to have, and that will be my title. Now, the title should be of type text. And you can also add not null there if you want to. All my data should not be null, actually. Now, besides the title, I also want to have the image URI stored in there, and that's also text, which is not null. It's text, of course, and not a file or anything like that, because we're not storing the file in the database, we're storing the path to the file in the database, which is a string. And now something else we'll need later, which I also already want to set up, is my address, which is a text. That should be a string which describes the address of the place. And a latitude field, or just lat, which is a real, which is a floating point number in the end. And the longitude, here abbreviated with LNG, which is also a real. And these are also not null. Now we're not fetching the location yet, but we'll do so later. And we'll express a location as a combination of latitude and longitude, which is the standard way of expressing points on the world. So this creates such a table now if it doesn't exist already. Now the execute SQL method also takes a second argument, which is an array of arguments, which will come into play later, which we don't need yet. These would be dynamic arguments you can inject into this query, but we don't need that here. And then we have two functions here as argument number 3 and 4. The first function, which we pass in, is a success function. This executes if this command succeeded. The second argument is an arrow function, which executes if this failed. Now, the first argument to each function here, and these functions are executed on your behalf by the SQL package, of course. So these functions always, as a first argument, get basically the query you executed. And by adding an underscore as a name here, I signal that I don't care about this, but I'm interested in the second argument, and here this would be my error object. And now to make this usable in an easy way, I will actually wrap this into a custom promise. So here I'll create a promise by using new promise. Promise is built into JavaScript and supported by the JavaScript version React Native uses. And promise takes a function which takes a resolve and a reject function as an argument. And now we can move this database transaction code in there. And in the success case, I call resolve, which means that the outer promise will be resolved. In the error case, I call reject and forward my error here. And then I can return the promise here overall in my init method. And now I can call the init method from other places in the app, and I get back a promise that will resolve if we were successful in initializing the database, so in creating the table, or if we faced an error. By the way, if no table is created because it already exists, we'll not get an error, but we'll still end up in a success case. So, with this, we're still not storing anything in the database, but we're setting up the database. So now let's make sure we call init, And of course, the place to call it is the app.js file because we want to initialize the database as soon as possible when our app starts up. So I'll import something from my helpers folder there, from the database file in there. And that something, unsurprisingly, is the init function. And therefore here, when this app.js file executes, when we also initialize the Redux store and so on, I want to call init here. And now init is either successful or not. So for now, I'll just add a then block where I say console log initialized database. So that's the success case. Or a catch block where we get a potential error where I console log initializing DB failed, and where I then also console log the error we got. And if we now save this, you should see here in the log initialized database, which is the output from the iPhone. And now that it started on Android, you see it there for Android 2. So that works, and now we got a database initialized. Time to now also add more methods to make sure we can also insert data and later also, of course, fetch data. With the database initialized, let's make sure we can store data in there. So back in the db.js file in the helpers folder, we can add a new constant, insert place, for example, which I export. And now here, I want to get the title of the place, I want to get the image URI, I want to get the address, and also a latitude and a longitude. So I want to get all the data that makes up a place, and in there, now I want to insert that place into the database. For that, we'll use the same syntax as here, so I can just copy this, because I also want to have a promise as a wrapper here, so that I can conveniently use then and catch or async await in the place where I call insert place. But of course, the query I execute now is different. Instead of creating a table, I now want to insert data into the table, and that's done with the insert into command. Now you need to specify the table, and that's places. And then between parentheses, the fields you want to target in there. And of course, I want to target all fields except for the ID, because as I mentioned, that will be auto-generated, which is very convenient, of course. But I want to target my title field, and now you need to make sure you match the names which you set up there for your columns. You need to match these names here now. The order does not have to be the same, but the naming is important. So I want to target the title, the image URI, that's also a name I chose up there, right? So image URI, address, latitude, and longitude. And now we need to specify what values should go in there. You do that by adding the values keyword here after this list of columns you want to target. And now you have another pair of parentheses here where you specify the values that should go into each of these columns. Now the order of values here, of course, has to match the order of column identifiers you have here. So the first value you enter here will go into the title. Image URI is the second value, and so on. Now what you could do here is you could use, of course, backticks instead of single quotes, and then, for example, inject title here, and then have a comma, and then the image URI, and so on. You could do that and it would work. But this wouldn't be good. This is insecure. It opens a door for an attack pattern called SQL injection, where users could kind of maybe insert malicious code in there and run other queries which could break the database. Of course, in this app, where it's a local database just on this user's device, that might not be super bad, but still we want to defend against this. And therefore here, you actually use a couple of placeholders. You add question marks here. And you need to add as many question marks as you need to enter values. So here I'm entering 5 values, hence here I have 5 question marks separated by commas. Now the concrete values for the question marks are provided in the second argument you pass to execute SQL, this array of arguments. Previously it was empty, now we fill in the arguments in the order we need them, so title first, then image, URI, and so on, and the SQL package will then swap these question marks for our values, but not before validating them to ensure that such an injection attack can't happen. So we get some extra automatic validation by using this approach. And then we can enter the title here. Then the second piece of data was the image URI. Then we need the address, then we need the latitude, and then we need the longitude. So this is how we now pass our data into this query. Now, in these success functions, as I mentioned, the first argument always is like the repetition of your query, but the second argument is then either the error or here the result of this query. And here I want to resolve this result so that in the place where we call insert place, we can actually then listen to the resolving of the promise and get our result of this query, which should be some information about the record that was created. So now we can call insert place, and of course the place where I want to call it again is my places actions file. There we move the image. There I now also want to reach out to my database and add an entry. To do that in here, first of all, let's import this insert place method from the helpers folder and there from the db file. And with that imported, in add place, after solving our file system and so on, here I of course then also, still in the try catch block, want to try inserting data into the database. This also can fail, so having it in a try block isn't the worst idea. So here I can call insert place, and that returns a promise, because we have our own promise in there, so we can await this. And I get back my db result thereafter, so I'll store this in a constant. And now insert place, of course, needs a title, an image URI, an address, a latitude, and a longitude. Now therefore, I will forward my title, which I already have. I will forward the new path, which is my image URI. And now for address, I'll use a dummy address, because we have no real address yet. For latitude, I'll use a dummy number of 15.6, and for longitude, let's say 12.3. Now this might be in the middle of the ocean, I don't know, but at least we have some coordinates here, which we can use for now until we're able to fetch a real location. Now this db result, of course, is interesting, so let's console log it. And let's also, by the way, make sure that we only dispatch this action and therefore touch our Redux store if we succeeded with both the file system and the database action, so inside of the try block. And now let's have a look at this. Now we should be able to store data in the database. So let's test this on Android, where we can take an image. This is a test. Let's take an image here and see whether all of that works by now cropping that image and saving this place. This works. And here we see some output. We see this is the result of our database action, and we see that one row was affected because one row was inserted, and we also get back the ID that was automatically created. It's a numeric ID here, but that's of course no problem. So now we can also use this ID in our reducer instead of manually creating this state snapshot ID here. So that's a tiny improvement. When we dispatch our action here in the place data, I now also want to provide the ID, and that ID can be fetched from the db result constant, and there it's in the insert ID field here, as you can see. So let's access insert ID here. Now in the reducer, therefore, we no longer need to generate it like this. Instead here we can simply refer to action placeData.id. Now keep in mind, there it's a number. Here I actually want to have a string, though you could also keep a number, but I will convert it to a string here. With that, we're now also using that ID. We're storing it in the database. Of course, now it would be nice to load all our data whenever our app restarts, because right now when it restarts, the data still is lost. It's not really lost, it is in the database, but we don't see it here because we don't load this into our Redux store, which then of course is the data we use in the running app. So we need to make sure we do load the data into the Redux store when this app starts. Fetching data from our local database is not that different from fetching it from a web server. Instead of reaching out to a web server, we just reach out to our local database, but that's it. So let's start by writing a function in the db helper file that allows us to fetch data from the database. For this, in there, I'll export a new constant, fetch places, which should do what the name suggests, takes no arguments, and in there, of course, I want to reach out to my database and get all places. So I'll copy that code here from insert place with the promise and so on, but the query will change now, and also the arguments. I need no arguments because we'll not inject any arguments here. Instead of running insert into, we need to run a different query, and that will be a very simple query. I want to select all places in my places table, which is done by running select star, which means I want to get all columns, all fields in this database from places. Now, if you know a bit of SQL, now you could also add a where clause to say where ID greater 1, for example, and so on, but I'll not do it here. I want to get all places, so I'll run this query and leave the rest as it is. And now we just need to go to our actions and make sure we have an action for this. So first of all, I'll add a new identifier here, a new action identifier, set places, just as we did it in the HTTP module for setting the places we fetched from a server. And with that, I can create a new action creator here, where I say load places maybe, where this is the name. And in this action creator, I will return this inner function, and I use async await in there. So this function looks like this, where in the end, of course, we dispatch an action object where the type should be set places and where we set all the places we loaded. But of course, that's the part that's missing. We get the places by running this fetch places function, which I just defined in the helpers file, in the DB file there. So let's import it from there. And then here in the load places action creator, we can run fetch places like this. This returns a promise, so we can await this, and again we get our DB result here. Now we can also wrap this into a try catch block to make sure we catch any errors that could occur. So here, if we have an error, I will just throw it. So we need to handle it in the component actually. I'm not doing that here, but you could handle it in the same way you handle it in the HTTP module, for example. And with that here, eventually, also in the try block, we can dispatch the places which we fetched. For that, it's important for us to understand how the database result looks like, so I will console log db result here so that we can look into it. And now I want to execute load places in my places list screen, because that is where I need all the places, right? So in here, I will import star as places actions from the store folder, and there the places actions file. And we need to dispatch an action, so I will import use dispatch from React Redux. And then here we create that dispatch function by executing use dispatch. And now when this component loads, which we can in the end find out with the help of useEffect, I want to dispatch this data loading action. So here we can run useEffect. And in the function that we pass to useEffect, I want to dispatch places actions dot load places, right? Like this. Now that means that for this effect, we have one dependency, that's the dispatch action, which should never change. So therefore, this should only run once when the component is created, which is exactly the behavior I want here. So now the load places action should be dispatched when our app starts up. And indeed, it did start up here on iOS already, and now also on Android. And therefore here in the log, I see some output, and that's the Android log. And that's the result from the load places action in the end. And as you see, that's the result of our database action. Insert ID is undefined because we didn't insert something. We instead just got something. We have that rows field, and that's another object which has an underscore array field, which holds an array of objects. And in the end, that's our place data, right? This object in here, that's our place data. It has the address, the ID, image, URI, and so on. So it's in the result, in rows, and then underscore array. That's where our data lives. So that's what we need in the places actions file. Here, when we dispatch our places that we want to display, that we want to load into Redux, that should be dbResult.rows._array. Now, of course, that then triggers the set places action. So now in the places reducer, we need to care about this. So here I add a case, set places. Make sure you import the set places identifier here. And in the set places case, I can return a new state snapshot where my places are basically set to the places I got back from the database. And I do this by setting it to action.places, because in my actions file, I have this places key in the action, right, which is the loaded places data. And there I just want to map this array into a new array to transform the data, to transform every single place into a new place that follows my place model, where I, for example, convert the ID of the place we loaded to a string, which is optional. I just want to show you how you could also then transform the data if you needed to. You can do this with the map method, which maps this array into a new array. So there I do that. I keep the title though, I keep the image URI, and I just don't need address and latitude and so on right now. That's also why I'm mapping this, so that I can drop some data. So now I map this array of places I load into a new array of places where I only care about the ID, title, and image URI. Now if we save this, we should actually be able to see our places being loaded here on Android, that one place which we stored before, and indeed here it is. So that's our place, that's the place loaded. With that, now we can focus on also getting the user location, of course. For the user location, we got another package built into Expo, which we can easily use, and that's the location package. Now, just as before, you install it by following the instructions here, and then you also see a usage example down there. So let's quickly do that. Let's run expo install expo-location in our project. And with that installed, we can now also add another component. Besides the image picker component, I'll add the location picker.js file, because that's another thing I want to be able to do in this app. I want to be able to pick, well, a location. For that, in the location picker component, I'll import React from React, of course, because it will be a regular React component in the end, and import a couple of things from React Native. And amongst these things is the view, a button which allows us to start getting the user location, some text also to show a default fallback text while no place has been selected, an activity indicator to show a spinner whilst we're waiting for the location to be fetched, and maybe also alert to show an alert if something goes wrong. And also the style sheet, of course, to style this component. Now here I have my location picker component, which receives props and then will do something. Set up the styles object with style sheet create, and in the end export the location picker component here as the default, like that. Now for that component, how should its JSX code look like? Ultimately, that's as always up to you, but I will start very simple here and just have a view with a button in there, which will allow me to start getting the user location, and also another view in there, which shows, for example, my fallback text, no location chosen yet, which will later be replaced for a little preview of the place on a map. So that's something I'll add later. Now here on the button, I'll therefore say get user location, for example. Set the color to colors.primary, and for that, as always, make sure you import that color as constant. And upon pressing this, I, well, unsurprisingly want to start fetching the user location. So here I'll add a new constant, get location handler, which is a function that will then use that location API we just installed to, well, get the user location. And that's what I trigger when I click this button. Now for the styling here, I'll add a style location picker. On this view here, I'll add another style map preview. We could also style this text, but I'll stick to the default. And now add these two styles to the style sheet. So location picker here. There I'll add a margin to the bottom of, let's say, 15. And on the map preview, there I'll also add a margin to the bottom of, let's say, 10, and a width of 100% to take all the available width, a height of maybe 150, and also a border color of this grayish color with the CCC hex code, and a border width of 1. So a little bit like the image preview box. With that, we have this component set up. We can now include it in the new place screen. So in that screen component, I'll import the location picker from components location picker like this, and add it in the JSX code below the image picker, just like that. If we now saved it and we have a look, we see this box here. Now when I click get user location, unsurprisingly the idea is that I will start getting the user location. For that, in our location picker component, we'll need to import some things here. We'll import everything as location from the Expo location package, which we just installed. In addition, for location, just as for the camera, we'll have to ask for permissions. So we'll import everything as permissions from Expo permissions. That's also required. With that added, here in the get location handler, I first of all want to check my permissions, and for that I can copy the approach I use in the image picker. There we have this verify permissions function, which we could of course therefore also outsource and write in a more generic way to work in different components. Here I'll just copy it, verify permissions. Of course here I'm not asking for the camera role, but for location instead. And you need to grant location permissions to use this app. And now verify permissions is executed here in the get location handler. We can use async await here again to await the result of this check. So has permission is what I want to check here, and if not, so if we don't have permissions, well then I'll just return here. There's no need to continue because we'll not be allowed to fetch the location anyways. Now otherwise we can continue, and now we can use the location package to get the current position async, and this does what the name implies. It gets the current user position. Now locating the user can take a while, which is why this is an asynchronous task and why this returns a promise which will resolve once we got the user location, or which will be rejected if it fails to fetch one. We can also configure this with an object you pass to it. Again, as always in the official docs, you learn all about all options you can set there. For example, one option you can set is a timeout, and set this to 5 seconds to make sure that if we couldn't fetch a location for 5 seconds, we stop trying and we throw an error, so the promise would then be rejected. Now we can await this and of course wrap it into a try catch block. That's important to make sure we do handle errors if we fail to fetch a location. Here I will then simply use the alert component, which I'm already importing, to throw an alert, could not fetch location, and then here, please try again later, or pick a location on the map, which is not possible right now, but which we'll soon add, and here a button where we say OK. So that's an alert I show if fetching the location fails for some reason. Otherwise, here I expect to get back a location. So that's the result of this promise in the end, a location which we can use. Now we can then utilize this location with the help of use state to manage some internal state here. That's the picked location and set picked location. And there we can call use state, which has no initial value here. And then here in the location handler, we can set the picked location to, well, to something. We'll have to see to what. For now, to null. But before we set anything here, let's actually console log location to get a feeling for what's inside there. Now I also want to show a spinner whilst we are fetching, so I'll manage another state in here. And that's the is fetching state. And initially that is of course false, but initially we're not fetching. But then here in the get location handler, before we start getting the location, I'll set is fetching to true. And once we're done, and that also includes if we got an error, so thereafter I'll set it back to false. And now we can use is fetching to show a spinner whilst we are fetching. So here if is fetching is true, I'll show the activity indicator, and only otherwise I'll show this text. And later we'll of course not just show the text, but we'll also show a map snippet. Now the activity indicator can be configured. We can set the size to large and the color to colors.primary if you want to. With all that, let's go back and give it a try here on iOS, because whilst I can't add an image here, at least I can check the location and click on Get User Location. And now I'm asked whether I want to grant permissions, which I do want to allow, always allow. And, well, you see that spinner, it's super fast because it says simulator. It also, by the way, simulates the location. It's not the real location of your computer where you're running this on. Instead, it's a default dummy location in San Francisco. And here on Android, it's the same. If I click Get User Location here, I need to grant permissions. Once I did that, you see the spinner here, and then you, well, see nothing. But in the logs, of course, you see something. There you see the objects which were being logged, where you have a coords sub-object, so to say, so a field named coords in the object, which is another object with the accuracy, and then a latitude-longitude pair that describes this fake location. Both simulators use fake locations. You also got a timestamp. So now we know what's in there, so we can set the picked location. We can now set this to, let's say, an object, where you store a latitude of location.coords.latitude, that's what's in there, right? And a longitude, lng, of location.coords.longitude. So now we have that picked location available, and that picked location can now be used to, for example, show a little map snippet here, once we do have a location. Before I do that, just one tiny fix. I want to make sure that both the text and the spinner here is centered. So on the map preview, I'll actually also set justify content to center and align items to center, so that all content in there is centered horizontally and vertically. That's just a tiny thing. So now you see that all in the center. But with that, let's now make sure we show a little map snippet that shows the location the user picked. So now I also want to display a little map preview here. And there are different ways of doing that, of course, and later we'll also add an interactive map to this app. But for now, I just want to have a static image, so like a map snapshot. And the cool thing is, Google has an API for us which generates such snapshots. You can Google for Google Maps static API to find the official documentation, where you can learn all about that, of course. And in the end, using that API is super straightforward. You just need to send a request to this URL, and this already gives you back an image. So you can just use this link on an image component, and you're good. The only tricky thing here is this API key thing. There you need your API credentials, and for that you need an API key. Now, for this, you can just click on your API key here and generate one. And now you can select a project which you already have, or you create a new project. And for that, you need to cancel here and instead scroll down a bit further to this getting started, activate the API part here, and click on Get Started here. Now, once you do that, you're taken to the Google Maps platform console, where you can now enable the different Google Maps features you want to use. And here I'm interested in Maps, which will later help us use this interactive dynamic app on Android. And I'm interested in Places. So these two things should be checked. We don't need the routes because we're not building any navigation features here. And with that, we can click on Continue, select a project, and now either select the existing project or simply create a new one. And I'll create a new one here and name it React Complete Guide, but you can name it whatever you want. Click Next here. And wait for this to be generated. This should be relatively fast. And now a word about pricing whilst this is loading. You can generally use this for free, but you need a billing account. That's what I'm getting asked for here. You need a Google account, of course, and on this Google account, you need to have a credit card in order to use it. Otherwise, you can't use it, unfortunately. It is what it is. So you need a credit card. You need to have a billing account set up in your Google account, and then you can use this logged in Google account for this project, which is what I'm doing here. With that enabled, you still will be able to use that for free. You got a very generous free tier, and attached you find a link to the pricing of the Google Maps platform. And only if you breach certain limits, which will not breach for the little usage we have here in these videos, only if you would breach these limits, you would pay. Now, still be aware that there can be a point where you need to pay and that it depends on how much you use the API, and therefore definitely check out the pricing docs. Now, here I got this all enabled now, and I'm just finishing this up. And by the end, you should be presented with an API key, which of course I'll invalidate after these recordings. So you can't use mine, but you should take yours instead. And now this is the API key, which you need to insert here into this URL. So now I'll just copy this entire URL here and move that over into our code. And there, I now want to output an image here, which points at that URL, because as I mentioned, this is how you can get this image. This URL returns an image. Now what I'll do therefore is I'll create a new component here, which I'll name map preview.js, because I'll also use it in another place of the app later, where I import React from React, where I then import image and style sheet from React Native, like this. Then here I'll create my map preview component, which receives props, of course, unsurprisingly, which needs to return some JSX later, and set up some styles here with style sheet create. And of course, also export this map preview component. Now in here, I want to generate this URL, which I just talked about. So here, the image preview URL should be generated, and that can be done by using backticks here so that I can add dynamic content into the text easily, and then copy in that URL you just copied from the documentation here. Make sure it's all in one line, because by default it's not. So make sure it's all in one line, otherwise this won't work. And now, of course, there are a couple of segments you need to replace. For example, here, the center equals part. By default, this points at the Brooklyn Bridge, and you can enter addresses here, but you can also enter latitude, longitude pairs here. So what I'll do here is I'll dynamically add two pieces of information here, separated by a comma, and the first thing is the latitude. Here I expect to get this on my props. I expect to get a location prop, and of course this can be any prop name of your choice, which then should have a lat key. And here I want to have a long key, a LNG key as well. So that will be the latitude and longitude of the location I want to preview. Now the zoom factor, I'll set this to 14. You can experiment with different factors. This influences basically how far the map is zoomed in or out. You can also play around with your size here. Now, since I will have a map preview container that I'll typically use with a height of 200, I'll set the height to 200 here, and I will set the width therefore to 400 here. Of course, you can use a bigger size here than you'll use for the container to display the image later. Just be aware that if you're fetching a super large image here, it will of course be too large, too much data to download, it will load slower, and you might not need that. So you should aim for a size of the map image here which kind of fits the container where you want to display it. Doesn't have to be the exact same size, but roughly. Now map type is how the map should be displayed. You could use satellite here, but I'll stick to the standard road map. And now you can also add markers to that map. Now there are a couple of markers set up in this dummy snippet. I'll get rid of all of them but one, so that I just have markers here, color red, a label of A. This can be a single character here, like A, B, C. And then the latitude and longitude where this marker should be placed. And of course, that's again, props.location.lat. And then here a comma, and thereafter replace this number with props.location.lng. Placing such a marker is optional, but of course I want to show the user where this is. Now I need the API key, so I'll copy this key which was generated here and replace this here. Now I can paste it in like this, but actually I want to manage this in a separate file because I'll use that API key in other places of the app as well. So here I'll create a new file which I'll name env.js for environment to set up some environment variables. And there I'll set up an object with my Google API key. And that should be this value here, and then I can export this. And of course, therefore, that should have a name, vars equals. and then I export vars here. So with that, I can simply import from that env file, and that's just what I'll do here. Import env from the env file here, and that just stands for environment variables, as I said, and now dynamically inject this here. So now we have one place where we can change that key and where we can also then import it from in all the different places of our app. So here I'll dynamically inject env.Google API key. Okay, so with that, I got the image preview URL set up. Now in this component, we of course need to return the image preview. And that generally is that view I have here in the location picker. So I'll grab it from there and add it in the map preview like this. Though the fallback content in there, I actually want to pass that in from outside. So I'll cut this out again and move that back into the location picker. However, not like this, but instead here, import this newly added map preview component. So import that from /map preview. So this new component we're currently working on. Add this here, map preview, and then have this check for is fetching and the indicator and the fallback text in here. So in map preview, I will therefore only have props children in here to output what's added between the opening and closing tag. But that's just the fallback content. Of course, I do care about outputting the real preview here. And for that, we have to make sure that image preview URL actually also can be empty in case no place has been chosen yet. So I'll create a variable image preview URL and just assign a value here. And I do want to assign a value if props.location is set, because that also cannot be set in case we haven't picked a location yet. And now image preview URL is either empty or it's this URL, depending on whether we have a location passed in on the location prop. And we can now use this down there to output something. And by the way, since I'm using view here, of course, we should also make sure we import view. Now, how do I use this URL? Well, if we do have it, I want to use it to output an image. Otherwise, I'll show this props children fallback content. So here we can check for props location. If that's set, I know I'll have an image URL as well. We could, of course, also just check the image URL existence. And if this is set, I'll output an image here. If it's not set, I'll output props children like this. So I'll output my fallback content. Now the image here will receive some styling, map image, and a source. And the source here takes a URI which points at image preview URL, because that will be a network URL, a network image, right? So now let's just bring over the styles from the location picker. I can take the map preview, but I only want to bring over the justify content part and actually pass in the rest and manual here and merge it. So I'll still pass in styles.map preview from inside my location picker. And in the map preview, I now want to merge this with my styles I'm setting up here. So here I'll actually wrap this into an object where I pull out all the styles set up in map preview in here and merge in all styles set up on the style prop so that we can set styles from outside as well and merge them with our internal styles. And now for the internal styles on the map preview, as I just said, I'll have justify content and align items in here. And for the image itself, so for the map image, there I want to set this to take all the available width and height it can get. And we need to set this because it's a network image. As you learned, for those, you need to set the width and height of the image component. Now with that, we have the map preview component, which either displays this map image or our fallback content, which is passed in from outside. And it does so by checking the location prop. So in the place where we use the map preview component, which of course is the location picker, we need to pass in this location prop. And the location prop, if we check the map preview, in the end has to be an object with a latitude and a longitude, or a let and lng key. So therefore, back in location picker, I want to pass in such a prop here. And indeed, that's exactly what we manage here with the picked location, which is of course no coincidence. That is an object with latitude and longitude, or it's undefined initially. And we do handle this case in the map preview component as well. If it's undefined, we just show the fallback content, which is passed in from outside. So to location, we can just pass in the picked location. With that, we should now have a setup where we actually are able to see a preview of the place. So now here we see the fallback content, but if I now click on get user location, we see the spinner and then we see a real snapshot of the place we picked. As I mentioned, this is not where I'm sitting right now. This is just some dummy place the emulator gives us. The same on Android. If I take a location here, now this is actually the Google headquarters, which are selected by default there. So this works. Now as a next step, I want to make sure that we can also pick this place on a map instead of just locating us. To display this on a map, we have this map screen component, which currently just has some dummy content. And now we need to be able to render an interactive map. And for this, Expo again has got us covered. There, you find the map view package. Now this behind the scenes uses a package named React Native Maps, which you can also use in non-Expo apps. By the way, many of these packages can be used in non-Expo apps, and that's something I will come back to in the building apps without Expo module. But for now, we can simply conveniently install this by running this command, and this will install the React Native Maps package. And then we can use it as we see it here in this example. By the way, also check out the official documentation at this link to see way more usage examples in there, because there you can learn all about how to use this package. Some examples are also shown here in this module, of course. So let's run expo install react-native-maps to install this package here. And this will then allow us to use various components that render interactive maps. So let's wait for that to finish. And with that finished, in the map screen component, we can start using that map. Now in there, to use the map, we can import map view from React Native Maps, so from this package we just installed. And that will allow us to render a map on the screen. Now, how does that work? Well, let's go here into our map screen, and instead of returning this view here, I'll return a map view, like that. Now, the map view can be a self-closing tag for now. We can later also add some markers in there, but for now, let's just render it like this. And now you need to configure this map view. To be precise, it needs a region prop, which tells it where it should be focused on when it loads. So which map part or which part of the world it should focus on when it loads. So we need to create such a region here. And I'll store that in a constant named map region. And the region is actually an object with 4 properties. And you have to name them like this. Latitude, and not lat, but really latitude, written out. Longitude, latitude delta, and longitude delta. The delta is basically set the zoom factor, because this describes, well, how much space you can see around the center, which you describe with these 2 points. So that describes a point. Together with the 2 deltas, it describes a surface. So now here, we can start with some dummy values before we then later also make sure that we can pre-populate this. So here I'll set this to dummy value of 37.78 and minus 122.43, which is in the Bay Area around the Google headquarters. And here latitude delta will take 0.0922 and then 0.0421. I found that this works quite well as a region. Of course, you can experiment with these numbers, but then in the end pass in this map region here. Now this should render a map on the screen. Now we just need to be able to reach it. And for that, let me go back to the location picker. And I want to reach it in 2 different ways. One is with the help of a button, which I didn't add yet. Besides the get user location button, I want to have a second button, which should sit next to the first one. So I'll add a view to wrap both. And then move this button in here and have a second button in there. And this button will generally be configured in the same way. But I will say pick on map. And of course, I'll trigger a different method, different function. Here I want to trigger a function which is the pick on map handler. And I'll therefore use this here. And that's one way of selecting this. The other way of selecting this or of going to the map is by clicking on the map preview. And before I implement this, let me quickly style this view that holds the two buttons. I'll give it a style identifier of actions, and then down there, actions can be configured in a relatively straightforward way. I want to have the items sit next to each other, so flex direction will be a row, not column. Justify content can be spaced around to distribute the available free space around both buttons. I'll take a width of 100% for this row, and that's actually it. Now with that, I have my buttons here. Now we need to make sure that we can also tap the map preview. For that, let me go to map preview and actually wrap this not in a view, but in a touchable component. And here I'll just use touchable opacity. Of course, you could also go for different touchable components based on the platform you're running on. I want to keep this relatively straightforward, so I'll just replace this view here with touchable opacity, have my style here, that's fine, but also of course have the onPress handler. And there I want to trigger a function which I expect to get from outside via props. I'll just call this onPress2, but you could give this prop any name you want. This now allows us to add an onPress prop on the map preview. So here in the location picker, I can listen to onPress on the map preview, and there of course I want to trigger the same function as when I click on the button down there. I want to trigger the pick on map handler. So that's what I do. Now the pick on map handler should simply go to the map screen, right? So in there we can say props, navigation, navigate, map, and that's it for the second. So if we now save this, we should be able to reach this full screen interactive map where we can't select a place yet, but at least we can view it. So now if I click on the plus here and then pick on map, I get an error. Now why is that? Well, that's totally unrelated to native modules. You might remember that the navigation prop is only available on components which are directly loaded as screens, which the location picker of course isn't. There are various workarounds. There would be a higher order component we can use. We can also install a React navigation specific hooks package. But here I'll take a simple approach and just make sure that I have a navigation prop on location picker by going to the new place screen, which is where I do use the location picker. And there I'll set this navigation prop and forward props.navigation, which I here do have available because this is a component directly loaded through a navigator. So now I'm just forwarding access to my navigation props. And with that, if we now go back and click this, we do load this map here. Or at least the map screen, but where's the map? Well, the map's invisible because, and that's important, for your map you need to add a style. And here I'll add styles.map. And it can be a very simple style, but you just need to define how big it should be, because by default it'll not occupy any space. So by just setting flex to 1 here and telling it should take all the space it gets, just by doing that you will make sure that you see a map. So now with that, if we click on this, here is our map getting loaded. Now also worth noting, on iOS you automatically use Apple Maps, though you can also use Google Maps there if you want to. The official docs tell you how. On Android, you always use Google Maps. So here, if I click on Pick on Map, we will also see that once we load that new screen. Here it is. Now, of course, we can also go to that screen by clicking on our preview here. That's what we set up, right? So that also works. Of course, also works on iOS. And by the way, the animation here isn't super smooth. On a real device it will be, so that's not a problem, that's just here on the emulator. So with that we have our map here, and on this map we can scroll. Again, on the simulator it might be a bit small, on the real device it won't be. So here you can scroll around, you will also be able to pinch and zoom later. So you can do all of that, and with that we see the map. Now the map is usable, but of course we can't pick a place on there yet. So that's the next thing we'll need to change. How can we make sure that we can pick a place? Well, on map view, in your map screen, you can add an onPress handler, and this fires whenever you tap somewhere on the map. And with that, I don't mean taps when you scroll, but when you tap there without scrolling, so if you really want to select something. This will then fire, and this therefore can be bound to a function which I define in here, which should kind of store the selected place. So here I'll have my select location handler function, which gets an event object, and that's what I bind to onPress here. Now we can look into this event to get a feeling for what's inside there, which kind of data we get. So let me save this and let's test it. Let's go to the map, and then once this is loaded, simply tap somewhere on the map, like here. If we now go back, this is the output I get. And in there you see it's quite a big object. In the end, we get a bunch of data in there, which we don't really need. It's this synthetic event here. What we do have, what's interesting, is this native event property, which is yet another object, which has a coordinate property, which is yet another object, which has a latitude and longitude. That's what we're interested in the end, right? That's what we want to find out. That's the coordinate pair we want to get. So this is the place, the coordinates the user tapped on. This is what I want to store here. And it would be nice, for a start, to add a marker in that place, so that we mark that place on the map. For that, of course, we can use state to save that selected place. And in the component, then initialize this up here and have our selected location and set the selected location with the help of use state. Initially, it's empty. We have no selected location initially. And then we can create a marker here if we do have one. For that, we can import the marker component from React Native Maps by adding some named imports here besides this default import we have. And we can import marker from React Native Maps. This is as simple as that. And we can render this marker by adding it between the opening and closing tags of map view, which we now need. So we can add a marker here. Now this marker needs some configuration. Otherwise, React Native Maps doesn't know where to show it. You can add a title, for example, pick the location. But more importantly, you can add a coordinate prop here, and that expects to get an object with a latitude and a longitude in there. So here I'll add a new variable, marker coordinates, let's say. And if I have a selected location, and that's the state I'm managing up there, if I do have that, then I want to set marker coordinates equal to an object where you need to have a latitude, named latitude. So it's not lat, it needs to be latitude, because the marker component will look for a property named latitude. And that can be the selected location dot lat, let's say. It's up to us how we then save this. We're not doing it right now, but later I will save it such that we have a lat prop there. And longitude, which needs to be named like this, which can hold the value stored in selected location dot lng. Now marker coordinates is conditionally set, and here we can now check if marker conditions does exist. And if it does, we use this shortcut to also output a marker here. Now marker coordinates is also what we can feed into here. And please note, this is coordinate, not coordinates, it's just coordinate. And this points at our marker coordinates. And now we just have to make sure that we eventually set the selected location. And of course, I want to do this here in my select location handler. There, I want to call set selected location to set my state, pass an object in there, and set my state to an object with a lat key, because I'm trying to extract lat down there, of event.native event, as you saw, and in there was this coordinate property, which has a latitude property, and then lng, which I'm also extracting down there, should be set to event.native event.coordinate.longitude. And with this code, we should be able to view a marker on the map. So let's give it a try. Let's go to iOS, load the map there, and pick some place. And we see a marker at the place where I click. The same on Android, hopefully. Let's give it a try there. Open the map. And indeed, there, if I tap somewhere, I also do place my marker there. So this is how we can work with markers and how we can select places. It's all nice. Now, ultimately, I want to be able to kind of click a save button up there, which doesn't exist yet, which then closes this map and passes the selected location back to my new place screen in the end, right? Which I do have here as well. I want to go back to that screen and, of course, kind of save my selected location. So I want to have a save button in my header, and for that, of course, we need to add map screen dot navigation options and use the function form there so that we have access to this nav data object with the navigation object. And in there, I want to return my configuration object. You could add a header title, but I'm actually happy without one. But I want to set header right here. And now important, here you can use header buttons, of course, and render a nice icon. But actually, I'll render some text here. So I'll import the text component, or make sure that you do have it imported. I render some text here where I'll just say save. And you could, of course, also add a platform check to make this uppercase on Android if you wanted to. I'll just say save like this. And then add a style here where I add my header button text style. And around it, I want to have a touchable view. So I'll use touchable opacity here, which you therefore also need to import. Not from there, but actually from React Native. So touchable opacity should be imported from React Native. And with that imported, we can wrap this around this text to make our own button, so to say. And there I also want to add a style, and that style will be having an identifier of header button, let's say. Now upon pressing this, I want to save what we added, or save our location we chose, but that's something I'll do in a second. For now, let's style this. So down there in the style sheet for the header button, which is that touchable opacity, I'll add a margin horizontal of 20 to have some spacing around the button to the left and right. And on the header button text here, it's of course up to you what you want to add there, but I'll add a font size of 16, let's say. And important, the color. For that, I need the platform API because the color needs to differ, since this is on the header, which is having a solid background on Android, but not on iOS. I can set my color here, my text color, to platform OS equals Android. So to check this, and on Android, I'll set it to white, and otherwise I'll set it to colors.primary. And for that, as always, make sure you're importing your colors constant from up there. So now we have the save button. When we press the save button, I want to trigger a function that should be defined in the component. And that's also something we did multiple times in the course. I showed you how you can communicate between your component and also your navigation options here. So we can essentially add a new function here, save picked location handler, whatever you want to name it. And this function, or a reference to this function, should be passed to the navigation options. And for that, we can use the good old use effect hook and use callback to avoid this infinite loop, if you remember. And we can therefore then wrap this with use callback and then use effect here to tell our navigation options about this by using props navigation set params. And then I want to set my save location param here to the save picked location handler. So pass a reference to this function, to this param, or with this param to my headers. And use effect, of course, depends on the save pick location handler function, so I'll add it as a dependency here. And important now, use callback here also has an array of dependencies, because in here I want to basically leave this page and go back. So here I can use props navigation go back, and we'll tweak this in a second, but for now we can do this. And therefore, normally, of course, this go back function would be my dependency, but to avoid an infinite loop with this approach we have to use by using params to update the component we already are on, I'll actually add an empty array here as a dependency so that this function effectively isn't rebuilt right now. So with that, we can extract this save location param in our header. So here I want to point at my save function, which I get with navdata.navigation.getParam, pointing at this save location identifier, and then save function is the function I hook up to the onPress handler on the touchable opacity. So this should trigger this save function, this save pick location handler function here. With that saved, if we go back, let's give it a try. Let's go to pick on map. And if I now click save, it should simply go back And it does. So that works. But of course, right now I'm not saving any location. I'm not using any location. That's the next step. And for that, we need to pass the location the user picked back to the previous screen. With go back, that's relatively hard, but instead we can use a pattern which I haven't really used before in this course. I can use navigate here as well to then go back. I can navigate to my new place screen with the new place identifier as set up here in my places navigator. And since I'm already on a screen ahead of that new place screen, don't forget that this is a stack of screens and I'm on a screen on top of the new place screen, this will actually not push this new place screen on top of the existing screen. We could force this with push, but I don't want to. Instead, it will go back. But now by using navigate, I can append some params here. I can add my picked location and there point at my selected location prop, which hopefully holds my picked location. Now, since I use selected location in here, and since this changes, I'll add this as a dependency to use callback, so that this function is recreated when we have a new location picked. And I want to make sure that we do have a location here. So I will check if selected location, or to be precise, if we don't have one, so if this is undefined, which means the user hasn't picked one yet, then I'll return and not continue, and we can also show an alert here if we want to. Now, I'll not do that here, but you could show an alert if you wanted to. So now we'll only be able to click save if we do have a location pick, but if we do so, we'll actually set it on the params of our go back action. Let's give it a try. Let's go there, click pick on map, and now please note I haven't picked any location yet. I haven't clicked anywhere yet, so if I click save, nothing happens. If I do pick a location, I click save, I do go back though. So now we can use the data we're passing back from the map screen in our location picker ultimately to update the map preview there. So that's the next thing I'll do. So to use the data we're getting back from the map screen, we can go directly to the location picker component, because there I do have access to props navigation since I feed this in there from the new place screen, so I can directly listen to changes in my params there. And there, let's say at the top of the component, here where I set up my state, I can also get my picked location with the help of props navigation get param, and now extract the param I'm setting in the map screen. So that picked location param I'm setting there, that's what we can retrieve here. Now, of course, this will not always be set. For example, if we go to the new place screen from our places list screen, there in this navigation action, I'm not setting any params, so therefore, of course, this is not always available, but in that case, picked location will just be undefined. Now here, I now would have a name clash because I have this picked location or this picked location here. And actually, I kind of want to merge both together, so what I'll do here, I'll rename this to map picked location, and then add use effect here to the location picker. And in the end, check for whenever this changes. So here I'll add use effect. And in this effect here, I want to trigger it, or I want to run this effect whenever map picked location changes. And if I then do have a map picked location, so if this is defined, I'll call set picked location to use my internal state here and set this to the location that was picked on the map. So this is now an elegant way of storing the location we picked on the map and which we passed around with props in our internal location picker state here. Now we'll update the picked location to the location picked on the map, and therefore hopefully we see it in the preview. If we go back there and open the map, and then I'll pick a location here somewhere around this hospital, let's say, and I click save, indeed we see that here on this preview. And the same should be the case on Android. And even if I fetch a user location first, which is at the Googleplex, if I then pick a location here somewhere in San Francisco and I save this, this gets updated here in the preview as well. So that works. This is how we can pick places on the map and use them here in the preview, and of course also therefore kind of store them here in the location picker. Now we also need to make sure we can pass the data from the location picker back to the new place screen, because that's ultimately where we need that data. So whenever our location changes here in the location picker, I want to inform the new place screen. Well, that of course means that here, when I picked a place on the map, or also here if I got the user location, in both cases, I want to trigger a method or a function which I expect to get from my new place screen. So the same thing as we're doing it on the image picker in the end. There, once I took an image, I called props on image taken to call a function that the parent component, so the new place screen, can pass to the image picker. And I want to do the same here. I want to use the same pattern here in the location picker. So here, after picking a location with the please locate me button, I want to trigger props on location picked and forward this location in the end, right? And I want to do the exact same thing if I got a new map location. So besides setting the internal location to update the preview, I'll forward, in this case here, the map picked location. So on location picked is now a prop we can set on the location picker. So I'll do that here in the new place screen. And this should now point at a function which will receive the picked location. So here we can add the location picked handler. This is a function, and this function will of course receive the location in the end. And for the moment, I'll just console log it there, and then take the function name here and pass it to onLocationPicked, so that a reference to this function is passed to onLocationPicked into the location picker. Now, one important thing, onLocationPicked is getting used in useEffect here, therefore we should specify it as a dependency. So to only specify this and not all our props, I'll use this destructuring syntax where I get onLocationPicked out of my props like this, so that I can use it without props. Now I can use it here, onLocationPicked. And now to make sure we get no infinite loop, back in the new place screen where we do send in this function, I need to make sure that the location picked handler, which is what I do provide on location picked, is a function that doesn't change all the time. So here I'll import use callback and wrap use callback around my location picked handler to avoid that this gets recreated with every render cycle and I therefore get into an infinite loop. And here use callback needs no dependencies because in there right now I'm doing nothing with external data. So now we should see that log hopefully when we either select the user with the get user location button, and that's looking good. Here's my output. And the same if I pick it on the map. So if I pick a location here and I click save, I also get this output. So that seems to work. This here was my first output. This was the second output for picking it on the map. And with that, we have the information available in the new place screen. Now we just need to store it in some state there as we're doing it with the title and the image. So the selected location, selected location and set selected location. We get that with the help of use state. And now we can call set selected location in here and set our location like this. Don't need to specify this as a dependency. You could, but React will guarantee that it doesn't change anyways, so you don't need to specify this. And now we got our selected location here. We can now use this in the save place handler. There, besides forwarding title value and selected image, we can now also forward the selected location to add place. And therefore, the next thing we'll do is work on our Redux logic to take that location into account. And that's one thing that's missing right now. Also make sure we translate this coordinate pair we get into a human readable address as well. So let's go to Redux to the places actions, which now receives a location object as well. And keep in mind that this is an object that looks like this. So it has a lat and a long key here. So in places actions, in add place, we'll get this location object. And here, I of course want to store it in my database, I want to store it in my Redux store, and as I mentioned, I want to get this human readable address, right? And for that we can use another Google API. If you search for Google Maps geocoding API, you'll find this link here. And this is an API which allows you to translate addresses into coordinates or coordinates into addresses. Coordinates into addresses is called a reverse lookup. So we can click on reverse geocoding down there. And this tells us how that works. And for that, you need a Google Maps API key, which I did set up earlier in this module. And now we can send a request in the end to this URL here. So we can just copy this entire URL and send a HTTP request to this. Now this will not generate the image, but give us back some JSON data. So we'll send a request with the fetch API as you learned it in the HTTP module. And I'll simply do that here inside of my add place action handler in this inner function. Of course, you could also outsource it in a separate file though, if you want to keep this file a bit leaner. So there we can use the fetch API and send the request to a URL, which I'll create here as a string with backticks so that injecting dynamic data is easier. And there I want to copy this URL here and paste it in there. Okay, that does not work, so let me manually grab it then. And now paste it in there. And for the API key, I of course want to use this environment variable, which I set up earlier. So import env from the env file, you might remember. This is a file which holds an object which holds my API key. So now I can replace this here, this API key thing here. I can replace this with this dynamically injected env.google API key value. And of course, latitude and longitude also needs to be set dynamically. Make sure you don't delete the comma between these two. But now here, latitude can be found on my location, which of course has a lat key, the way we set it up. You can always see that down here at the bottom in the console. And location has a LNG key too. So we have these two pieces of information. This sends a GET request there, and that's okay because we need to send a GET request. And of course, we can therefore await the response. And I want to store the response in a constant to use it. Next, we can check if this response is maybe not okay. It should be okay, but if it's not, we could throw a new error here. Something went wrong. And of course, you can therefore also set up error handling in the same way as you learned it in the HTTP module. But here, I do assume that this will work. And now we can get the response data by awaiting response JSON, which extracts the body of the response and converts it to normal JavaScript. And for the moment, I'll simply console log that response data so that we get an idea of what's in there. And now let's simply give it a try. Let's try adding a new place, get the user location and click on save place. And we can do that even without filling out the rest because we got no validation here on iOS. So this works. Of course, I get an error because of missing data, but we also actually do get the result of our HTTP request, and that's this super huge object there. That's really a large object, as you can tell. Now, in the end, what's in there, in this large object, is this is the object here. We have a results key in there, which is an array, and there we have the different components of this address. But if you scroll down a bit, we see besides this array, we also have this formatted address key. So in our result object here, we don't just have that array, but we also have formatted address. And that's what I'm looking for. This is what I want. I want this formatted address. So we can extract that from our response data here. So instead of logging it here, I just check if we maybe don't have a response data results key, if that's somehow missing. In that case, I will also throw an error. But if we make it past this check, then I should be able to retrieve it. So here I can then derive my address by accessing response data results, and then there, the first item, that's where we actually then find the formatted address. And you can simply inspect this object I just showed you to get an idea for its complete structure. Of course, the official docs also document how this data looks like that you get back. So now we have the formatted address here, and therefore I can retrieve it like this, and now we get everything we need. When we now store something in a database, I can use my address, which I just extracted, instead of dummy address. And here for the latitude, I can use location.lat. For the longitude, unsurprisingly, I can use location.lng. And for dispatching data, we can now also add additional information. We can add the address and maybe a coords key, which holds our object, where we have let, which is location.let, and lng, which is location.lng. And now all that data is passed on with our action object and therefore reaches our reducer. So in the reducer, we now need to make sure we use the new address and coords fields we get. So in the places reducer, we want to initialize our place here with that extra data. And for that, we first of all need to tweak the place model to expect that data. So here I want to get an address and I want to get a latitude and a longitude. So we can all then store all of that, store the address here, store the latitude, and store the longitude. With that, the model is prepared. And with the model prepared to get this extra data back in the reducer, we should add this when we add a place. So here, we then add, as an address, the action place data.address, because that's what I just added in the places actions here, this address key. And we can also get the coordinates. So for the latitude here, I pass action.placeData.coordsLat. And for the longitude, I pass action.placeData.coords.lng. With that, places are initialized here. Now, when we load them from the database, when we set our places, we should therefore also initialize our place model correctly and take the data which is in the database already. So keep the address, keep the latitude, and keep the longitude. So that's pretty straightforward. And therefore now we hopefully have all that data and use all that data. Now to see whether that works, we need to work on the place item we're outputting here on the starting page. We can see it on Android. So that we also show the address here maybe. And we also need to work on the place detail screen. So let's work on that so that we can see all the pieces come together. So let's make sure we can see all the data we're working with. In the place item, I already got a field for the address. I just need to make sure I feed that into there. So in the place list screen, when I use the place item, instead of passing null for the address, of course we should pass itemData.item.address in there because we should have the address stored. So if we try that, and this reloads, we see dummy address here. And now if we add a new item with should work as a title, and then an image to take a nice image, and we can even move around here a little bit by pressing the key you see down there. So now if I take an image here, yeah, this looks good. This one, and confirm by clicking on crop up there. That looks good. Now get the user location maybe, and then save this. This looks good. This is the address of the Google headquarters. This looks like the image I took, so that's nice. Let's make sure that on the detail page, we also see a bit more about this. And for that, on the place detail screen here, we of course can tweak this and add a scroll view so that we ensure that we can always see everything. Don't need a flat list here because we'll not have an infinite amount of items, maybe just a little bit of scrolling that is required based on the device size. And then in there, I definitely want to be able to output an image. So here I'll output my image. And below that, I also want to be able to output my address and then also actually a map preview. So I'll import this as well, and we'll need to tweak that component a little bit therefore. But for now, I'll just import map preview from components, map preview like this, and output this below my text here. Now, in the text, I want to have my address text in the end. That's, of course, all data which I expect to get passed as params or with the help of params. So to be precise, we already, when we select the item, we already pass in the place ID here. So in the place detail screen, I can get the place ID by accessing props, navigation, get param. Place ID is the identifier I used. And then we can, of course, use selector to get the fitting data from our Redux store. So from React Redux, that's where we import this from. And then here we can get our selected place with the help of use selector. pass in a function and access state.places, and then the find method to find a specific place where the place ID should be equal to the place ID we're extracting from our parents. That's the place we loaded for this screen, and this selected place, of course, therefore has an address field which we can access, because that follows our place model in the end. And for the image, we can, of course, then also bind the source and set the URI on this object we passed to source to selected place.image URI, because in my place model there, I named this image URI, so that's what I'm extracting here. And for the map preview, I want to pass in my location. Good thing is, my map preview, of course, takes a location. It looks for this location prop. So I can pass this in, and this should be an object, actually, with a let key. So we can use selectedPlace.let for this, and a lng key, which is selectedPlace.lng. So now we pass all of that in there. Now I'll also wrap the text here into a view, and then assign some stylings here. So on the image here, I want to have a style of styles.image. On this view here, which wraps my entire location-based stuff, I want to have a style of, let's say, location container. On this view here, a style of address container. On the text here, a style of address. And on the map preview, I'll also set a style and name this map preview. Like this. Now, if you use the exact same names, attached you find some styling which I set up for you. You can just replace your styles object with that, and this sets up styles for all these identifiers I just added to make that all look the way I want it to look. So that's attached, and you can use that to make sure you get the same styling out of the box without me writing all these styles, because we've written so many styles throughout this course. Here, I really want to focus on the native functionality and not write those all again. Now, one important thing on the scroll view, you also should set the content container style. And there, I'll use a quick and dirty inline styling to set align items here to center so that everything is nicely centered on the horizontal axis. With that, we should be able to view the details about a place. One important note, I used the colors constant in the styles I provided to you. So you need to make sure to import that. Import colors from constants colors. And with that import added here as well, if you save that and this reloads, you should be able to see these places on Android. And of course, you could show a fallback text if you have no places. But now here, you see the places, and if I click on it, this is the detail screen. Now, the one problem I have with that is, it looks nice, that's good. But if I click on the map, nothing happens. And of course, there I want to go to the map screen as well, but in a non-editable way, so that I go to the map screen without being able to edit it there. That's the remaining piece we need to add. So I want to go to the map screen, and I actually want to add a marker there right from the start, which is also something it doesn't support right now. And I want to make sure that I can't pick a new location there. So a couple of restrictions. So when we click the map preview on press, I want to navigate to the different screen, right? So I'll add a new constant here to hold a function, which I'll name show map handler. Of course, you could have also used the inline function. And I'll connect the show map handler to my on press prop here on map preview. This will be triggered when we click the preview, when we tap it. And here, of course, I want to navigate. Of course, that can be done with props, navigation, navigate, and then go to the map screen. The problem just is if we do it like this, unsurprisingly, if we have a look at this on Android, once this reloaded, if I click on this, I load the map screen, but I don't have the place I selected pre-selected. And I can also click here and save and go back to my add place screen. And that's definitely not how this should work. So that's wrong. Instead, I want to pass some data to the map screen. where I can for one set this to read only, let's say. So I'll pass a read only prop and set this to true. And I also want to set an initial location and set this to an object, for example, where I basically pass in, well, this location I also show on the preview. So this here, I can cut it from there and create a new helper constant here. Selected location is now just this here. And I pass this as an initial location here, the selected location, and I pass it to my map preview on the location prop. And with that, we're passing the data to the map screen. We now need to use it there. So we need to use the read-only prop or param to make sure we can't select a new place, and initial location to still have a marker in there right from the start. So now to use all that information here in the map screen, I can get my data from the params I received. So I get my initial location by accessing props, navigation, get param, initial location, which might be set. Of course, this also might be undefined, but it also might be set. And I get the read only with props, navigation, get param, read only, which also might be undefined. Now the initial location can be used to initialize the state now. Now this will not reinitialize this whenever this re-renders, but instead React manages this such that this sets the initial state, and for subsequent re-render cycles this is simply ignored, you could say. So now when we have an initial location, our state will be initialized to that location, which is great. Now keep in mind that what I pass to initial location is of type object with let and long, and that of course should match what we manage with our state in here, and that is the case because there I also set my state to an object with let and long. If that would be different, you would need some logic for normalizing this. Now read only is the other thing I'm extracting, and I can use this in the select location handler, which is the function that triggers whenever we press the map. And there we can check if read only is true, and if it's undefined it will be false, but if it's true, I just return here, which means I don't continue, I don't pick a new location. With that, picking a location should be disabled. Now I also want to get rid of the save button if we have nothing to save. So if we're in read-only mode, then we can't save anything. So header right should only be set if we're not in read-only mode. So here I'll also extract read-only mode with the help of navigation, get param, read-only, which I can do here as well, of course. And therefore now here, if we're in read-only mode, if that is true, then the configuration I return is an empty object. So without any button. Let's give this a try. Let's save it and go back. And if I now click on this item here and I click on the map, it opens, but I got no save button and also no marker, so that doesn't work, but at least I can't select a new one, that's good. But the marker is also not working. Now before we fix this, let's go to the new place screen and see if we there can still set a marker, and that is the case. We can pick a place there, so that works. So the only thing that doesn't really work is loading this map with a marker chosen. And actually that's not correct. We do have a marker. It's just not here on the screen we pre-selected in San Francisco. If we go to the Googleplex, down there, here is the marker. So it did save this, it just didn't focus on that when we loaded it. So that's a little tweak we should also add on the map screen. There, we should make sure that this map region we set here also takes the initial location into account if we have one. So here, the latitude we set initially. Well, if we do have an initial location, then I want to use initial location.lat instead of the default. Only use the default otherwise. Same, of course, for the longitude. If we have an initial location, I want to use the longitude of that initially instead of the default. Now with that, if we save this, we should be able to have a map which is automatically centered on our marker if we open it in the read-only mode. So here, indeed, that works. And if I, of course, add a new place, that also still works. There, we open it on the default place, so somewhere here in San Francisco. This, therefore, all works, and now I just want to test it on some real devices before I wrap up this module and we're done with adding native device features to our React Native app. So now for the important part, testing this on a real phone. For this, I'm reinstalling the Expo client on my iPhone so that all the permissions I did set up there in the past during testing and so on are reset so that I can show this from scratch. And I opened up my Expo dev window in the browser here. Well, it was always open, but now I brought it on this screen so that we have the barcode there to scan. So with that, we can now, of course, scan this with the help of the camera application here, which I pointed the barcode so that I can tap this to open it. On Android, you have the scanner in the Expo app, but I'll show this in a second. Got that. Here's the app, and now I can add a place, test this, and now you'll see something interesting. If I click Take Image, I'm asked for permissions, and I click OK, but now this will actually fail. You see that warning here at the bottom? This failed. Now, the reason for why this failed is that I'm asking for the wrong permission here in the image picker. Now, previously I had to change this because on the simulator, I was also getting an error there. Now, this should actually be fixed by not just asking for the camera roll permission here, but also, you can simply add a second argument here, for permissions camera. So we need both, camera and camera roll. Now, previously changing this to camera roll fixed the issue because, well, we did ask for the camera permission first, but in the end, you need to ask for both. And whenever you reinstall the Expo client or relaunch the app on a new device, you definitely need to ask for both for this to work. So make sure you do ask for both. And with that added, with both permissions added here, this will now always work because now we're asking for both permissions, even though we're only using the camera here. But since this package could also use the camera roll, we need to get both permissions. And thereafter, close Expo and rescan that barcode here, like this, and open this in Expo again, and now it should work. So now if we go here, and we enter test here, and I then take an image, now I'm asked for whether I want to grant access, and I do. And now I'll take this amazing image here, which is very meta, because I take an image of the screen where I record that I take an image, and I can use that photo. Here it is. And now let's choose a location on the map. Maybe this one. Save this. Seems to work. Or get my current location, which I don't want here. So I'll just click Save Place. And here it is added. We can view it. We can view the details. So this seems to work. And now let me also close this and reopen it so that we see whether it was really stored in the database. So it should now load this place, hopefully. And it does, and all the data is there. So this is now our application running on a real iPhone, and we fixed this important permission error. Let's now also run it on an Android device. So let's now also test this on Android, and for that here I have the Expo app on Android open. Now let me take a picture of this QR code and permit this overlay. And now this should open up the app here on Android, on my real phone, of course, now. And here, again, I'll enter a little test title here, then take an image and allow access to that. And take this image here, let's say. Yeah, looks beautiful. Also crop it, accept it. Now for the location, I'll pick that on the map. Maybe here. Save this. That looks good. And now if I click save here, that's all looking good. Here's my item. Here's the place I just created. I can go to the map and view it there. And now if I close this, and I again scan this again to reopen the app, I should hopefully load this, and yes I do, from my local SQL storage I have. So with that, I got this working on Android and also on iOS, on real devices, and with that, we added native device functionality to our app. So this is it. This is how you can add native device features to your app. We added a lot of features in this module. We added the camera, we made sure we can get the user location by auto-locating the user, and also by showing a full map, an interactive map where you can scroll and zoom and then select a place, add a marker. We showed a map preview, which was pretty neat, and we stored that data not just in memory, but we moved the file in our file system, and we stored all data also with the help of SQLite in a real database that runs on our device, and you learned how to set this all up and use that. Now, as I mentioned multiple times in this module, the official Expo docs are your friend. This is everything which is built in, which should cover like 99.9% of use cases you might have. There are so many amazing features you can add to your applications. And as you saw, adding is super simple. It's mostly one command you have to run, and then you can start using the package. Now, nonetheless, you might have some niche use case where you have some functionality you need, which isn't provided by Expo, or you have some other reason why you might want to build an app without Expo. And therefore, I'll also have a separate module, as I already mentioned, where I will show you how to build a React Native app without Expo, and I will also show you there how you could still add native device features. My recommendation, however, would always be that you use Expo because it's such a breeze to add such features to that app, as you saw. Throughout this course, we built React Native apps, and I really want to emphasize this. We built React Native apps, but we built them with a tool called Expo, and as you saw throughout this course, Expo mostly got out of our way, but it made building these apps way simpler. The setup process is simple, you can test it on your real device without any special configuration needed. You can easily add native modules, and you have a huge catalog of built-in native modules, and so on. So developing React Native apps with the help of Expo is really easy, and therefore my recommended way of doing it. Now, there can be reasons why you might want to build an app without Expo. For one, you must not forget that Expo, of course, works such that you have the Expo client on your real device, or also on the simulator, of course. There we also in the end installed the Expo client, so this app on the device, and your app kind of gets loaded into that client. Now, you still will be able to publish a standalone app, as you learned, so you can still publish your app which you upload to the app stores where people don't need to install the client, but this published app will in the end kind of include that app wrapper. So it will be a standalone app where people don't need to install the Expo client app, but the Expo client app is part of your app, you could say, so people indirectly install it, if that makes sense. So you always have this wrapper, and therefore one reason for not using Expo could be that you want to get rid of that wrapper, because as you might imagine, this wrapper, while still giving you a native app and while still giving you the benefits of your views being compiled to native views, whilst all of that is the case, this wrapper of course adds a little bit of size to your app. Your app gets bigger. It probably also gets a bit slower because of that extra wrapper, though I still want to emphasize you get a native compiled app, right? Your views still are compiled to native code, so you don't lose that. It's not like Ionic, where you have like Ionic use a native app as a wrapper for a web app. That's not what's happening here. Still, you have that overhead. So one reason for not using Expo might be that you want to get rid of that extra wrapper. Another reason could be that you need some native device functionality outside of what we used in the native feature module that isn't included in Expo. So some feature which you just can't add with the help of Expo, and then you're stuck. If you need some feature that's not part of Expo, so which you can't find here, then you can't add it to a React Native app built with Expo. There's no way for that. You can't write your own native code and connect it, and you can't bring other third-party packages which tap into native device features. That's not supported in Expo. So these could be two reasons for why you want to switch away. You want to get rid of that wrapper because every millisecond of performance matters to you and every kilobyte of size matters to you, or because of a native feature that's missing. Now, I will emphasize for most apps, both reasons probably don't apply because we're not talking about a huge performance hit. We're not talking about a super huge app which you would be getting. Indeed, it's very lean, but still that might be a thing for some apps. And the thing with the native modules which might be missing, there are so many included, chances are that you can build the app you want to build with what's included. But in case something's missing, you can of course also build a React Native app, and we can find that on the official docs too, without Expo. Now let me dive into the alternatives you have. You could say there are around 3 ways of building a React Native app. One is with Expo with the so-called managed workflow. That's the approach we used in the course. And this has kind of a dashed line around it because this is not really an alternative for building a non-Expo app. This, of course, heavily embraces Expo instead. It is the approach we used in the course. It's easy to use, has pretty much zero setup. It works out of the box. You can easily test the app on a real device. You got lots of native modules built in, which are super easy to install and to use. It's controlled with the Expo CLI. You just type npm start or Expo start. You got the Expo dev tools in the browser. It's easy to run on simulators and real devices. And you still can get a standalone app which you can deploy, which, as I explained, contains the Expo client as a wrapper, so to say. Since you can also easily test it on real devices, you technically don't even need to install Android Studio or Xcode to build an app with Expo. I did install it, and I kind of instructed you to also install it for this course so that we could spin up simulators and test it there, because I didn't constantly want to test it on a real device and record that screen. But you don't need to do that. You can test it on a real device with the Expo client app installed there only. So that's something you can do. Now, this is the approach we used, but of course, this is then an Expo heavy app. It's an app fully in the Expo ecosystem with all the restrictions or disadvantages I outlined. Now, an alternative to that is that you still use Expo, but the so-called bare workflow, or that you build a React Native app without Expo at all with the React Native CLI. Now, the Expo bare workflow thing can either be created from scratch or by ejecting from the managed workflow, and that's something I'll also show you in this module. Now, when you build an app with the bare workflow, you get a non-Expo app. You build a native app as you would build it with the React Native CLI, so you get the same basis there. The difference is that you can still use special Expo packages. Installing them is a bit more complex than when you're in the managed workflow. You need to do more manual wire-up work, at least for some packages. But many, not all, but many of the Expo packages which are included in the managed workflow are available as standalone packages you can bring to any React Native app as well. And the Expo team is working on making more and more packages available outside of the managed workflow. So you can bring that, and with the bare workflow, it's relatively easy to add these packages. Not as easy and quick as in the managed workflow, but still very easy. When building an app without Expo at all, with the React Native CLI, you can still bring these packages, but then more manual setup is required. Now, as I said, it's relatively easy to configure and manage in the bare workflow. You have to manage more in the React Native CLI workflow. So there, you really build everything without any support by Expo. Regarding the native modules you use, you can use any native module you want, also non-Expo ones. You can bring these special Expo packages, which you need to wire up manually, but you can bring any other native module. Now, when we come to building the app and distributing it, with the managed workflow, you will see in the deployment module that's super easy to do. With the bare workflow, it's a bit harder, in quotes. It requires more work with Android Studio and Xcode, and is not as easy as with the Expo managed workflow. You also, for example, and that's one important restriction, you'll not be able to build iOS apps on Windows. That is possible in the managed workflow because the build won't happen on your machine there, but in the cloud. With the bare workflow and with the React Native CLI, you are responsible for building the apps, and therefore you need to do it locally on your machine. And therefore, due to Apple's restrictions, you'll not be able to build an iOS app on Windows or Linux. So that's one thing to keep in mind there as well. So you do it all on your own there. So you need these tools installed, and whilst you won't use them to write code, you will need to fiddle around in them a bit, and you will use them to then build your app and deploy it in the end. These are the alternatives. Now, for deployment, I'll have a separate module where I have a look at how that works with the managed workflow and also without the managed workflow. So that's not something I'll focus on in this module. Instead, in this module, I want to show you how you build an app with the React Native CLI, how you also build it with Expo in the bare workflow, and how you can eject from the managed workflow to the bare workflow. We'll also have a look at how you can add some native device features in these two alternatives, because that is the part where it mostly differs from the managed workflow. The way you write your components and so on, and which components you use from React Native, that does not differ at all because there was nothing specific about Expo in that. Put in other words, if we have a look at the project we worked on earlier in the course, this native module project, essentially what you lose when you're not using the managed workflow is all the Expo related imports. Everything you're importing from Expo, that basically is something which now is harder or which you now need to do differently. If you're not using Expo, like in this file, such a file would not need to change at all. Only files where you use something from Expo need to be adjusted or need to be implemented differently when not using the managed workflow. Or to be precise, you might not be able to use certain packages anymore, or you can still use them and you probably don't even need to touch your code at all, but in order to use them, you need to do more manual setup work than you need to do with Expo and the managed workflow. So what are alternatives to the managed workflow? One alternative is to use the React Native CLI. You can learn about this on the official React Native page. If you visit that, you can simply Google for React Native to find it. And there, if you click on Get Started, you actually are greeted with two different ways of getting started. And the pre-selected way is to use the Expo CLI. It is the approach we used, right? So there's nothing too fancy about this. This gives you a React Native app using Expo. It's what we used in this course. You can also click, however, on the React Native CLI Quick Start. And now here, you first of all need to set your system up in a certain way, and then you can install a separate package, the React Native CLI, which you now need to create a project and to run it and so on. Now, important. Here you find the detailed installation instructions for different operating systems and apps you want to build. Now, be aware that on Windows, as it says here, you can't build iOS apps, the same on Linux. You can only build Android apps there, and you find installation instructions if you select these specific options. On macOS, you can build iOS and Android, and you also will need to follow through these installation instructions. Now, I'll not do this in detail here, because you find them all written here, of course, if you want to follow along. In the end, you will need to install a couple of packages, not NPM packages, but system-wide packages, and the exact installation process differs regarding on which platform you're running on. You will need to install Android Studio or Xcode, so Xcode for iOS apps, Android Studio for Android apps, and you need to install that now. Previously it was optional, I just did it to get a simulator. Now you need it because now these tools will be used to build your app. Previously that was not required because the Expo wrapper basically kind of read our code and hosted it. And you can build a standalone app with Expo in the managed workflow as well. There, that will happen in the cloud. Now that all happens locally, so you will need to install Android Studio and so on, and install it with all the options you find here. Now you also, no matter for which platform you're working, you also need to install the React Native CLI. You can do this in your normal command prompt or terminal. On Mac or Linux, you might need to add sudo in front of this to get the right permissions, and this will now globally install the React Native CLI. For that, you also need Node.js installed because this uses NPM, which is Node's package manager, so make sure you have that as well. Now, with the React Native CLI installed, we can start creating a project totally without Expo, and for that, I'll create a brand new project. And I selected a folder for that by running React Native init, and now any name of your choice, for example, rn without Expo. For the name, it's important that it's written like this, no dashes or underscores in there, but just one word. So rn without Expo is the name I'll choose, and this will now create a brand new React Native project using the React Native CLI in this place where you ran this command, and it will give you this new folder which contains this new React Native project. Now, important again, you now need to have Android Studio and Xcode installed and configured as mentioned in the official docs here. Otherwise, what I'm about to show you will now not work. You need that installed because now these tools will be leveraged by the React Native CLI to build and run your app. Also, spin up some emulators or simulators, can be the same ones you used before in the course, but you need to have those running so that we can see our running React Native app there. So now let's wait for this setup to finish here. And once this is done, and this process can take a while, you can follow the instructions here to, in the end, run your app. So let me navigate into this newly created folder here and run React Native run iOS, for example, to run it on the iOS simulator, which I got. Now this behind the scenes uses Xcode to build this app. It does not use Expo anymore. You could uninstall the Expo client here. You can uninstall the Expo CLI from your system. This does not leverage Expo at all. It just uses Xcode behind the scenes to build your app. So this native Apple development tool. So let's wait for this build to finish. And the first time you build this takes a bit longer. Subsequent rebuilds will be faster. So let's wait for this to finish. Now, throughout this build process, a new tab will be opened or a new window in your terminal. Keep that process running and also keep the build process running, of course. Don't quit this. So keep both these processes up and running here. And now this installs the app on the, in this case, simulator. If you had a real device connected, it would install it there. And it launches the app there. And therefore here, they actually created a new simulator here for me. Doesn't matter though. It now launches the app here in this simulator. Again, for the first launch, this now downloads the build app on this device basically, and you have some nice development features there too. Remote debugging can be enabled, so you got all these nice features in here as well. That's not Expo exclusive, and this first launch will take a bit longer as mentioned. So let's wait for this download to finish here so that the app does launch. And here it's coming up. Now the exact start screen you're seeing here, that might differ over time because that's just the starting code you get in the project, which we'll have a look at in a second. But this is now the app, a native app without Expo, otherwise the same, running on iOS. We can also run it on Android, and for that, this process which now finished can be cleared. The other one should be kept running. That's your development server that talks to the device and which watches for file changes and pushes new code to the device. So what you know from Expo, that works here as well. So keep the other process running, but now we can also run React Native, run Android, to also build the app for Android and leverage that same server to then also build and push the Android app to the Android emulator and then see that as well. So let's wait for this to finish. Again, this first build will take longer. Subsequent reloads will be much faster. This build process now leverages Android Studio, which you also need to have installed and configured as described in the official docs. And therefore, this now also, of course, works totally without Expo. It just uses Android Studio. Now, this also launches the Android app here on my Android emulator. And just as before, this initial launch can take a short while. Now it's connecting to this development server, which you therefore here, of course, also should keep on running, not only whilst it builds this bundle, but all the time, so that upon changes in your files, you get a live rebuild. And once this is done, let's see the finished app run on Android. Now, let's have a look at the code that is responsible for that. Does that now look totally different than what we saw thus far? For that, I loaded the project here again with Visual Studio Code, so the same setup as before, and what you see looks a bit different, but mostly we have a bunch of different configuration files. Fair enough, but that doesn't really change the way we write our code. Very important, we got an Android and an iOS folder. We didn't have that before. Those folders, and on Windows, by the way, Linux, you don't have iOS, you only have Android there. But those folders contain the real native app projects, which are built with the help of Android Studio and Xcode. And your code gets kind of built into that, you could say. React Native does all of that for you, the React Native CLI and process. But if we have a look at the concrete code in the app.js file, well, that is just what we used in this course, right? There we have a couple of imports and some additional linting, which is showing me some warnings here regarding the code style. These are not actual errors, just that I should use double quotes instead of single quotes. Yeah, some recommendation I don't care about here. But if we have a look at what's getting imported here, React, save area view, style sheet, scroll view, text, these are all things we already worked with. So we have the normal components we already worked with, and of course we do. Because what I said throughout this course, React Native is React Native. Expo is a thin wrapper around it. We write the same code. We use the same components. They get compiled to native widgets. That all does not change when we use Expo. The only difference is that with Expo, we don't have to set up as much, the build is a bit faster, and adding native modules is super easy, testing on real devices is super easy. It's simply easier. We built the app in the same way though, and that's something you can see here as well. Styles are set up in the same way with style sheet create. That's all just as we did it throughout this course. And that's important for you. Now, one extra thing you'll find here is the index.js file. We didn't have that in Expo. That kind of is the basic configuration file that launches your app, you could say, that makes sure that this app component gets rendered to the screen. That's something Expo did for you in the React Native Expo app. But other than that, it's really just the same. And you would build an app in the same way. Now I disabled linting here so that I don't have all these warnings and errors regarding code style. Of course, you can adjust your code to follow that style. That's a personal preference in the end. Now what I want to do here is I want to show you how you can, of course, change that code, but then also how we could add a native functionality in such a vanilla React Native app. So for that, I'll first of all simplify this starting app a lot. Just get rid of all that content here. And just add a basic style setup here with flex1, justify content center, and align items center to center my content on the screen. Get rid of this thing here. And from all these imports here, I want to use the style sheet. I want to use the view. And I want to use the button, because what I want to add is the image picker functionality. So here I return my view and my button. And on the button, I say take image, and then on press, I want to open the image picker. Now, how can we add this? Now, since this is a React Native project without Expo in any way, we can't easily use the Expo APIs here. There actually is a way of using them, and I'll come back to that later in this module. But you would need to configure a couple of things. So therefore, what we can do instead is we can do something which you will do a lot if you're working with a vanilla React Native app. We search for a React Native image picker, for example, to find a package that helps us with that. For example, this one, the React Native image picker package. And now we can install this, because now we can bring any third-party package, no matter if it adds native functionalities or not, into your app. Previously with Expo, this was not really possible. There, you could only bring third-party packages that did not tap into native device features. Now you got no restrictions. So now we can add this, and here we can install this by following the installation instructions here. So by going back into our project, and in there by running npm install -- save, and then here it's React Native image picker. Like this. By the way, you can keep this process here running, and you should, so that code changes once you save your files are picked up and pushed to your devices. So let's wait for this installation to finish now. Now it's done, took quite a while. And now we need to install this. And the good thing is, this package is very easy to install. You should only need to run this command here, React Native link, React Native image picker. So run this in your project like this, and you should be good. Now, I will say there are third-party packages that take more effort. It really depends on the package. For Expo, it obviously was very easy. You just ran Expo install, that was very fast, didn't take that long, and you didn't need to do anything else. Here, you need to run one extra command, but of course, that's also not too bad. But again, I will say not all packages support this command. Some packages require way more manual wire-up work. Manual work where you then actually need to dive into the Android and iOS folders to start working on some configuration files there. That's what the React Native link command did for you. For example, on Android, if you dive into the app folder and there's source, and then in the source folder into build Gradle, you will see that there this line was added. This wasn't there from the beginning. This was added by the React Native link command. And for some packages, you have to add these entries manually. A lot of packages support the link command, and with more recent versions of React Native, some packages even support auto-linking, where this linking will be done automatically once installation finished, but not all packages have that support. So that's something to be aware of. Behind the scenes, a lot of configuration was changed. With that, we can now use this package, again, as instructed in their docs. So we can add this import here. Then also add the pick image function here maybe, and connect that to our button. And now here, image picker works a bit differently than the Expo one. Here we call image picker show image picker with options which we can set up. Options are configured as described up here or described in the docs in general. And here I will just grab this entire code here, like this, copy that into the pick image function, get rid of this set state call. We're not in a class-based component, so that's not something we can do. Instead, here in the else block, I'll just console log the response URI, which should be the path of the image which was taken. And then we got a couple of handlers for different scenarios here. And with that, let's see whether that works. If we save this, normally it should rebuild here, but due to our new package installed, I will quit this process and rerun React Native, run Android. Here now in my terminal integrated into Visual Studio Code and therefore in this project folder. And now this will bring up this development server again. And more importantly, it will then also relaunch the app on the emulator so that we hopefully can see it there and can test the image picker there. So let's wait for that to finish, for that build process to finish. Now here's the app coming up. And if I press it, I get this overlay. I can click take photo and nothing happens. Reason for that is missing permissions, and that's the manual work I meant. We have to go into the Android folder, there into source, main, Android manifest, which configures the Android app, and there you have to add a new permission. You can copy this internet permission, which you always need for the Android app to communicate to the development server, and there you can now add the camera permission, which you need to add for this app to be able to access the device camera. Otherwise, this is not supported. So now we can rerun this process, rebuild the application, and make sure that we take this new setting into account. And with that, we should now be able to open this. So again, it's an additional setup which we didn't need to do in the Expo world, of course. On iOS, by the way, you also need to do something similar whilst this rebuilds. There, if you go into your rn without Expo file, you find the info plist file. And in that file, you also need to add an entry to ask for this permission. You need to add a new key here after an existing key value pair. The exact position doesn't matter. And you'll find the detailed instructions on the official docs of that package there under install doc. If you click there, you find instructions regarding which permissions need to be set. For Android, I also forgot one. We need to set this external storage permission as well. So let me go back to the Android manifest, add this here, and now rerun this on Android. And for iOS, there you need to set these keys here. So you copy all of that and then go back to the plist file I showed you here. And now you can add these key value pairs here. With that, let's check the app on Android. And if I now click on take photo, now I'm asked for permission here. This now happens automatically. The package does it for us. And now the camera opens up. So this now works, but as you saw, with a little bit of extra configuration and by following the instructions on the official docs. And every package will have its own instructions there. Some packages don't even support the link command. There you need to do even more. Other packages require less work. You have more flexibility, but therefore also more duties. This, however, is how you can bring third-party packages that tap into native device features to a React Native only app. For your component code which you write, that's the same code we wrote throughout the entire course. Same components, same logic, same way of how you build your app. You can create the same folders, you can add React navigation, that all doesn't change. So you learned how you can use the React Native CLI to create React Native projects. These are projects which have no connection to Expo and which are therefore totally managed by you and where you can therefore add any third-party package, actually including some Expo packages which are available outside of the managed workflow as well. But you need to configure everything on your own. That can be easy depending on the package you're using, but it also can be harder. Now, there is kind of a middle way between the Expo managed workflow and the pure you need to do everything on your own workflow. And that's the Expo Bear workflow. Now, what's the Bear workflow here? The Bear workflow includes a React Native app as you would create it with the React Native CLI. So not a managed app with Expo as a wrapper, but a native app. That, however, is already pre-configured to support a lot of the Expo packages. Not all, but the Expo team is working on making more and more available outside of the managed workflow, but a lot of them are already included. And you can check the supported APIs page here to get an idea for which features you can use in the Bear workflow as well. The idea behind the Bear workflow is that you have this raw native development experience where you need to use Android Studio and Xcode, so you don't have the Expo CLI and the Expo client helping you, so you need to do that manually with the help of the React Native CLI. But where adding native functionality is easier, so where you need to do less configuration maybe, where you can use these powerful native packages that Expo offers you, where you can use all of that without having the limitations Expo gives you. Though I want to put limitations into quotes because you don't have that many limitations actually in the managed workflow. So let me show you how to get started with that Bear workflow. And of course, for that, you can also check the official docs. Here, you need to have the Expo CLI installed. And we installed that at the beginning of the course, of course, for creating our managed project. And you also need to have the React Native CLI installed. In addition, and that's also important, you should generally have the setup which is described here on the React Native docs under React Native CLI Quick Start. So make sure you set up your system as described here for the different platforms, the different operating systems you're targeting. So make sure you install Android Studio and Xcode and all the dependencies you find here, because you will use this workflow. You just get a little bit more than this raw, empty project you have here. So once you have all of that installed, you can create a new Bear workflow package with this command, or in general by running expo init and then any project name of your choice, like rn with expo bear, and make sure you're running this command in a path where you want to create this project folder. So if you run this now, this will create a new Expo project, and this is also the prompt we saw at the beginning of the course. There I chose blank, and please note that this of course was part of the managed workflow, what I chose at the beginning of the course. Now we can choose the Bear workflow by going to the Bear minimum selection here and hit enter. And what this does is it now creates a new project, and we can now enter a name here for the app that's visible on the home screen, rn bear, and here also rn bear. So choose that here, hit enter, and now this creates a new project. I don't want to use yarn, I'll use npm instead. This will create a new project, a new React Native project, pretty much like React Native init would do. So if you only used the React Native CLI, but pre-configured such that you can already use a lot of these supported or all of these supported APIs. Now important, the project setup we're getting here could also be achieved with this React Native CLI created setup where I didn't use the Expo CLI at all. Because the magic happens with the help of these React Native Uni modules here. This is a package in the end provided by the Expo team, which helps you tap into the native device features you can get in the managed workflow outside of the managed workflow as well. Now important, if you visit the GitHub page of the React Native Uni modules, and you can simply search for this name to find it, you also find instructions on how to add this to an existing React Native app. Here you find instructions how you need to configure this, and all this configuration which is described here. So all these things here, right, which you need to do if you would want to use this package and therefore the Expo native features in a normal React Native non-Expo app, you would have to do them manually for such a project created with the React Native CLI. And that's exactly what Expo init with this Bear workflow does for us. It gives us such a React Native project as if we would have created it with the React Native CLI, and it pre-configures it following all these steps, so then we don't have to do that. So that's something we can take advantage of course. So let me open this project. This is now the RN with Expo Bear project I just created. And there you'll find some similarities to the React Native project we created with the CLI. Pretty much the same config files. The same starting app.js content. Now here actually Expo used an older version of React Native to create this, which is why this looks a little bit different, but in the end you'll get the same setup as with the React Native CLI, but as I mentioned, with the Android and iOS folder, with these Android and iOS projects pre-configured as described on the Uni modules page, so that you don't have to do this. And with this pre-configuration, you can now easily add third-party packages. You can add any third-party package. You could, for example, now also again use the React Native image picker. So what we added before, what we couldn't add to a managed workflow app, this package here, you can easily add this to a bare workflow app because it is just a React Native app without Expo. So you can add this. But now, unlike in a normal React Native only app without Expo, you can also bring any of the Expo APIs which are listed here, like the Expo location package which we used earlier in the course. You can now easily install this by following the installation instructions you're linked to here for the bare workflow. You would then have to follow the installation instructions you find here on the Expo location package. There you learn that you can install it with this command, then run pod install in the iOS directory, and no extra setup for Android is required. So fair enough, not too difficult, and therefore you could maybe say you get the best of both worlds. You have a native app with React Native CLI, and you can still tap into some Expo features. Though be aware, of course, that if you run this app, you do this, of course, with React Native Run Android, for example, and therefore this requires Android Studio. It builds it locally on your system. Therefore takes a bit longer. You need to set up everything on your system, and for deploying the app and so on, you also have to manage it all here on your local machine. So you get no convenience features which Expo gives you in the managed workflow, where this building and testing is super quick, where you can quickly test it on a real device and so on. All of that is missing here too. You have a React Native project without Expo, but using certain Expo APIs is easier. That's the idea behind the bare workflow. And since Expo has many amazing APIs, that of course is a pretty good reason for using it, because these APIs, these packages are also pretty guaranteed to be continued and maintained, which is not necessarily the case for all other third-party packages you might be adding to your React Native apps. Now, besides setting up a new project from scratch with React Native CLI or with the Expo CLI and then choosing the bare workflow, you can even convert a managed project into a React Native bare workflow project. And that's pretty cool, because that means you can get all the convenience features of the managed workflow during development. And once you're done, for example, or once you need a certain third-party package which integrates some feature you don't have built into Expo and you absolutely need, in such a case, you can still switch and you don't have to rebuild the app from scratch and create a brand new project and copy over your code. How? Well, in your project, and this is the native device feature, the Great Places project we built earlier in the course, where we can add places, where we are, of course, using the location, maps, the camera, SQLite, so where we are using all these things. There, in this project, you can simply run expo eject, and this transforms your project into a non-Expo managed workflow project. Important though, there is no going back. Of course, you can copy your folder and make a backup copy and save this, or if you're using Git, you can of course go back to an earlier commit. But if you haven't saved your project, once you eject it, you can't transform it back, so be aware of this. You would have to create a brand new Expo managed project and copy over all your code if you wanted to go back. So here, if you run expo eject, you should actually be asked to which kind of project you want to eject. And here I got two options in the end. Now the options you see here, by the way, might differ over time, but here the two options I have are Bare and Expo Kit. Expo Kit is deprecated. This is basically what we had before we had the Bare workflows, so you shouldn't really switch to this. Instead, you can switch to bare here, which simply means that now this will be transformed to a React Native project as if it would be created with the React Native CLI without the Expo wrapper. But it will be pre-configured as mentioned here on the React Native Uni modules page, which is this kind of this package which Expo needs to expose all these Expo APIs to a non-Expo app. So it will pre-configure all these things during each action so that you don't have to do that. So you get a React Native Plus app, so to say. So if I hit enter here, and now important, you can't go back once this completed. You can choose a name for the home screen, and I'll choose Great Places here, for example. Hit enter. Now name my Android Studio and Xcode projects RN Guide, but that's up to you. And now this will do its job. It transforms the project, it adds an Android folder, and since I'm on Mac OS, it also adds an iOS folder. Of course, on Windows and Linux, it won't do that because there, since you now need to build this locally, it can't build iOS apps. And it pre-configures everything and installs a couple of dependencies so that you can use your existing code and all the Expo packages you already installed in this bare setup. So it does not just set up all the Uni module stuff here, it also makes sure that all the packages you are already using, like Expo Location or Expo SQLite, that those packages also work. So now this can take a while, so let's wait for this to finish. And here it's done, and you see it actually tells me that it generally did its job, but there were two packages which require some manual setup. You can simply click on these links to get instructions on what you need to do there. It's the Expo Image Picker and the React Native Maps package where you need to do some manual installation to finish it up. So here on the Expo Image Picker page, in the end what we need to do is we need to run pod install in the iOS folder. So we need to do all the things after installing the package. So in the project folder, I'll navigate into iOS and run pod install. Pod is like npm for iOS. It installs some dependencies which iOS needs to work correctly. So that's what's happening now. And once this is done, we'll also need to add this entry here to the Android manifest. So that's also something we'll need to do. So we need to go to the Android folder, the app folder there, and in the source folder, Android manifest. And then, as described here, add this inside of the application tags. So here is application. And in there, we should add this activity entry here. Like this. That's required. Now, whilst I'm already here, you will also see that this manifest file also was set up in a certain way. It includes all permissions. And of course, you don't want to do that. You only want to ask for the permissions you really need. So, as it says here, remove any permissions your app doesn't need. And for example, my demo application here should only need the access find location permission, which I'll move up there. And the camera permission, of course, which I'll move up there. And also the write external storage permission. That should also be required. These should actually be all permissions, and you can check all third-party packages or all Expo API packages you're using to make sure you're not missing any permissions. With that, I'll actually comment out all these permissions here and also all these permissions, and we'll test it to see whether that works. So with that, setting up the image picker package is done. Now React Native Maps also needs to be configured. There we can dive into the installation instructions. Now this npm install command, that already happened. But now what we need to do is we need to run React Native link React Native Maps. So let's simply go up one level back into the root project folder and run React Native link React Native Maps. And that will now link everything up, make sure that everything works correctly, that everything is configured correctly. And you'll still need to do some manual stuff. All these things here should not be required. That should all be done with linking, thankfully. But on Android, you need to make sure that you add this entry here, this metadata entry, into your application key in the Android manifest. So here, inside of application, we can add this entry, and there you need to place your Google Maps API key. Now I have that in the env folder, if you remember, so I'll just grab this key and add it here, replace your Google Maps API key here with it. And also important, if you go to the Google Maps API page, you need to enable this Maps SDK for Android for your project. That's important, otherwise this will not work. For iOS, you don't need to do anything special unless you want to use Google Maps there, in which case you need to follow the instructions given in the React Native Maps instructions here for how to use Google Maps on iOS. But for Android, you definitely need to enable the Google Maps SDK for Android API here. To enable this API, you can go to your Google Cloud Platform here for the project you worked on earlier when you set up that API key and so on. And then here under APIs and services, you can go to library, which takes you to a library of all the Google APIs. And there, the Maps SDK for Android, you need to enable this. You also will need to set up the Maps SDK for iOS if you want to use Google Maps on iOS, which I won't use here though. Now it should be enabled here already, but make sure it is. So in case it was not enabled, definitely do so. With that, this should also be set up such that it works. And now if we run React Native run Android, the app we built in an earlier module with the Expo managed workflow should now still work. Now without the Expo managed workflow, without the Expo client being used on the simulator or the real device, but instead built locally with Android Studio, or of course also with iOS if you want to use that. And therefore in the same way as you would do it in a React Native CLI created project, but now after ejecting from the managed workflow, which of course means all this code was written in the managed workflow, and yet I now run it in the non-managed workflow, which is pretty sweet. So let's wait for this to finish and see whether this app works the way it should. It's coming up on the Android emulator here, which is the emulator I want to use for testing, because there I can use the emulator camera for testing. And again, just to emphasize this is now not using the Expo client app. We also couldn't scan a barcode here because there is no barcode to scan. This is now really an app built with Android Studio and pushed to our app. So here's our app, and now let's try adding a new place here. Test, take an image, allow access to the camera, of course. And then take this image. Yep, crop it. Pick a location on the map maybe. Here's the map coming up. This location looks good to me. Save this. Save the place. Here we are. And now let me close this app. There you also see that this really is a standalone app installed. If I open the app drawer here on the device, here on the simulator, it's this Great Places app you see here. So if I launch this, this now relaunches the app we just worked in. There's our place as it was stored in the local storage. The image obviously was stored on the file system, otherwise you wouldn't see it. And it works as before, but now not inside of the Expo client, but as a standalone app without any Expo wrapper. Still using some of the Expo APIs and Expo packages, with the help of this Unimodules package, which is automatically added and configured to the bare workflow, which we on the other hand got with the help of ejecting. So lots of cool things going on there. So now that we learned about all these alternatives, the obvious question is, which approach should you use for your application? Now, I think throughout the course you saw that using Expo in general is an awesome development experience. Everything is super fast, it's easy to test changes, both on simulators and real devices. You don't need to build locally, therefore you can also build and test for and on iOS, on Windows systems and Linux, which is not possible without the managed workflow. And that's all pretty cool. But when we compare Expo to non-Expo setups, and with non-Expo I mean both creating it with React Native CLI or using a bare Expo workflow, then of course we have to compare all the things. So as mentioned, with Expo, with the managed workflow, it's easy to use that, easy to develop. Non-Expo means more manual setup, and so on. Now, you also will have an easy time deploying your app, as you will also see in the deployment section, and you can even build and deploy for iOS if you're on a Windows or Linux machine, something which is not possible without the managed workflow. So there you have some restrictions there, and deployment, as you will see, also takes more manual work, like the non-Expo workflow does in general. When in the Expo managed workflow world, we also have a rich suite of native modules, so all these Expo APIs, which are always easy to use, just a Expo install away, don't need any setup, so that's really amazing, and you got pretty much everything you could want in a native app there. Camera, location, file system, it's all there. If you sometimes need something which is not supported though, or you need to write your own native code that you want to connect to React Native, your own package or whatever it is, then non-Expo is the solution. So there you can use any native code. But of course, you need to set it up manually, and that might be easy with React Native Link, as you saw, or even some auto-linking libraries. But you might also have libraries that take more effort. In addition, it's worth noting that, of course, third-party libraries need to be maintained to stay up to date with React Native and newer versions of React Native, but also they need to stay up to date with Android and iOS, right? Because these platforms also evolve and introduce new features or deprecate old features. The Expo APIs are pretty guaranteed to be maintained because the Expo team is active, is working on that, and it's a whole ecosystem that works together. That might not be true for all third-party packages, so this extra security you get with the Expo packages is definitely pretty nice. That being said, as you saw with the Bear workflow, you can of course also add certain, but not all, Expo APIs to non-managed apps. That is possible, but takes a bit more work. Now, of course, the managed workflow has downsides. It's a wrapper around your app, and that of course impacts both the size and performance. Most likely not in a way that you will feel or see, but it's worth noting there is a thin extra wrapper, and you don't have that in the Bear workflow or when just working with the React Native CLI. And of course, as mentioned, you're restricted to the built-in native modules. There are a bunch of those and probably everything you might ever need. But if you need something else which is not built into Expo, so an API which is not supported by Expo, then there is no way to get it to work. Then you need to eject, because only non-Expo, and with that I mean non-managed workflow apps, support all third-party packages and all native modules you might want to use. So therefore, my suggestion would be that for most apps, pretty much all apps probably, you work with Expo because of the great development experience and the great flexibility you have there. Since you can always eject, there's not much to lose. You can always go back to a non-Expo managed app if you want to, as you saw. Starting with such a non-Expo app, so with a Bear app or even with just a React Native CLI app, is a good idea if you know that you will need a lot of native functionalities that are not supported by Expo, or if you're building a high performance application where every kilobyte of extra wrapping matters, then of course you might start with such an app. But otherwise, I really see no strong reason for why not to use Expo. And especially if you're not working in a huge team in a corporation or anything like that, being able to build iOS apps on Windows too is really a nice thing. So that alone is also a good reason for staying in the managed world. So that are my 2 cents on that. Since you can eject, it's not like you have to stick with one solution if you started with it. Just going back from the Bear or the React Native CLI only setup to the managed workflow is a bit more tricky, because there you need to create a new Expo managed project, copy over your code, and if you did use any third-party libraries that are not from Expo, you won't be able to use them anymore. So switching back can be hard. Switching from Expo managed to Expo non-managed, that is pretty easy with ejecting.